The network and system security module of TryHackMe is a really big one, and it helps us explore the principles of network and system security, meaning using secure protocols, hardening or securing an operating system, the various cloud security measures and network devices that we can secure throughout the cybersecurity environment as a security engineer. The first video is going to be the securing network architecture, where we understand how to implement security best practices for network environments. The next one is the Linux system hardening, where we go into securing and hardening a Linux system. Then we have the Microsoft Windows hardening that takes us into the various security measures that we can take to secure a Microsoft system or harden a Microsoft system. And within Microsoft, we have Active Directory. So then we go into securing Active Directory within the Microsoft environment. And of course, network device hardening. And this could be anything like IoT devices or essentially any other type of device that would be considered a network device and how to secure those things. And then we go into network security protocols. And this is the various layers of the OSI model and what it means to use various protocols to secure a network in its entirety. And then we're going to be talking about virtualization and containers, which is a very big deal, especially in the cloud environment as we go further into the cloud environment and all the technologies that are involved, especially in the future. And then we're going to go into cloud security specifically, so that we can understand what it means to secure a cloud machine or a cloud environment. And finally, we go into auditing and monitoring, which is a subject that you're going to run across all the time. We've covered it several times, multiple times in our channel so far, and this is not new, but we're just going to be looking at it from the security engineer perspective. This video is sponsored by SurfShark, which is an all-in-one antivirus and VPN solution that you can use to secure unlimited devices. And this could be your mobile devices, it could be your personal devices, and everything else in between. And you will get access to the unlimited antivirus and VPN for literally 7 cents a day, which ends up being $2.20 per month. And it's one of the greatest solutions that exists on the market right now. So to get advantage to that pricing, go ahead and use the link in the description below and secure all of your devices today. And without further ado, let us jump into the network and system security video. All right, what's going on? It's your boy Hank Hackerson at Hank Hacks Hackers, and we are continuing down our security engineer pathway today. This is going to be episode 9, which goes inside of the network and system security module of the security engineer pathway of TryHackMe. And today's room is called the secure network architecture. And this is what our outline for today looks like. So we have the intro, network segmentation, common secure network architecture, network security policies and controls, zone pair policies and filtering, validating network traffic, addressing common attacks, and the conclusion of the room. All of these things are going to be timestamped in the description below, so you can bounce around and check out individual portions if you want to. But apart from that, this is literally what we're going to be talking about today. The first specific room of network and system security on episode 9 of the security engineer pathway. If you are studying for your security engineer or security analyst, Pentest Plus, ethical hacker, any of those things, then I do encourage and invite you to like and subscribe and turn on the notification bell so that you get notified the next time that a video comes out from this channel. There's also the SOC Level 1 playlist that already is completed, and that's for the junior security analyst, and just a lot of really, really good stuff for security analysis that you can find that on our channel. And then there's the Pentest Plus. It's not complete, but there's a good number of videos. I think there's maybe like 30 something videos in the Pentest Plus playlist. And yeah, so that's kind of where we're at right now. So all of these things will actually be directly applicable to your certification exams, because I did take my CYSA and it was directly applicable to everything that was covered in that examination. So I know it'll be useful to you in there, but it'll also be useful to you in your day-to-day job as an analyst or an engineer or anything of the sort. So I think you will definitely get a lot of value from this channel. And then just for me, it would be really awesome to have you as a part of the community so that I can see, just help grow the community. And if you have any questions, you can drop them in the comments. I'll answer to them. I love our community. It's been a very, very fun process to do all these things. And it's nice to see that people are finding value from it. And, if I can help you, I'll definitely answer all your questions and try to even make videos for you. So that is it. And without further ado, let's jump into the introduction of the secure network architecture room. There's not really much going on in the intro here. So networking is obviously one of the more critical components of the corporate government enterprise type of environment. And from a security standpoint, it can be overlooked typically because we're so focused on softwares and maybe even users or systems or something like that. Nobody really, or few people look at the network itself as a whole. So if you have a really well designed network, then not only do you actually get internet service, but you also get redundancy, optimization, and security. A lot of network appliances like Cisco routers and Cisco switches and stuff like that, they come, especially if you get like the really fancy ones, the expensive ones, they come with a lot of good security embedded in them that kind of prevents a lot of hacks to take place if those things didn't exist. So if a switch goes down in a good network, if a switch goes down, packets can be redistributed through another route with no loss in uptime. If a web server is compromised, it cannot traverse the network and access important information. So a system administrator should be confident that their servers are secure. If a random device joins the network, so you got to keep track of all of your devices, right? So if something gets plugged in or if somebody shows up in your list of devices, you should know what's going on and then immediately go and find that. And this is something that's like a big deal, obviously, in the military environment and the government environment. If you plug in a wireless access point that is not supposed to be a part of that network, within minutes, they'll come and find it and destroy it or arrest you or whatever. So these types of things are really important, right? So everything is what we're going to be talking about in this particular room has to do with these objectives specifically. But it's a big one. This is one of those big conversations that we're not going to cover everything inside of this room, and we're going to probably look at some surface level stuff inside of this room. So we're going to be going through principles of secure network architecture, implement common security, network security concepts and protocols, and understand the environment and potential threats to a network. You do need to know a basic understanding of networking terminology, so I do recommend you go into that. I don't have any videos on that, but there's a lot of good stuff out there. And so if certain things don't make sense to you in this video, feel free to just pause the video, do some Googling, and read up on it so that everything else can connect for you and make sense. So there's our intro, and let's jump into the network segmentation. All right, so the need for secure segmentation. There's a few different things that you need to be aware of when it comes down to network segmentation, segments of a network. So let's consider a particular scenario that would help us kind of understand what a subnet seems to be and why we need to segment our network and so on and so forth. So let's say that you have a client that brings their own device. It's called BYOD, bring your own device. The client's device was infected with a remote access Trojan that will attempt to traverse the network when the device is connected to and exfiltrate any sensitive information. So with subnetting in place, there's no restriction in place that the infected device there's no restriction to prevent the infected device to connecting to other things and routing or finding your different portions of your network and stuff like that. So it leaves sensitive information and computers and servers and everything open to whoever this unknown device is that this person just brought them in. So how do you fix that? There's something called a virtual LAN, a VLAN, and it's used to segment portions of the network to at the layer 2 level, which is the IP address level. Or no, I'm sorry, layer 2 is actually the MAC address level. At the layer 2 and differentiate devices, right? So VLANs are configured on a switch by adding a tag to a frame. 802.1q, a .1q tag will designate the VLAN and that the traffic is originating from. So this is the Ethernet data frame that you'll see right here. And then the VLAN data frame that has the VLAN tags that will get associated with it. So the 802.1 tag provides a standard between vendors that will always define the VLAN of a frame. For example, if our switches are Cisco and the routers are Juniper, then they can send tagged frames and digest them equally because it's standardized, meaning it's uniform across, doesn't matter what brand equipment you're using. So we're going to go and configure these things. As an example, we're going to go and configure these things. So we're going to use the open source switch, which is Open vSwitch. And from Open vSwitch, I'm just going to open it up inside a thing right here. I wonder if I have to download this. Let's see if we can just kind of see what the whole thing is, and maybe they'll have it available to us later on in this room. So first, we're going to look at the default configuration of the switch. So you do, once you're inside of your command line, you do OVS VSCTL show, and then to add one, you can just go and do set port, the interface, and then any kind of a port number. The tag should now be listed under the sub interface in the configuration. So if you go to the port ETH1, and you'll see a tag 10 attached to interface ETH1. So now we have the first interface configured, and we can do it to tag their frames. So if we don't know where the VLAN traffic originates from, for example, traffic from the virtualized device or the network, what do we do in that situation? So tagging unknown traffic. So the native VLAN is used for any traffic that is not tagged and passes through a switch. To configure it, we have to determine what interface and tag to assign to it, and then set that interface as the default native VLAN. So this is what that would look like in the command line. So you set a port for this interface, tag is going to be 10, VLAN mode is native, and it's untagged. So now all the traffic that goes through that should be tagged, even if it doesn't have known origins, even if it's unknown. So routing between VLANs. So what's the capacity, or how does a VLAN connect to the internet or other resources in other VLANs? So since they're segmented, they can't communicate outside of their tagged devices. So since routers are used to communicate between traditional networks, you can use routers to route between the different VLANs. So it's not that complicated, right? Before all the fancy stuff that exists nowadays, network engineers would physically connect a switch and a router separately for each VLAN. Nowadays, we can do it through ROAs, so a router on a stick design. And so VLANs are configured to communicate with a router through a designated interface, and then that specifically is called a switch port. So a designated interface of a switch is called a switch port, basically a little hole in the back that you plug your Ethernet cable into. The connection between the switch and the router is known as a trunk. So a trunking protocol is what you hear very frequently. So the connection between the switch and the router is a trunk, and then that trunk goes out of the switch port and it goes to the router. And if this is done physically through the wire, right? VLANs are routed through the switch port, requiring only one trunk or connection between the switch and the router. Hence it's called on a stick. So before configuring the router, we have to configure a trunk on a pre-existing connection. And in our demonstration environment, trunks are configured by the default as bridges. So a trunk can also be referred to as a bridge. So this might get a little bit complicated, but just kind of try to keep track of these terms, right? So each vendor configures their trunks and switch ports differently, and some even with proprietary protocols. So you would have to go look at their individual documentation to try to figure out what their protocols are and how they configure their trunks and their switches. This is what we would do on the OVS. So you would do add BR and then BR0, add port for BR0 on this interface, and then tag 10. And now we can configure our router to route tagged traffic between VLANs. And as mentioned, we can introduce tags because 8021Q tag is standardized, and we only need to tell our router how to configure its switch port that belongs to just that router, and then what tags to accept for that interface. Because all the tag traffic comes from a single connection, the router has to be able to keep each tagged frame separate because it's all coming from one connection, and it should, otherwise it would get they would clash each other. I forget, I think it's called broadcast clashing or something like that. I forget the specific terminology, but so this specific action right here, so since it needs to be able to keep everything separate, that's accomplished using virtual sub interfaces. And this is going to act very similar to a physical interface, but it's just virtual. And so that is called its ID. So the VLAN's ID is its sub interface. And the syntax for that is the name of the VLAN, and then, or excuse me, the name of that specific sub ID, the sub interface. And then you have the VLAN sub interface ID. So you have its name and then its actual ID that's attached to it. In this example, we're going to be adding a new virtual subinterface and configuring the addressing for it. We're going to be using Vios, and let's go and check that out. And this is Vios. It's open source. There's a buy now, but it should be open source based on what they just declared over here. So maybe ever since they made that, it became a paid resource. So you have, Vios set interface Ethernet on this interface, VIF 10 description, yada yada. Interface Ethernet, same thing. The address is that, and then notice that they did 1/24 to say that it were going on this particular subnet, and then there's 24 bits, I want to say, because 24 bits, because each byte is 8 bits. Yeah, I think it's bits. If all went well and was well configured, we should be able to route traffic between VLANs while keeping traffic tagged and isolated. So are they really isolated though? They are physically, but because routes exist between them, there's no security boundary. So that's where all of this is how it all connects to security engineering, right? So they're physically isolated, but because there's routes between them, meaning they can communicate with each other, there's no security boundary, and they're not necessarily isolated. So as long as a route exists between those two VLANs, they can all communicate between each other. And then we can now talk about what we need to actually talk about for this particular room and this task. So securing VLANs and introducing the concept of zoning. So creating zones for VLANs and what to do if something actually happens inside that VLAN that you don't want it to go into the rest of your network. So analyzing the configuration, this is what it's going to look like. This is apply what you learned to analyze the configuration given in this output below. So we have this whole thing right here, and you have the ports on the different interfaces with their tags, and then at the bottom we have the bridge BR3. Okay, so how many trunks are present in this configuration? So let's see that. So being that a trunk can also be referred to as a bridge, we have one bridge, two bridge, two bridges, three bridges, and then we have 4 bridges. So that would be 4 trunks. And then what is the VLAN tag ID for ETH12? So ETH12 right here, port ETH12, the tag ID is 30. And there is that. So fairly straightforward. I mean, we don't need to know all of the in-depth stuff behind all of this, but you do need to understand that a bridge is technically a trunk. In this particular case, we have 4 bridges or 4 trunks, meaning that there's 4 VLANs, and inside each one, there's a particular interface. Inside the BR0 right here, there's way more than the rest of them, so this is probably the busiest part of their network, so on and so forth, right? So not overly complicated to understand. There's a lot of jargon and there's a lot of technical data that they shared with us because it's important for us to know these things, because even if you are in security, you still need to understand networking. So that part's very, very important. But that's neither here nor there. So next piece is going to be the common secure network architecture. With the introduction of VLANs, there's a shift in network architecture design to include security as a key consideration. So this is where we come in, right? So security optimization and redundancy should all be considered when designing a network, ideally without compromising one for the other. This brings us to a very important question. How do we properly implement VLANs as a security boundary, which is now going to bring in security zones and zoning? Security zones define what or who is in a VLAN and how traffic can travel in and out of that VLAN. Depending on who you speak to, every architect in a network may have a different approach to the language or requirements surrounding security zones. We're going to talk about the most commonly accepted security zone standards, and then thankfully we're going to be looking at it in a minimalist approach. And this is, by the way, consider the fact that they think that this is minimalist, right? So this is the table of commonly standardized zones, and the zone, and then the explanation of the zone and an example of the zone. So you have external, which is everything outside of the network or asset control, devices connecting to a web server. Demilitarized zone, you'll hear this a lot, DMZ, a demilitarized zone. It separates the untrusted network from the internal network. So our demilitarized zone can be accessed by the public without any kind of login or any kind of special credentials or anything like that. And that would be a remote user or a guest, a public server, right? It's available to the public, BYOD, bring your own device. You have the trusted zone. So internal networks or devices, they've been placed in the trusted zone if there's no confidential or sensitive information. So that could be a workstation or a B2B, business to business communication. You have restricted, which is a high risk server or database, which is your domain controller, right? Or information, or a database that has client information on it. So nobody should be able to access that except key people inside of the organization. Then you have management, that belong to, these are basically any device or service that belongs to the management department. It's less commonly seen, and can be grouped within the audit zone, which is the very next one right here. And so virtualization management, backup servers, all that stuff. And then you have the audit zone, any device or service dedicated to security or monitoring, and it's less commonly seen and can be grouped with management. And that could be a security information and event manager. Telemetry. Ooh, I've never even heard of that. I mean, I have heard of it, but I have no idea what it is. So maybe we'll talk about that in a little bit. While security zones mostly factor in what will happen internally, it's equally important to consider how new traffic or devices will enter the network, be assigned to the network, and of course, interact with internal systems. Most external traffic, so HTTP, which is internet traffic, mail, right, email, they stay in the DMZ, the demilitarized zone. But what if a remote user needs access to an internal resource, and we need to easily create rules for resources that a user or a device can access based on their MAC address, their IP address, or something like that. And we can then enforce those rules from the security controls inside of the network, and we're going to be talking about that in the next task right here. So you have external and wireless is everything like a regular person, or this icon right here represents a hacker or an attacker. And then you have, from the external wireless network, there's a firewall right here. And then you have the demilitarized zone that has the stuff that you can use that can be publicly viewed. But again, there's a firewall between this and the trusted zones, which is could be your Linux server, it could be any kind of web server, it could be your workstations, anything like that. And then you have a final firewall, which is going to the restricted zone, meaning these are the people that, or this is the zone that only domain controllers or domain administrators or executives, all those people can access. So with each level, there is another firewall and another firewall and another level of security that this particular person, this hacker right here, they would have to go through to be able to get access to what's going on. So security zones and access controls will physically direct how and where traffic goes. But how is it decided what resources users or devices have access to? Traffic rules are often governed by company security policy or compliances equally as security controls that determine their permissions. So we've established a system to approaching the design of a VLAN, but how can we practically implement this? So that's what we're going to talk about in the next task. So from the above table, what zone would be a user connecting to for a public server to be in? And so this is probably going to be either the external zone or the wireless zone. So let's try external. And that's not it. So let's try wireless. That's not it either. So what zone would a user connecting to a public web server be in? Didn't I type in external? Maybe I misspelled external or something? But yeah, it is external. I mean, what the hell? Anyways, from the table above, what zone would a public web server be in? So a web server would be the public server right here. So it's a DMZ, a demilitarized zone. There you go. And from the above table, what zone would a core domain control? That would be restricted. I already know that. Restricted. So there we go. We have our zones, and we can kind of understand some secure network architecture. So let us now go into the security policies and controls for these things. So how do you enforce secure architecture design, right? If there are routes between VLANs and they're supposed to be separated, how is it possible and appropriate to access restricted stuff? Or how do you restrict access? Or how do you grant access, right? Policies, basically. They aid in defining how network traffic is controlled. A network traffic policy can determine how and if a router will route traffic before actually routing it. IEEE, Institute of Electronics Engineers, has standardized a handful of access control and traffic policies, such as quality of service, and there are many other routing traffic policies, obviously, that aren't standardized by IE, but they're commonly used by a lot of vendors, right? So we're going to be focusing on traffic filtering and introduce network policy concepts. So traffic filtering. Before defining what a traffic filter is, let's discuss what one of the more common standards is, which is access control lists. So an ACL is used as a loose standard to create a rule set for different implementations and access control protocols. We're going to use ACLs within a router to decide whether to route or drop a packet based on the defined list. And ACL contains ACEs, the access control entry, or rules that define a list profile based on predefined criteria, source address, destination address, MAC address, probably a bunch of stuff like that. Once defined, we can use the access control list for several vendor-specific implementations. For example, Cisco uses ACLs for traffic filtering, priority or custom queuing, and dynamic access control. Traffic filtering provides network security, validation, segmentation by filtering network traffic based on predefined criteria. And so now we've defined what traffic filtering is. So let's look at ACLs, how to implement an ACL and traffic filtering. to do this hands-on, we're going to look at BIOS again. And the access list policy is the platform's most basic implementation. So it's going to be broken down into a few things. First, we're going to create the new access list, define the ACL number. So you set the policy access list, and then you give it a number between 1 and 2699. Then you set the description of it. So set policy access list, the number that you've assigned to it, and then give it the description. And then you use the description option or parameter, I guess, and then you give whatever the description is supposed to be. Then you create a rule for it. So now you have the same thing, access list, the number. Now you have a rule for it and the rule number. And then here's the action that the rule allows you to do. You either are permitted to do something or you're denied from doing something. Then you set a criteria for parameters for the rule to actually enforce or match. And this is where it comes into, so, this is the rule, it permits, and then this is the list of destinations that are permitted, or the list of sources that are permitted. And would it be anybody? Is it a specific host? Is it an inverse thing? Is it a network that gets access or, is permitted, right? So now we have an ACL, access control list, and an ACE that is actively being enforced by the router, right? So you have the access control entry that is assigned to an access control list, right? So the ACL is defined as the ACL number, and it's made of separate rules for the entry that describes the behavior of that. And each entry can determine the action, the destination or the source address, and the specific address range to trigger that entry. And this is what it would look like. This is a valid SSH request being permitted by the list. So the IPv4 source address is this, destination address is this. So literally same freaking thing. TCP is the protocol that's going to be used. Checksum is this, validation disabled. Header checksum is unverified. The source is 12.209, 12.209, or 212.209. Transmission control, source port 35560, destination port 22, sequence 1578, acknowledge 1670, length is 148 bits, source port 35560, destination port 22, right? And then so these are the actual commands that go into. So set the policy for access list 1, rule 1, action permit, and then set the policy for access list 1, rule 1, that the source IP is going to be 10.10.212.209, okay? Now this is what a denied list would look like. Basically, everything that you saw previously, the destination port in this case is going to be 2 instead of 22, but pretty much everything else is exactly the same that you just see right here. And then what we see as a command is that now it's going to be a deny action instead of a permit action, and exactly the rest of it is exactly the same. So if implemented correctly, the router should now drop or accept packets based on the source to destination address. Is it the best solution? If we want a public server in DMZ and be able to ensure that only HTTP traffic originates from it, what do? So what is the specific host that needs specific protocols to be open on a server? And the router can only provide a limited number of extensibility for security. So now we need to address that specific scenario, right? So first we got to answer some questions down here. So it says below is each packet. So we see that we have a structure of an access control list and what it would be like for in a packet. And we're going to analyze a few packets to determine if they will be accepted or dropped. So each packet, we have it right here, required. There's a ACL that's attached to it. And then we're going to answer these questions. So according to the corresponding ACL policy, will the first packet result in a drop or an accept? So this is our packet. Okay, so 22, all this stuff is very simple. So this is the access control policy. It says, is it going to be dropped or accepted? And so it's permitted, so it's going to be accepted, right? So accept is permit. Based on the second one, is it going to be dropped or accepted? So this is the packet. And then so let's look at, and then you see deny. It's it's pretty straightforward, right? So it's going to be dropped. That's it. Very, very simple. So now we got our understanding of security policies and controls for the network. So let's go look at zone pairs. So a zone pair policy and the filtering of the zone pair. And we actually have a website attached to this. So let's see what that's going to be like. All right, so we looked at security policies and controls. Now we need to look at zone pair policies and how those things get filtered. So a traffic correlation is standardized as the state of a packet. So what is the protocol, the process, the direction that it's going from where to where. We must employ a firewall to parse the state of a packet and enforce the policies based on that state. So a firewall, basic network firewalls, they do two things. They're stateless or stateful. The category is determined based on the ability to consider the state of a packet. For example, an access control list used in that previous task would be regarded as a stateless protocol. A stateful firewall can better correlate information in a connection. So it allows the firewall to filter based on ports, protocols, processes, other information from a device. And for this, we can go into the extending your network room, which I don't know if I've done. Have I done this? I think I have. Oh yeah, firewalls, practical firewall, VPN basics, networking devices. So I think this was one of the pre-security or like one of the beginner stuff. So extending the network, introduction to port forwarding, and we have firewalls 101. What is an actual firewall? And then you have the practical that we had to do to capture a flag, and we have the VPN basics and what it actually does using encryption and how it secures a connection between certain things. And you have the what do we have here? This is the LAN networking devices. So the stuff that goes inside of a local area network. So you have your router, you have the layer 2 switch, you have all the computers that are attached to it. Then you have a router, and then you have another switch, and it has two different VLANs now that are coming out of that switch. So it shows us a couple of examples of a networking device, and then you have the network simulator that we had to go through to try to pass data packets or frames from these devices so we can get some access. So I'm not going to go into the details of that. You're more than welcome to go through. Actually, I think this was probably one of the free rooms too. Let's see. It usually tells us at the bottom if this was a free room or not. No, this was a subscriber only room. But you can, just based on what I covered right here, you can probably get some nice information from Google or from Gemini, the Google AI, or some YouTube videos or something like that. So before configuring the firewall, we need to consider how we can apply the requirements of zones to the actual firewall rules. So how can we define different actions based on the protocol and source destination zone pair? So or the zone. So you get a zone pair out of that. So the zone pair is a direction-based and stateful policy that will enforce the traffic in a single direction per each VLAN, hence a zone pair. So for example, a demilitarized zone to the local area network, and then vice versa, the local area network to the demilitarized zone. It's going in just in one direction, right? Each zone is given a topology. Each zone in a topology must have a different zone pair for each other in the topology in every possible direction. This approach provides the most visibility from a firewall and drastically improves the filtering capabilities. So we're going to use VIOS again of configuring a firewall for zone pairing. And before defining the pairs zoning policy, we have to add a common name and default action for each one of them. And we're going to go look at the last two that we were routed through the trunk and divided through the sub interfaces. So the interface.VLAN number is the naming for it. So for example, ETH0.30 is going to be one specific VLAN, right? VLAN ID. So below is an example of setting up a default action for the DMZ and assigning it to the VLAN for the common zone name that we have over here. So set zone policy zone DMZ, and then default action is drop. Then it's going to say the DMZ interface is ETH0. So the zone policy for the zone DMZ is the default action is drop everything, right? And then the DMZ interface attachment to that is going to be ETH0.30. So we're going to repeat this for each VLAN or zone that's been defined in that network. And then before we can begin addressing each one of this, you need to be understanding this particular topology. So you have the demilitarized zone, you have VIOS, which is going to be doing the job that you want it to do. You have the wide area network, and then you have your local area network. And your wide area network is the internet, basically. And then you have your local area network, and then you have your demilitarized zone. And all of this is going to be going through VIOS. So each zone is going to have a corresponding pair to every other one. To define it, we need to write down each possible pair and protocol that we're going to apply. So this is an example for each zone pair in this particular topology and what possible protocols could be looking like. So you have the LAN, the local area network, that has the zone B attachment. So it's the zone B could be the wide area network, the internet, the local network, which is itself, and then the demilitarized zone. And so the protocol to the wide area network is going to be ICMP, and then it's going to be dropped. So the action is to drop that. In its own network, nothing is going to happen. And connecting to the demilitarized zone, nothing is going to happen. The wide area network to the local area network, ICMP protocol, is going to be accepted, meaning that the local area network should be able to access the internet, but the internet should, in this case, it's saying the internet shouldn't be able to access the local area network, but the local area network, in this case, should be able to access the internet. And you have the WAN to local, nothing, WAN to DMZ, nothing, right? And then you have local to the LAN, nothing, local to WAN, nothing, and local to the DMZ, nothing. And then finally, you have the DMZ to the LAN, and that should be through the HTTP protocol, and that would be accepted. Then you have DMZ to the WAN and to the local area network that have no rules attached to them, right? This is it for this particular topology. So it gives us an understanding of the expected behavior and a good plan to begin configuring the firewall. So not all traffic is IPv4. Depending on the network configuration, you may also need to consider IPv6 rules, which have very different looking IP addresses. So because of the default action that we set, any protocol that originate on the network and are not defined are going to be dropped by default. So we're not going to go over each rule set. Instead, we're going to cover one zone pair in each direction and then test that behavior working as, hopefully that it works as expected. So we're going to configure the LAN and the WAN zone pairs. And after the example, hopefully you'll be confident about configuring something, a small topology, a small zone for yourself. So for all VIOS firewall rules, we have to begin by defining the default action and the state rules. And then we're not going to cover the intricacies because that's probably an entire module or pathway just by itself. So instead of repeating 7 commands, we just rely on the VIOS configuration to define the rule. So this is the example. The top of it is going to be the LAN WAN. This is the rule set specifically. So what are they calling it? The configuration. So we have to begin the default action. There you go. The default action and the state rules is what we're doing. This is what it is. So the name of it is the LAN WAN. The default action is to drop. And then enable the default log. And then the rule 1 is accept, state, established, enable, related, enable. Okay. Rule 2 inside of this is drop, enable the log, and invalid enable for this particular state. So anything that's invalid, enable that. Established connections, enable that. Related, enable that. Meaning that all of these things should go under this particular rule. In this particular action, you have these two, the established and related connections should get accepted. And then if it's invalid, then it should be dropped. So enable over here means that enable this rule for this state. Enable this rule for this state, right? And then you add the rule for ICMP. So rule 100, the action is to drop, and then this is the comment. So define the action for the rule. The log is enabled, so enable logging to track connection attempts in BIOS. And then the protocol is IPv4 ICMP, so the protocol to monitor and enforce the action on. And then now we have the first zone pair rule set. Now we can create the rules for the zones from the WAN to the LAN and the LAN to the WAN. So this is the rule set that we had previously. Rule 2, rule 100, this whole thing is our rule set right here. So now we can move into the zone pair. So the zone pair is now, do we have it? Oh no, you know what? It's it's actually, it was added to the piece right there. So it's under rule 100, which is the action IPv4 yada yada yada. This was the actual zone pair rule set. So this is the zone pair rule set. This is what the completed version looks like. That's what we're looking at over here. So there you go. Zone pair is now defined with appropriate actions and steps, and we can combine the rule set with previously configured zones. So at the beginning of this, we configured zone policies with the corresponding interface and zone name. So we have the zone policy for the zone, which was the zone A, from zone B, and then firewall, the name of the firewall, and then the rule set name. So we're going to set the pair for the LAN WAN and WAN LAN pairs. So set zone policy zone LAN from WAN, firewall name LAN WAN. And then set zone policy zone WAN from LAN, firewall name WAN LAN. And we have the official first pair of this, right? So to test the configuration, we can just send a ping in both directions to ensure that the firewall is dropping or accepting the packets that you need. And creating something from scratch, it just requires that you pre-plan everything before you start putting the commands into the interface, the command line interface. So we're going to do this live in this particular situation through the view site exercise at the very top. We have our source, the DMZ, the LAN and the WAN, destination, and then the protocol, so on and so forth. So we need to configure our whole thing and then capture a flag at the end of this. So I am now going to click the view site button, and it's going to open this up for us. Reduce the configuration as the visualize packet flow. It will help you set up the correct configuration to get the flag. So what's our tutorial? Please select a blank to view its corresponding options. Okay, next. Please select the blank to view the corresponding options. As soon as a blank is selected, you can choose an option here. Okay, next. And then once the blanks are filled, you should run the workflow to see whether or not it works. Next. And then what is this? We have the visualization of the packet flowing in the diagram. Okay, so DMZ to WAN. This is kind of what it looks like, I guess, at this point without anything happening. So zone policy, zone, where are we at? We're at the bottom right here. And set zone policy zone, and then the action that you want, and then the zone policy zone, so on and so forth. So in this particular case, we have the DMZ, which is going to be the source, destination is LAN, HTTP protocol, accept is the action, the default action is dropped. So set zone policy here, it's going to be DMZ, and the default action should be drop. So the zone is going to be DMZ here. The default action is going to be drop, and then go back here. And so DMZ connecting to the interface is ETH010 right here. So ETH010. And the next one again is going to be, now we're going to look at the LAN in this particular case. And the default action for that is going to be drop, and the interface for the LAN that needs to connect that to is going to be the ETH020. So we're going to go here and click that. So that's our first set of rules right there. And then so the set firewall name in this case, DMZ LAN. So DMZ LAN, DMZ LAN. There we go. And the description in this particular case is going to be, I guess, DMZ LAN still, right? So DMZ LAN. Set firewall name for the next one is going to be the DMZ LAN, which is the one that we just did. So DMZ LAN, and then the default action is going to be to drop, because that's basically all we're doing here, it seems like. The next firewall name is what we need to do is the DMZ WAN, right? Rule action, no, so DMZ LAN, I have 52 seconds. We'll do DMZ LAN. Rule 100 action is going to be Rule 100 action. Rule 100 action. So it's not the default action, it's the Rule 100 action. So I'm going to do accept. So that's that. And then so the next one is going to be DMZ LAN, and Rule 100 protocol in this case is going to be HTTP. Run it. Okay, interesting. So it gave us the thing right here. So it gives us the DMZ to the WAN now. That's probably going to be the next one that we have to do probably. And that one gives us another few minutes to run this thing, but it said DMZ LAN, what, it changed it. DMZ WAN, changed it again. DMZ LAN, or it changes by itself? Yeah, it is changing by itself. Okay, so HTTP is greenlit, TCP is not greenlit. It's blocked. That's what the current stuff is. So that was our setup right here. So you do the set policy zone itself. So it's from to where it's coming from first, and then what's the default action. So the DMZ default action is drop. The policy zone is from the DMZ to ETH010. And then that's the interface. And then you have another one that is for the LAN. So the LAN right here, the default action for that is also drop. And then the policy zone interface for that one is ETH020. And then you have the firewall name at this point that we had to set up, which was just the DMZ to LAN, which there's no indication here, but based on what they showed us in the previous example right here, that's what they did basically. So wherever it was coming from, or wherever it's going to coming from, so its zone is LAN WAN, so LAN WAN, and then zone is WAN LAN, WWAN LAN. That's the way that they did it. So if we're doing DMZ LAN is the entire setup for that, so it would be DMZ LAN for the firewall name for this whole thing. The description, DMZ LAN, the default action is drop for everything. The Rule 100 action, which is different from the default action. So the Rule 100 action was the accept part right here. And then DMZ LAN, being the specific one that we're dealing with over here, needed to be with the protocol for HTTP. So that's how that whole thing was set up. So that is that specific task for zone pair policies and filtering. So let's now go to validating network traffic. And I think is that another one that we do? No. So this is I don't think this has to do with a view site anymore. So let's look at validating network traffic now. The scenario here is the organization has proper zoning and routes in place. A zone pair between DMZ and LAN allows the HTTPS connection. Of course, the firewall should accept those connections. So how is Susie supposed to watch Facebook or Azure updates install, right? How could any of these things actually happen? So there's a threat actor that has landed an implant through phishing on a LAN machine. Assuming host defense mechanisms have failed, how can the implant be detected and monitored? If the beacon for the threat actor is using HTTPS through the DMZ. That would look primarily like legitimate traffic to the firewall and the analyst. So to solve this, we have to use a SSL TLS inspection to intercept the HTTPS connections. SSL TLS uses the SSL proxy to intercept protocols, including all of this stuff, or the other encrypted traffic. And once it's intercepted, the proxy decrypts the traffic and sends it to be processed by a unified threat management platform. The UTM will employ deep SSL inspection, feeding the decrypted traffic from the proxy into other services on the UTM, including but not limited to web filters or the intrusion prevention system to process that information. It seems ideal, but there are downsides probably. So some may have already noted that it requires an SSL proxy or a man-in-the-middle attack, right? So if a firewall or a vendor has already implemented the solution, it will act as a man-in-the-middle between your devices and the outside world. And what if it intercepts potentially plain text passwords? A corporation has to assess the pros and cons of this depending on the calculated risk. And you could allow all the applications that you know that are safe to prevent potential cons, but the solution will have disadvantages. An advanced threat actor could route their traffic through a cloud provider or a trusted domain. So it's not it's not foolproof, right? And we talked about this a few times in the last videos as well. There's nothing that's 100% foolproof. You can get pretty close to secure, but there's going to be certain things that you may have to either just accept the risk for or find other ways to get a workaround for it. The question is, does SSL inspection require a man-in-the-middle proxy? And the answer for that would be a yes, it does. What platform processes data sent from an SSL proxy? And that's going to be the unified threat management platform. So this was, it's an interesting concept. So validating the network traffic needs to go through an SSL proxy and get processed by a unified threat management platform. And those things connect to a bunch of other things. For example, your IPS, Internet Prevention System, or Intrusion Prevention System, Internet Prevention System, the Intrusion Prevention System to actually process that information. But again, it has downsides because somebody can go through whoever your man-in-the-middle proxy is, and it could be a cloud provider. So if you say that a cloud provider is allowed to use or is allowed to pass traffic through here and we're allowed to access that, all the threat actor has to do is go through that same cloud provider, and now it looks like it's legit. So you need to put more rules on top of your rules. Like this is not a one and done type of a configuration. There's several layers to your security that need to be implemented for all of these things to work. And as you can imagine, it'll get fairly complicated, right? So this is, again, it's like this is an introductory concept to, or introductory overview of this concept. So let's look at addressing some common attacks here. Cisco defines DHCP, Dynamic Host Control Protocol, DHCP snooping, as a security feature that acts like a firewall between untrusted hosts and the trusted DHCP server. So DHCP server was introduced to combat rogue DHCP servers, and it's going to validate and rate limit the DHCP traffic as necessary. If a host is untrusted, the traffic will be filtered and rate limited. Although DHCP is a layer 3 protocol, dynamic host control protocol that deals with IP addresses, DHCP snooping operates on the switch layer, the switch at layer 2. The switch will store untrusted hosts with the least IP address, least as in not less than, least as in rented. So this switch will, the switch will store untrusted hosts with least IP addresses in a binding database, a DHCP binding database. The database is used to validate traffic and can be used by other protocols such as the ARP inspection. We'll cover later. We know how DHCP snooping will gather and store addresses, but how does it determine what to do with that traffic? The list of conditions of the protocol will inspect to determine if a DHCP packet should be dropped. This is it. So any DHCP packet is received from outside the network. The source MAC address and DHCP client hardware address don't match. DHCP release or DHCP decline packet is received on an untrusted interface that does not match the interface, that the secure address, that the source address has already been registered. And then the DHCP packet that includes a relay agent that is not I think that's what the domain gateway address typically looks like. It's like 0000 or 1111, something like that. So any packet is received from outside of the network. The source MAC address and DHCP client hardware don't match. So the source MAC address that is coming from this packet doesn't match the client hardware that we have on file. That's why it's called snooping. Snooping basically means that they've changed those things. And so if the release, or not if the release, a release or decline packet is received on an untrusted interface that doesn't match an interface that the source address has already been registered. So that's what this basically means. And then the packet that includes a relay agent address is not 0000. So these are the rules, right? These are the list of the conditions that the protocol will inspect to determine if the packet should be dropped or not. And so if any of these things are triggered, then most likely it's going to be dropped. So recognized by IE in several research papers, there is no standardization of DHCP snooping. That said, it generally does not change between vendors, unlike other protocols. Dynamic ARP inspection. So Cisco defines ARP inspection as a security feature that validates address resolution protocol packets in a network. ARP inspection will validate and rate limit ARP packets as necessary. If an ARP packet's MAC and IP address don't match, the protocol will intercept, log, and discard the packet. So ARP, address resolution protocol, works with MAC addresses, and then it connects the MAC address to an IP address, and that's how the whole thing gets filtered out. So ARP inspection uses the DHCP binding database filled from DHCP snooping as its list of binding IP addresses. So the DHCP binding database provides the expected MAC and IP address pair of the untrusted hosts, and the ARP inspection will compare the source IP address and the MAC address to the binding pair. If they're mismatched, it's going to drop the packet. So DHCP provides the MAC and IP of the untrusted host. ARP inspection compares those two to the binding pair that it has, and if they're mismatched, then it's going to drop the packet. This is the diagram showing a valid ARP request that matches both the binding and request information. So address resolution protocol, it's a request, hardware type, Ethernet, protocol type, IPv4, size is 6, protocol size is 6, opcode is request, the MAC address of the sender, right? And then the IP address of the sender. The target MAC address is nothing because it doesn't have anything in its database yet, and then the target IP address is filled in. And so that is going to turn into this. So all of that turns into this. You have the MAC address that you do know with the IP address that you do know, and then the lease, the number of seconds. DHCP snooping is the type that is going to show up for your security appliance on the VLAN that has the ID of 10, gigabit internet 1, right? And then this is the MAC address and the IP address, lease DHCP snooping the ID of 20, gigabit internet 2. So this particular case is showing the valid ARP request that matches both the binding database and the request information. So in this case, this is, I guess, all valid right here. And then from here, the diagram showing an invalid ARP request. So you have the MAC address. So everything else up until this point is the same. You have the MAC address that in this case is missing some information. In this one, we actually had a filled in MAC address from what it seemed. Or maybe this is actually the MAC address in its entirety. This is the IP address that's attached to it, and that's the same IP address. And then now there's the IP address of the target, and it didn't serve well, so it was then denied. And DHCP snooping is still the type that came through with this. So really the only thing that I can see that is a difference between these two, and this, I don't think there's supposed to be a difference that we're supposed to pull. It's just that they're showing that this is what it looks like when it doesn't work, or when it is unverified, or what is it? Invalid. An invalid ARP request that does not match the binding database and requests information. Note the sender MAC address has been spoofed. So this was what I thought was going to be the case. So this just doesn't seem like a right MAC address, because the MAC address is supposed to be this, and this does not represent that. So the actual MAC address over here, this is the one that was valid. So this was the actual MAC address, and this is what it's supposed to be. Whereas in this case, this is what it's supposed to be, and this is what came through. So it's been spoofed. So I actually did have it right at first glance. I gotta pat myself on the back for that one. Where does DHCP snooping store the least IP addresses from the untrusted hosts? It is going to be inside the DHCP binding database. That's where it stores it. So we're going to paste that over here, and my keyboard needs to connect. There we go. Will a switch drop or accept a DHCP release packet? It's going to drop it. Does dynamic ARP inspection use the binding database? Dynamic ARP inspection. Does it use the binding database? ARP inspection uses the DHCP binding database. So that is a yes. Dynamic ARP inspection will match an IP address and what other packet detail? And that would be the MAC address. And there we go. And we got our addressing common attacks task done. And that was it for securing network architecture. And there's nothing really in the conclusion other than just what we went over. And to continue exploring this, we're going to go through network security protocols, which is going to be is it down the line here? Network security protocols, yeah. It's inside the current module that we're going to be dealing with, but let's not jump ahead here. So we have completed 8 today. This is episode 9 that we're on, and we just wrapped that. So episode 9 in the bag. If you are studying for your security engineer, SOC analyst, Pentest Plus, security analyst, ethical hacker, any of those things, I do invite you and recommend that you actually like and subscribe and turn on that notification bell, because all we talk about on this channel is cybersecurity, ethical hacking, pen testing, engineering, all that stuff. And all of these things are going to be applicable to you for your studies and your certification exams, as well as your day-to-day job in any of those roles. And on top of that, just as an extra bonus for me, it would be really nice to have you as a part of our community. And I do my very best to make sure that I post consistently and answer all the comments to just make sure that you get as much value as possible as being a part of our community. So it would be awesome to have you, and I think you'll actually get a lot of value from it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. And, love, peace, and chicken grease. If no one else loves you, Hank loves you. Hope you enjoyed this one and you got a lot of value out of it. I will see you in the next video. Peace. Physical security, file system partitioning and encryption, firewall, remote access, securing user accounts, software and services, update and upgrade policies, audit and log configuration, and the conclusion and some final notes. And you're going to find the timestamps of all of this stuff in the description below if you want to skip around or get into a specific part in this particular room. And that's about it for that. As per usual, if you are studying for your security engineer or SOC analyst, security analyst, pen tester, ethical hacker, any of those certifications, I do encourage you to like, subscribe, and turn on that notification bell because all we talk about on this channel is cybersecurity and pen testing and ethical hacking and all that good stuff. And so everything that we talk about is actually directly applicable to your day-to-day studies as well as your day-to-day job for any of those roles. And you can use this information for your certification exams as well as what you're going to be doing when you become a security engineer, for instance. So we would love to have you as a part of the community, and I think you'll actually get a lot of value out of it. All right, without further ado, let's jump into the intro of our room here. It does require that we start the attack box because I read a little bit further in advance before I started this, so I just started the attack box because we needed a couple of minutes for it to run, and then we have a victim machine that we've already started up here as well, and it's a Linux machine, as you can already imagine. So let's first talk about the introduction of this particular room, what we're going to be doing. So Linux is obviously a very, very well-known service and platform, and it has a lot of things that would be, I guess it's called a alternative to the closed source system. And a closed source system is something like Microsoft Windows Server or Unix, which belongs to Mac and Apple. And closed source meaning, again, it's closed source versus open source being that you have things that are freely available. So you can essentially go download any version of Linux that you want from the Kali Linux website and install it on any virtual machine that you want. And they don't really have any requirements for you to pay for them or anything like that. So it's open source, right? So it cuts down licensing costs, as you can see right here, and there's a lot of great other benefits that comes with running Linux machine. But if you wanted to just compare the cost of it, the Debian 11 with the cost of hosting a web server using Microsoft Windows, if you can compare those for each of the releases, what does it say here? It's, we can't claim that Linux is always the best choice. However, the best Linux is the best choice for many scenarios. Before this option, we can always focus on securing the Linux system, also known as hardening. The term hardening is very much used in the same breath as securing something. So network hardening, system hardening, all of that is part of securing your environment and your platform and your tools and resources, stuff like that. So these are the learning objectives that we're going to be going through, which is the physical security of your machine, file system encryption, firewall configuration, remote access, softwares and services, updates and upgrades, and of course, logs. It is recommended that you go through a Linux fundamentals video or a Linux fundamentals room, or just do some Googling for Linux fundamentals. Go find yourself a cheat sheet for Linux just to know what some of the commands that we're going to be running are and how to navigate a Linux machine. And we also have the security principles video that is a part of the current pathway that we're on right now. So I've actually made the security principles video, and you can go find that by just searching for security principles inside of the channel content, or if you just go into the security engineer playlist that exists, that this video is also going to be a part of, you'll find the security principles video inside the playlist that we're in. This is the login information for the machine that we're going to be using SSH to log into. And they did make a note that this is actually a very insecure password. Obviously, it's probably on one of the password dictionaries that exists online too. But if we do something like this, it would be very difficult to constantly have to type it and be able to log in. So cumbersome is a good word. So what we're going to do is we're just going to end up using the username TryHackMe at the IP address that is for our victim machine right here, and then log in like that. And then we will get into the room, the machine. So that's it for our intro. Let's go into physical security here. Physical security. So you see this desk and the physical machine and how the desk is shaky. I can't tell if this person is shaking the desk or if they're trying to prevent the desk from shaking because of like a earthquake or something that's happening. It seems like it's kind of an earthquake that's happening. Okay, so in defense in depth, that's a security principle that we dealt with. Um, there's a lot of different layers of it, and physical security would be one of them. So if you want to prevent somebody from gaining physical access to your computer, that's what you have to factor in. That's what you have to plan for. So if they get physical access to your office, it'd be pretty easy to remove the disk drive, right? And then just walk away with it, or just pick up the computer and walk away with it, whatever. Or insert a physical USB drive into your machine and mess around with your machine like that. It doesn't require a lot of technical skill or like cyber ethical hacking, or not technically, I guess that's not ethical. So, pen testing or hacking experience. You just go pick up the computer and you run away with it. One of the examples that I think of is inside Zoolander, when they're like, the files are in the computer. And then he's like, it's in the computer? And then he picks up the Macintosh computer and takes it. And yeah, if you haven't seen that movie, it's pretty funny, honestly. So let's say you've taken the necessary measures to prevent intruders from taking the disk or the whole computer and running out with it, right? So you've ensured that the system passwords are complex or impossible to guess. If they can access the system physically, it's a non-sophisticated task to use grub, which is a Linux bootloader, to reset the root account password. So we have to create, I guess the adage here is boot access equals root access. So if you can reboot the Linux system, then you can reset the root password, which is a big no-no. So we need to ensure that that doesn't happen. So in the unlikely event that physical security is breached, we need to provide extra layers of protection. So basic input-output system is what BIOS stands for. UEFI firmware allows you to add a boot password, and it'll prevent unauthorized users from booting the system. So when they do this grub thing, they won't be able to reset their root password. So that's very, very important. However, this can only be used for personal systems. It won't make sense to use it on servers because somebody else needs to be able to access it. And so if you can't share that, or require someone to physically be present to supply the boot password. So there's a few kind of issues that would come into play if you were doing it on a server or on an enterprise machine. So what we can do is consider adding a grub password depending on the system that we want to protect. And there are a lot of tools that you can use. One of them is called the grub2 mk password, blah, 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 whatever this is. So it prompts you to input your password twice and then generates a hash for you. And the hash should be added to the configuration file depending on whatever Linux system you're in. And then this would prevent unauthorized users from resetting the root password. So it requires the user to supply a password to access advanced boot configurations via grub, including logging in with root access. And so this is the command to run. You enter your password twice, and then it creates a hash of the password. And this one in this case is a SHA-12 hash, as you can tell, or SHA-512, excuse me, which ends up being a very, very long hash, which is pretty secure. So it's important to note that adding a password for grub is not available for these systems that are deployed using cloud service providers such as our Linux machine. So we can't use that for our Linux machine. It doesn't make sense as you don't have access to the actual physical terminal. So that's a big deal. So ensuring proper physical security is a must, considering how easy it is for an attacker with physical access to wreak havoc. Adding a password to grub is a reasonable measure to block users with physical access to a system's keyboard from gaining access. So we need a plan in case an attacker finds a way to steal the disk drives. This is what we're going to probably go into in our next little task right here for file systems. So first, let's answer these questions. What command can you use to create a password for the grub bootloader? And it's this thing. So grub make password yada yada yada. So let's put that in here. And then the next one is what does PBKDF2 stand for? So let's try to find the answer for this. I can probably just Google this real quick just to find that. And so there it is, password-based key derivation function 2. It's a big mouthful right there. So that is what that stands for, and let's submit it. That is indeed the answer. All we have to do is Google it. Okay, so now let's jump into the next task, which is file system partitioning and encryption. File system partitioning and encryption. So encryption makes data unreadable without the key, the decryption key. In the scenario where an adversary has complete physical access to the laptop by stealing it or your disk or whatever it is, that's where encryption comes in, right? We want to make sure that they can't use any of that stuff, so you encrypt it. And we did an entire video on cryptography as well, so you can go check that out, because I don't think we're going to do that much of a deep dive into encryption right now. So a lot of modern Linux distributions come with LUKS, the Linux Unified Key Setup, and this is what it is going to look like. So you have the PHDR, it stands for partition header, and it stores information about the UUID, universally unique identifier, the used cipher, the cipher mode, key length, and the checksum of the master key. KM stands for key material, where we have KM1, KM2, and it goes all the way to KM8. Each key material is associated with a key slot, and it can be indicated as active in the LUKS header. When the key slot is active, the associated key material section contains a copy of the master key encrypted with a user's password. So in other words, we have to use the master key that's encrypted with the first user's password and saved in KM1, then encrypted with the second user's password and in KM2, so on and so forth. Then you have the bulk data, and it refers to the data that's been encrypted by the master key, and the master key is saved and encrypted by the user's password in a key material section. LUKS reuses existing block encryption implementations, and the pseudocode uses the following syntax to encrypt. And then, as you can see, it works with different ciphers. Obviously, original refers to the plain text of the data. The original length is that what is referred to as the plain text of the data length. And then you have the user supplied password that uses the encryption key, and the keys derived using the password-based key derived function, which we talked about in the last task, pbkdf2. So key equals this, and then if you want to salt it, again, go check out the encryption, the cryptography video if you don't know what salting means, and so on and so forth. So using a salt with a hash function, repeating an iteration count, we also talked about this in cryptography, ensures that the resulting key is very secure, or at least secure enough that it can be decrypted by something like CrackStation or these different decryption tools. And then right here, we're already referring to the introduction to cryptography room. So to decrypt the data, then you go and you create a variable called original, and you assign decrypt as the action to it, the cipher name, cipher mode, key, encryption data, original length, so on and so forth. Most distributions let you encrypt a drive using a GUI, a graphical user interface. However, if you want to do it from the command line, these are the steps that we would have to go through. And so you install crypt setup LUKS, confirm the partition name, set up the partition for the LUKS encryption, then create a mapping to access the partition and confirm mapping details, overwrite the existing data with 0, and format the partition, mount it, and start using it like a usual partition. And in the terminal below, right here, we actually get to see a real example of this being done on a USB drive that is sitting at this partition right here in NTFS format. And so this is the series of actions, right? So you use sudo to get access to it because you need the root permission. And then once you're here, BLK ID, then crypt setup, and then crypt setup lux open, then the make fs extension on the drive. Strategos USB is the name of the USB specifically, and then you mount it so that you can use it. If you want to check the lux setting, you can issue the command crypt setup, and in the terminal we see that the UUID of the encrypted disk, as well as the cipher that's used, and the key for PBKDF2, it used SHA-256, and the salt was 194180, and with the salt for 194,000 iterations. So there was a 256 encryption, there was a salt attached to it, and it was iterated over 194,000 times to make sure that you get like a really strong key. So it's sudo crypt setup, and then the drive itself, the USB drive, and then we go further down, and then we can see that the salt right here was there, digested the salt, so on and so forth. So this is for this key slot token, digest PKF2. So let's just, before going back and forth, I think this is actually all one. Yeah, because it's for this thing. So this is the header information as they implied. There's the version, the epoch, the metadata, the metadata area, and then the key slot area, the UID, label, subsystem flags, etc. And then these are the data segments and the cipher that was used in this particular case, the key slot itself, 512-bit, cipher itself, again, 512-bit, and then we had a salt attached to it. The hash type that we want to use is SHA-256, and then I want to find the part where they go through iterations right here. And so 194,000 iterations on that hash value, and it gives you a completely different hash than you originally would have started with. So question here, number one, is what does LUX stand for? And so we have that at the very, very top one more time, which is our Linux Unified Key Setup. And that's what LUX stands for. And we can just paste that in our text box right here. And so we can't attach external storage to the VM that we're on. So we've created one inside of our image file right here on home TryHackMe. It's encrypted with the password like this. And so to access it, you need to open it using crypt setup and then mount it to an empty directory such as my vault. So what is the flag in the secret vault? So let's go ahead and basically follow these instructions here. So I'm gonna open up my terminal and I'm going to access it using crypt setup. So we're gonna go to the top right here to get access to our stuff. So we already have crypt setup installed from what I understand. So if I just do man crypt setup, I should be able to see like a manual for crypt setup. And if I do, that means I actually have crypt setup installed on my machine. And there's the manual. So we can press Q to get out of that. And so the first series of steps would be to run crypt setup and open that drive, excuse me, so that image. So sudo crypt setup yv lux format with a capital F, and then from here we need to go to the actual directory of the thing. So home TryHackMe secret vault dot image. I keep misspelling image. There we go. Let's try that and see. We're good. Are you sure that you want to do this? Ooh, do I want to rewrite this? I don't know if I want to rewrite this. Maybe that's not the right one. Oh, I need to use Lux Open because I'm using Lux format. So that's definitely not what I want to do. So you know what? No. I'm going to do no. Operational board. I almost rewrote that entire thing and then I would have to restart the whole thing. So Lux Open, I think, is the one that I want to use. And does it say right here? So to access using crypt setup and then mounted such and such and such. So we're going to do Lux Open in this case because that would have been a very bad situation. So sudo crypt setup Lux open, and then I want to do home TryHackMe secret vault.img, and then what is after this? I guess EDC drive. Let's see maybe if that is something that I can use here. Image doesn't exist or the access is denied. Okay, well that means that I need to use the password for this. So, all right, let me try a couple of troubleshooting situations here and see what we can get. Okay, so we have a command here. I could have just done this the entire time. But you know, honestly, if you use the hint like as your first thing, sometimes you don't learn as much. So, you know, that's my excuse for going through a couple of errors and then finally getting that command that they gave us. So, first thing I need to do is I need to go to my home and then go into the TryHackMe portion. So I'm going to go back one, and then I'm going to do ls again, and there should be a home directory for me. And there it is. So home, and then let's do another ls. It's kind of running slow, this little machine. I wonder, do I have too many tabs open? I think I do. So let's close some of these tabs on this secondary monitor. I also have not, I'm going to leave Google open. Well, no, we'll close this one too. Why not? And let's see. That should be the only thing that's open. Yeah, that's the only thing that's open. Okay. So root Ubuntu, and it says home TryHackMe. So that, I mean, where is this thing? If it's not inside of the home folder for me, where would it be for home TryHackMe? So what if I went to, let's go to, of course, I am literally in the wrong machine, you guys. I skipped this whole freaking thing in our previous task, and I've never actually logged in to the Linux machine. I'm like, where is this thing? I can't believe it. Okay, fine. My goodness, I can't believe it. SSH, TryHackMe at 10.10.213.47. There we go. And then, yes, I want to continue. And password is going to be insecure pass 123. And once we are inside of that machine, then we get to continue from our plan right here and actually run the freaking command. So now what I can do is I can actually go to cd home TryHackMe, and that should work, because if it doesn't, I'll be pissed. All right, so there it is. So we got the secret vault image right there, so that works perfectly fine. And now I need to copy and paste this thing right here and run this. So there's our full command right there, sudo crypt setup open the Lux secret vault image, my vault, and then and sudo mount my vault to my vault. So let's press enter and see how that works. Enter the passphrase. So there's my passphrase prompt, and now I'm going to paste the passphrase in here and press enter. Okay, so it seems that it's been done, so there was no error or anything. So if I do an ls command, I should be able to get something in here, right? So let's see, my vault is where we want to go to. And inside of my vault, there should be the flag. Yep, there it is, lost and found. And then we also have a task 3 flag text. So that's what I want, task 3 flag text. And then we're just going to copy and paste that. And there's our flag. Can I copy this or not? Come on. All right, whatever. We'll just type it in. Cool beans. So there we go. That is it for our file system partitioning and encryption task. So let's walk into or move into the firewall task. All right, the firewall. Look at that. Our little penguin is being protected by a little shield. How nice is that? So the client server model is what we're going to revisit real quick before we can jump into a firewall. And I mean, honestly, you kind of should at the very least understand what a firewall is. But in this particular case, just to kind of do a quick review. So a client could be anything. So it could be a server, it could be a network device, or I guess, my bad. A network device could be anything. It could be a client, it could be a server, it could be both simultaneously. It could probably be IoT devices, Internet of Things devices. And the server offers a service. The client connects to the service. Examples of servers include web servers, mail servers, and SSH DNS servers, names, all of that stuff. And a client could be the phone that accesses that server through the internet, through some kind of an application or the browser, or it could be a computer that accesses the web server, right? The server listens on a TCP or UDP port that's been assigned to it, and it waits for incoming connections from the approved list of clients. The client initiates that connection to the server, and then the server responds. A firewall decides which packets can actually go into that server and which packets could leave that server. And for more information, we can go into the firewalls room, which I don't think I've even done. So that's probably going to be something, yep, that is going to be something that I will be doing in the near future. Let's see if it's inside of the learning path that we have right now. We have software security, and we have managing incidents. So firewalls is completely separate from the current path that we're on right now, which should be fine. It's perfectly fine. It's all good. We do understand a basics of it. So hopefully you just understand what I went through right now so that you can kind of put two and two together as we go forward here. Without a firewall, a client can communicate with any server without any kind of restriction, and it can function as a server and listen for incoming connections from other clients as well. In other words, if the attacker manages to exploit a vulnerability on a system without a firewall, they could use the exploit to listen on whatever port on the victim machine and connect to it without any restrictions. Setting up a firewall offers many security benefits. Rules on firewalls provide fine control, meaning fine-tuned, like a fine-tooth comb kind of a thing, over which packets can leave the system, which packets can enter the system. Firewalls rules help to mitigate a lot of security risks by controlling network traffic between devices. And firewall rules can be devised to ensure that no client can act as a server. So that's very, very important as well, because if somebody doesn't connect to your server, but they can connect to a client computer, they can use that client computer to be a server and feed back information to wherever they are in their country or in their room or whatever it is, and use your client, your computer, as a server. So you could even make it so firewalls prevent that from happening, which is very, very useful and very powerful. So an attacker can't start a reachable listening port on a target machine. The exploit can start a listening port, but the firewall will prevent all of the incoming connection attempts from happening. And a host-based firewall is software installed on a system that we want to protect. Unlike a network firewall, the host firewall restricts packets going to and coming from a single computer, a single client, a single host, single phone, right? It has two functions: who can come in, who can leave, or what can come in, what can leave. And this could be either allow or deny. That's the terminology that's used. Imposing rules on the packets entering and leaving a system will significantly improve the security posture. So let's investigate how we can achieve this on a Linux system. The first Linux firewall was a packet filtering firewall. It's called a stateless firewall, and it can inspect certain fields in IP and TCP/UDP headers to decide whether or not they want to use that packet or allow that packet, deny that packet. But it doesn't maintain information about the connection itself, the TCP connection. So as a result, the packet can manipulate a few TCP flags to appear as if it's part of an ongoing connection and evade certain firewall rules. And Linux firewalls right now are stateful firewalls, and they keep track of ongoing connections and restrict packets based on specific fields in the IP and TCP UDP headers based on whether the packet is part of an ongoing connection or a conversation. The IP header fields that find their way into the firewall rules are the source IP address, destination IP address, and then the TCP headers are the source TCP UDP port and destination. So it's worth noting that it's impossible to allow and deny packets based on the process, but instead on the port number. So if you have a process assigned to a port number, for example, a web browser is used on ports 80 and 443, then you can filter those ports, because you can't filter a Google Chrome or a Microsoft Edge or Mozilla Firefox specifically, but you can filter the ports that those things use. So it's very, very important. On a Linux system, SE Linux or AppArmor can be used for more granular control over processes. We can allow the user bin Apache 2 binary to use ports 80 and 443 while preventing any other binary from doing that. And then both tools enforce the access control policies based on that, providing a more comprehensive way to secure a Linux system. So we can take a closer look at this. We have NetFilter, which is one of the, the core projects, the core firewalls that are available. It provides packet filtering for Linux kernel 2.4 and up, so any variation of 2.4 and later versions, and it hooks require a front end such as IP tables or NFT tables to be managed, and then this is what it looks like. In just one particular example, you have the SSH client trying to connect through the cloud, and then the firewall itself just prevents or allows that access to go in to the system. So we have IP tables, which is a front-end software command line tool that provides the user space to configure the packet filtering rule set using the NetFilter hooks. And for filtering traffic, you can have input, output, and forwarding as the default chains that are available on IP tables. So the input applies to the packets coming in, output applies to the packets leaving, and then the forward applies to the packets that are routed through the system and being forwarded to something else. So we want to be able to access that on our system remotely. So the SSH server, to be able to communicate with the world, we need to be able to do two things. We need to be able to do incoming packets to port 22 and accept outgoing packets from port 22. And then we translate it into the IP table command like this. So you have IP table action input, port TCP, the destination port is 22, and then accept. And then IP tables action output, port TCP, the source port 22, and then accept. So that's what it looks like to just set a basic IP tables command or IP table rule, let's call it that. And that's very simple. You know, the action is going to be either input or output, the port is going to be TCP or UDP, and S port would be source port, D port would be destination port, and then you just send it through like that. So let's say you only want to allow traffic to the local SSH server and block everything else. In this case, you need to add two more rules to the set, and that's what it would be. So action IP tables action input drop, IP tables action output drop, to block all incoming and all outgoing traffic that's not allowed in these rules, right? So these are explicit rules. That's what that specifically means, is when you explicitly allow something or explicitly deny something. then everything else falls under this kind of like a holistic rule that covers everything. And all of the input is going to be dropped, all of the output is going to be dropped on port 22, with the exception of these specific actions, right? So if the rules need to be applied in a specific order in order for this to actually take place. Because if you do these first, then these two won't work either. So first you do all of your allowing stuff, and then you do your blocking of everything else. You should flush or delete any rule before applying new ones, and it can be used by the dash capital F flag, and that'll flush everything on IP tables. Now you have NFT tables. It's supported in kernel 3.13 and later, and it has some improvements over IP tables, specifically in scalability and performance. So we're going to create a very simple configuration that allows traffic to go through the SSH server. So specific, right? So the opposite of IP tables, NFT tables starts with the node tables or chains, and you need to add necessary tables and chains before adding the rules. So we first create a table, which is going to be the firewall filter in this case. So NFT add table firewall filter, and this I don't think this stands for non-fungible token. All right, so don't confuse this with the NFT of Web3. So NFT add table firewall filter, and add is used to add a table. Delete can delete it. List will be able to list it, and flush is to clear it, very similar to IP tables. And then the table and then the table name is used to specify what you want to do. So NFT add the table firewall filter. So now since we have firewall filter, we can add the input chain and the output chain for incoming and outgoing. So NFT add chain firewall filter, FW input, FW output. So far these first sections are exactly the same. Now you're doing firewall input, firewall output, and then type filter hook input priority, etc. Type filter hook output priority, etc. So the type of the filter that you want to, the type of the chain, that you want to add is a filter, and you want to do an input hook, and then this one is an output hook, and the priority is a 0, which in this case, let's see what it means right here. They haven't explained it to us. I want to say priority 0. If it's priority 0, I'm gonna guess that it's not anything to do with accept or deny or anything like that. It's just kind of granting priority, and 0 seems to be a low-level priority. But this is all speculation. I would need to verify that, but this is me just guessing what that means. The above two commands add two chains. So we have the FW input output, and this is of type filter and applies to the input hook, of type filter applies to the output hook. And then with the two chains created in our table, we can add the necessary rule to allow SSH traffic. And this is what we would do with that. So FW filter, same thing. So up until this part, we're not adding a chain to the FW filter. We're now just adding a filter to it. So FW filter, FW input on destination port 22 accepted. FW filter, FW output on source port 22 accepted. And then you can check the shape of this by using NFT list and then the table that we just created, which is our FW filter, and it'll show us what the rules are that we just created. So table IP FW filter, the chain for input, chain for output, and this is the hook that we created, and then the specific rule to port 22, and then another hook, and then specific ports to a specific rule to port 22. So we have UFW, which is something that is a tool that is being used to simplify things by doing a front end to the front end is what they're saying. So adding a front end to the front end to make it a little bit easier to manage. So examples would be the command line interface front end, such as what firewall D and UFW are, and then the GUI front end, such as FW Builder. And this is our nice little graphic to kind of explain what needs to happen. So net filter has IP tables, and then IP tables has UFW, and then the command line front end, and then net filter IP tables firewall D is the command line front end. So that could be and then but you have a GUI front end, so which would be used for net filter IP tables. The FW builder would end up being the GUI front end. So it starts with net filter, you have IP tables that you're using for net filter, and then from there you can either use a GUI as your front end to the front end, or you can use a CLI, a command line interface, as your front end to the front end. UFW stands for the uncomplicated firewall. So if it's promising uncomplicated, let's see if that actually works. So if everything has been configured already and you just do UFW allow 22 TCP, it allows traffic to port 22 TCP, and that's basically all you would have to do instead of doing this whole spiel to set this whole thing up. You see how all the crap that we had to do here using the NFT tables? You literally just you have IP tables obviously, but then you have this being your front end to your front end, and you just do allow 22 TCP, and that's it. That's all you got to do. And so if you do sudo UFW status, it'll say TCP port 22 allow from anywhere, and then that would be on the IPv6 or IPv4, and this is the rule from anywhere, right? The firewall policy, before configuring it, you need to decide upon a firewall policy, and you might be the decision maker regarding the policy, or somebody else could be it, and it all basically just comes down to what you're protecting. We're not going to go into security policies, but there are two specific things. You have block everything and allow everything, and so block everything, allow certain exceptions, allow everything, block certain exceptions. So this part right here is the explicit allow or the explicit deny that we were talking about previously. So they have their advantages and disadvantages. If you have a high traffic kind of an environment, you kind of want to block everything and only allow certain exceptions. If you don't have a high traffic environment, maybe you want to allow everything and block certain exceptions. So blocking everything with a limited set of exceptions would provide tighter and better security. It might cause inconvenience. So that's kind of a big deal. So we're going to consider an example. You're responsible for configuring the host firewall installed on the university computers. In this example, the academic institution has decided to block all outgoing and incoming traffic except for DNS, HTTP, and HTTPS. So this is port 53, port 80, and port 443. In firewall terms, that you have port 53 right here, port 80, and port 443 already. This policy should allow browsing the internet over HTTP and HTTPS. However, if one of the websites uses a non-standard HTTP or HTTPS port, it'll be blocked. Dealing with these exceptions, we will create a challenge. Keeping the firewall rules organized and properly documented is tricky, and we got to try to figure out how to do it. So there's a firewall running on the Linux VM, and it's allowing port 22 TCP, as we can SSH into it, obviously. It's allowing another TCP port. What is it? So for this, we would probably end up just doing a simple nmap against this thing. Okay, so actually, I stand corrected. We could have run a very basic command that was inside our lab right here that says sudo UFD status, UFW, excuse me, sudo UFW status, and it gives us the status of our firewall. So super quick, super easy, and immediate response. And so yeah, we got a TCP port that was open. We have another TCP port, same thing, basically the v6 version of the TCP port, which is 12.526. And then this is the UDP port, which is 14.298. And that is the UDP port that's open. And so very, very quick. No other type of scan or anything that was necessary to find open ports. Usually when I see the question ask for an open port, I automatically go to, oh, I got to run an nmap scan or something like this. But just looking at the context and the content of this lab and what we're looking at, you don't need anything of the sort. You just got to run a basic command for the firewall, and then you get access to that. So very, very quick, very easy to do. So let's move on to the next one, which is remote access. All right, remote access. Providing remote access is super convenient to access your system and files when you're not around your actual machine. So it also means that you're basically providing a service that attackers will target, because in order for you to be able to do it, somebody could do a man-in-the-middle kind of an attack and, sniff your password or guess your password and brute force into that remote port that you've set up for remote login, and exploit whatever the listening service is. So if it's RDP or SSH or anything like that, it basically kind of leaves some room for attackers to hack you or attack you, because of the fact that you've set up a specific port to do remote access. So when you want to harden your Linux system, you got to protect against these things right here. So the first one would be to protect against password sniffing. And remote access goes through a lot of different protocols. Modern systems use SSH, which is encrypted. Older systems might use clear text protocols such as Telnet, and we talked about this in one of the videos about weak protocols or weak ports to attack, and you can go watch that. And Telnet basically, if Telnet is not secure, because there is a port for the secure conversation of Telnet, and Telnet I think is 23, port 23, SSH is port 22. If you just use Telnet, it's going to send your passwords as clear text. And so people can actually, all they have to do is just be listening on that port, and they're literally going to be able to capture your information because it comes through clear text, no hashing, no encryption, nothing. And they could just read it. And that's basically it. And this is what that's what that looks like. So you use a Telnet client, your username and password comes through as clear text, and it goes to the Telnet server. And somewhere in the middle right here, somebody could just read this or capture the traffic and basically just see what your username and password is. And that's that's all they need. They don't need to do shit else. It's crucial to ensure that you select a protocol that encrypts traffic. So SSH has been around for a lot of time, and it stood the test of time because it encrypts traffic and it encrypts your username and password. So if somebody is listening, they can't really see what the actual clear text information is, and they would have to go through a lot of different steps to be able to find that information. Then there's password guessing. So protecting against password guessing, there is something called brute forcing, or password spraying if there's like multiple users that they can go after. But if they're just going after one user, it's typically called brute forcing. And password guessing, if you have a weak password especially, it's fairly easy to do because there is a bunch of dictionaries that have passwords in them. It's one of the most common ones that's very popular is called the RockU password list, and it has something like 14 million passwords in it. And they're all the easy passwords. So QWERTY1234 is a very easy password. And if you put your left hand on your keyboard and you start with your pinky and you go up from, so if you put your left hand on your keyboard at your home button, so your left index finger would be on the letter F, that's the home button on the left side. And so if your finger is just resting there and you go up to the upper row and your pinky goes on Q, your ring finger goes on W, your middle finger goes on E, and then your index finger goes on R, and then again T is the very next one, Y is the very next one. So it's literally just the series of keys that are on the top row of the keyboard. And then there's 1, 2, 3, 4, which is again your pinky, ring finger, middle finger, and index fingers. It's all done on your left hand basically. And it's not technically an English word or anything like that. It's very, very common in the top 10 or 20 most common passwords, because it's just one of those like easy things that you just randomly kind of do, but it's done with your left hand and it's super, super easy to do. And that just makes it one of those passwords that's very weak and easy to guess because it exists inside of these common password dictionary files. And so that's another one of those things that you gotta account for. So your SSH server is configured to listen for incoming connections, and evil users have all the time in the world to attempt one password after another, and you just need to account for that. You need to be prepared for that. So a remote login such as root needs to be disabled so that anybody who is logged in only gets to log in as a non-root user, and then disable password authentication, force public key authentication instead. So instead of them using passwords to authenticate themselves, they use a public key as a part of an asymmetric encryption algorithm where there's a private key and a public key to be able to get in. And the reasoning behind this is that you don't want the adversary to be able to attack the root account, number one, and then if it's a non-root account, you don't want the attacker to gain access if there's a weakness in the password. So those are the two things that you're trying to account for in that situation. And the configuration of OpenSSH can be controlled via the SSHD configuration file, which is located at the etc SSH directory, and you can disable the root login by just doing permit root login no. You just add that inside the SSHD config file, and it removes that possibility. And this is a complex password, it's a difficult password. Most people find it inconvenient to memorize. So if the account belongs to the sudoers group, which is the root group, people that have root access, they need to be able to type that password every single time that they want to issue a command with sudo, right? Because anytime you do sudo and then a command, it asks for that password, and then you got to be able to type that. And it's difficult to memorize, difficult to type. So you can't expect this to work for everybody. Many users are tempted to select a user-friendly password, and the approach would make it easier to remember, but at the same time easier for the attacker to guess, and it would be best to just rely on public key authentication to improve the security so that you don't have to worry about those types of problems. If you haven't created a key pair, then you got to use SSH keygen and then use the RSA real secure algorithm, and it'll generate a private key saved in the ID RSA and a public key saved in idrsa.pub. And for the SSH server to authenticate using the public key instead of the password, your public key needs to be copied to the target SSH server. And then an easy way to do it would be to issue the command copy ID username at server, where the username is your username and server is the host name or the IP address that you're trying to transfer it to. And you need to just make sure that in a best case scenario and an ideal scenario, you want to be able to have access to the physical terminal before you disable the password authentication to avoid locking yourself out. And you need to ensure having the following two lines in the SSHD config file, which is the pub key authentication is yes and password authentication being no, to disable the password authentication, and then pub key would be to enable the public key authentication. So very, very simple. So now what we got to do is we got to actually go in the SSHD config file to just find the flag. So I'm going to first remote shell back into this, because I'm doing this on a second session. I didn't finish this recording yesterday, so I need to re-log in using SSH TryHackMe at 10.10.44227, and we do that, and we want to log in, and it's insecure pass 123, and that should give us access. Did I misprint that password? I think I misprinted insecure pass 123. See if that works. Okay, there you go, that worked. So now we're gonna go and find the SSH config file. So let's see if we just cat it onto the screen. SSHD config, if it'll show. And let's see, example of overrunning, da, 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 da. I think we're in the file. So let me see if I can find that flag. There it is. It's at the very, very top. So it was on the top line of the file. So we're going to copy that right there. There we go. Copy that, and there it is. So we got the SSHD config flag. And just like that, we wrapped our remote access task. So let us now go into securing user accounts. Securing user accounts. So sudo make me a cup of coffee. The root account carries tremendous power, and therefore it carries a lot of risk. You're at risk of rendering your system unbootable with a simple mistake. Using a non-root account for everyday work is recommended to avoid sabotaging your system. However, root privileges are still needed for system maintenance, installing, removing software packages, and updating configuration. So even on my machine right here, I'm the only user on this machine. And so if I want to do anything, I'm the admin, I'm logged in as the admin, the only user. But what happens is when I want to do specific commands that are sensitive commands, it says that you need root privileges or you need admin privileges. So I have to run sudo to be able to run certain commands on the computer. And when you do that, it's kind of like you go through the point of no return. Like if you do anything using sudo, you're making real changes that could potentially harm the system, right, or sabotage the system. So to avoid logging in as root, the better approach would be to have an account that's created for admin purposes, added to the sudoers group, who can use the sudo command, which stands for super user do, and it should precede any command that requires root privileges. So you can create a user, add them to the sudoers group, and then they can use the sudo command, but it won't be the actual root user doing it, right? So that's very important. Depending on the Linux distribution, we can add a user to the sudoers group in the following ways. Such Debian and Ubuntu call the sudoers group sudo, and you would need to issue this command. So user mod add g, so add to group sudo the username. So user mod is modifies a user account. So user modification, append to group. The group name is sudo, so we're appending to the group sudo, and then we're going to append whatever the username is to that group. So user mod ag wheel username. Wheel is the same thing for sudo. It basically is the sudoers group, but it's in the distribution of Red Hat and Fedora. That's the name of the group. And so you would do it the same, pretty much the same way, user mod ag wheel, which is the name of the group for sudoers, and then the username. Disabling root. So once you've created the account and added it to either sudo or the wheel group, then you got to consider to disabling the root account. And you just go to etc password and change the root shell to sbin no login, which basically means edit the etc password file and add this right here to, or change the original line right here to this. So we can just go check this out in the shell that we're in right here. So if I go to cat and I do the etc password file, we'll be able to see this, and then we just scroll to the very, very top of this file and we'll see that the first line is our root user. And let's go and make sure that we actually are there. So that's the first line. So the first line is the root user, and you see how it reads bin bash right here. This also reads bin bash, which means that that's the actual bash binary that's being used for this. So to disable it, you just want to change that to this thing, sbin no login. So that way, it's not able to use the bash binary, and it just gets disabled. So very, very simple way to do it, and it's quite effective. Then you enforce a strong password policy. This is the library password quality that allows a lot of options for password constraints, and it can be found in the security security. I am drawing a blank for directory. That's the word. I'm like, how did I forget the word directory? So it can be found inside the etc security directory or etc pamd, and then you can just do apt-get install the library to just make sure that you actually have it. But depending on which kind of distribution you're using, this is where it would be located. And then so DIFOK, so defoc, whatever, allows you to specify the number of characters in a new password that were not present in the old password. Minimum length, minimum allowed length for passwords. Minimum class is the minimum number of required classes of characters, and a class could be uppercase, lowercase, digits, among others. Bad words, which is a space-separated list of words that must not be contained in the chosen password, and then retry and prompts the user a number of times before returning an error. So this is an example of a password policy right here. So 5 would be the specified number of characters in the new password that were not present in the old password. So when you create a new password, you need to have at least 5 new characters in that new password that were not in your old password. It just kind of ensures that you don't reuse your old passwords, basically. Minimum length is that it needs to be 10 characters long. Minimum class, it needs to be 3 different types. So it could be capital, lowercase, and numeric, could be the 3 different classes. And then you get 2 retries. And apart from that, you get an error that you can't do it anymore. So you can check all the available options through the manual for that configuration file, and then disabling unused accounts. And this is also a big deal because that's another one of those attractive places for hackers and attackers to go to, where they look at unused accounts and they just assign themselves to those unused accounts. So it's very important to disable user accounts that no longer need access to the system. The user might have moved to another department or quit the company, so you just want those things to be gone as soon as they're gone or as soon as they change departments. Disable a user account in the same way that you would disable the root account. It would be to edit the etc password file and then set the shell of the user account to be this, or you could just delete them. Enable account Michael such and such and such, disabled account Michael, and then same thing. The user bin fish turns into sbin no login. So that's like a really basic way of disabling them. You can also do it for local services. So we can set the shell to sbin no login for all the local services, such as www.data and Mongo and Nginx. And the reason is that these services need accounts to run the system, but would never need to log in and access a shell. So that's very important. So they need to run a system or run some kind of a service, but they don't need to actually access a shell. And sometimes they're set up to do so by default. So you just got to disable them and remove those options. And any of these things could have a remote code execution vulnerability. We've done the www data on web servers a lot when we're like using web shells to get into a web server. This is one of the vulnerabilities that we use a lot. Nginx, same thing. So you set the shell to no login and then prevent interactive logins for the account of that affected service. So the questions for this task are as follows. One way to disable an account is to edit the password file and change the account shell. What is the suggested value to use for that? Which would be, I think it's sbin no login, right? Yeah. What is the name of the Red Hat and Fedora systems sudoers group? Wheel, right? Yeah. And what is the name of the sudoers group on Debian? That would be sudo. And other than TryHackMe and Ubuntu, what is the username that belongs to the sudoers group? So let's check who belongs to the sudoers group. And we're here already. And I wonder if it tells us what group these people belong to. There is a way that I can check who belongs to the sudoers group. So first, let's see if any of these commands right here we could use. Okay, let me check real quick. Maybe the hint will tell us. Oh, okay, so the etc group file. So let's go and check that. I misspelled cat etc group. All right, here we go. So we're looking for that belongs to the sudoers group. So all right, found a quick little hack here. to make it a little bit easier. So we grepped for the word sudo, and then we grepped it inside of the etc group file, which is the one that we had right here to list. And then we cut the part of the file that shows the actual username that has that sudo in it. So we have Ubuntu, TryHackMe, and Blacksmith. So this is a very useful little command that I just found by doing a little bit of a Google. And there it is. So Blacksmith is going to be our user. There it is. Nice. Nice, nice, nice. All right, so we are good with this one. So let us now go to software and services. All right, so we gotta disable unnecessary services. And we talked about this a little bit in the last task. So the easiest ways to improve security is by just removing and disabling services and packages that aren't being used or they're not necessary for the business practices. We need to minimize the number of installed system packages is a simple way to say it. Every package carries risks because of the way that they're set up, and it could be third-party packages that you can't guarantee that they're secure, so on and so forth. So very, very simple is if you just know that something doesn't need to be installed on a computer or on a machine, just uninstall it or disable it. If you don't need a web server, then don't install one. And if there's one installed as you virtualize your machine, because a lot of times when you virtualize something or when you install an operating system, there's a lot of pre-installed softwares and services that are on there. So if you don't need it, just uninstall it or disable it. If you needed to run a web server at one point but no longer need it, again, remove it or disable it. So it's very, very simple to think about. Block unneeded network ports. So if you don't use certain ports or you don't need them, block them. Explicitly block them. After you remove a package that's not required and disable pre-installed services, then it's critical to set the firewall rule accordingly. And if you don't have a web server, there is no reason to allow packets on port 80 and 443 to go through. So block those ports. Reasoning is that the attacker manages to start a disabled service. The firewall will block the traffic and the attacker won't be able to access it. Avoid legacy protocols, and legacy protocols are those things that have kind of been grandfathered in, and they're in there because they used to be on old distributions and now they're just there, right? So Telnet was a primary protocol to access a system remotely, and it's a legacy protocol. It's kind of old school, as you want to call it. So the TFTP protocol was commonly used to transfer files. So these protocols are no longer allowed as secure alternatives. If that's the case, block them, right? Instead of Telnet, SSH is what's used. Secure File Transfer Protocol, SFTP, replaces TFTP, which stands for Trivial File Transfer Protocol. So it's very, very simple, right? It's very common sense and basic, but if you just don't use them, and to even make it better yet, you just block those ports and those protocols, then you're golden. And then remove identification strings. When you connect to a remote server, it usually replies with a version number. And when somebody has the version number, they can start searching for vulnerabilities and exploits for that version. So if you can do that, if you can remove the identification string of that, then you are also protecting yourself in a manner that they can't research your distribution to try to find any vulnerabilities or exploits or anything like that for it. So removing an identification string seems, again, very simplistic, but it's very, very effective. So the question here is, besides FTPS, what is another secure replacement for TFTP and FTP? And I think is SFTP. Is that it? Yeah, SFTP, Secure File Transfer Protocol. So there is our very quick software and services task. So let's go into update and upgrade policies. This is another one of those kind of commonsensical types of things where the latest security updates and patches and bug fixes, you just got to make sure you update your system and upgrade them regularly as soon as something comes out that can update and upgrade your software, your system, anything like that. You got to do it. A Debian-based distribution such as Ubuntu, you can just do apt update to download package information, apt upgrade to install available upgrades. On Red Hat or Fedora, this would be your command to update and upgrade those things. And it's just good practice to do that regularly. Microsoft is obviously pretty good with this kind of stuff because they give you notifications in advance or anytime anything new comes out. But for Linux, because it's an open source operating system, I don't know if they have developed them by the time, after this room came out, because this room is probably fairly old. Let's see, it says it's 313 days old, so it's almost a year old, this particular room. So we don't know how frequently these things get updated and changed. So just as a good practice, if you're running Linux, you just want to make sure that you update and upgrade your system regularly. The LTS releases, the long-term support releases, are released every 2 years, and they have an even version number. So 04 for April, 1804, 2004, 2204, etc. And LTS version will grant 5 years of security updates for each base without a subscription, and another 5 years if you pay for extended security. More information is available on the Ubuntu Lifecycle release cadence. And using an Ubuntu LTS release, you can download updates without a subscription for the first 5 years. And consider Ubuntu 14.04. It was released in 2014 on April, right? Its free support ended in 1904. In other words, free update services will be available until 2019. In the terminal below, we see that there are 133 additional updates that we can download and install if we have Ubuntu Pro, and previously known as Ubuntu Advantage. So when you run uname A, it'll say where. So this is the current version that exists right here. And then sudo apt upgrade, it gives you all these things. And then 133 additional updates are available with the infrastructure. So 14.04 was released more than 5 years ago, hence free upgrades are no longer available. From a security point of view, the user should either get an Ubuntu Pro subscription or switch to a new LTS release, such as 2204, so that they can get another 5 years of free security upgrades. So when you run a system that doesn't receive security updates, it exposes your system to be attacked. And so when you're the attacker and thinking about it, you can just consider, hey, you know what, if I search for something that is Ubuntu 14.04, it's probably likely that, if they haven't bought the Pro version, it might be likely that there's still vulnerabilities that are available and there haven't been patches and updates, so on and so forth. So it's always good to know the both sides of the whole thing. Then you have your Red Hat releases, Enterprise Linux 8 and 9. They have 12 years of support in 3 phases. So full support for 5 years, maintenance support for 5 years, and extended life phase for 2 years. So Linux 9 was released in May 18 of 2022. So full support is available until 2027, maintenance support until 2032, and it's pretty damn good. Kernel updates. Updating this system should not be limited to the installed software. It should consider updating the kernel. So in 2016, a security vulnerability that affects Linux kernel was discovered and allows the attacker to gain root access by exploiting a race condition in the copy on write mechanism, cow mechanism, and that's where the dirty cow came from. Vulnerability is present in all Linux kernel versions from 2.6.22 and onwards, and it's been patched in most distributions, but it's still a threat to systems that have not been updated. So it's a severe vulnerability that allows attackers to gain root access to Linux systems, and it's crucial to keep the system, including the kernel, up to date to the latest security patches to just reduce exploitation. So automatic updates. Now that you have a Linux system with security updates through the lifecycle, we got to ensure that they're all properly installed and security fixes are applied, and you just got to stay updated. And depending on the distribution that you're using, you got to configure automatic updates if you can, which is always a good move, and it can save you a lot of headache and save time, so on and so forth. So What command would you use to update an older Red Hat system? And that is up here, so right here. So DNF update or yum update, and it says Linux 8 or 7 and older. So let's see which one they're asking us for. It doesn't say which one, so let's see DNF update maybe. Nope, so yum update. That's the one. What command will you use to update a modern Fedora system? And that one I think is just apt update, yeah. So apt update is that one. Okay. Upgrade. Okay, so maybe DNF upgrade? Is that what it was? Yeah, DNF upgrade. Okay. What two commands are required to update a Debian system connected to commands with and? Okay, very good. So we're updating a Debian system. So it's apt update and apt upgrade. There we go. What does yum stand for? That is a good question. So let's Google that. So what does yum stand for? What does yum stand for Linux upgrade? Let's see. Yellow Dog Updater Modified is what yum stands for. I would have never guessed that shit in my life. There we go. Submit that. And then what does DNF stand for? So let's do that now. Let's just go up here and just change this to DNF. And then dandified yum. Dandified yum is what that stands for. And what's the flag hidden in our sources.list file? So let's see if we can even find that. So we're going to run a very basic find command, and this is why you need to know basic Linux. So find name sources.list, and then we want to do to dev null to go through any, to avoid any errors basically. And so it immediately popped up, which is usually very, very good. And we have several here. So I want to say it's probably the etc apt one. So we're going to do cat etc apt sources.list. And let's see if we can find a flag in here. Yep, it's right there. And we're just going to copy this. And that is our flag. Cool beans. So let's move on to our last piece here. So audit and log configuration. Most of the logs in Linux are inside the log directory. And when you're looking into threats, these are a lot of the logs that you gotta kind of keep track of. And the important ones are, of course, the security log or the secure log, your kernel log, the boot logs. I mean, these are all important. That's why they're probably been listed here. But there's a lot of logs. And these are the things that you just gotta audit. So that's the thing, right? Like they log. I mean, each log logs the activity inside the computer and the things that have happened, and a lot, authentication logs store authentication information, meaning usernames and passwords. So it's very, very important to audit your logs, and you just make sure that those things are all secure. There are two handy commands for large log files. New events are appended to the log file. You can view the last few lines using the tail. So for example, tail N12, which is the last 12 lines of the boot log file, and then search them using grep. So grep failed on the boot log file will look for failed login attempts. And that's also just very, very important, right? You have to be logged in as a root to precede your commands with sudo. So as long as you have access to the sudoers file or the sudoers group to see what's going on. So what command can you use to display the last 15 lines of the kernel log? So tail n15 and then kern.log, and that's our command. And what can you use to display the lines containing the word denied in the file that is secure? So we're going to do grep denied and then secure.log, just like that, right? Or secure. Okay, so not a log file, but secure file. And that's it, just like that. Very, very simple and easy to harden and secure your Linux machines. And let's see what our conclusion says. Conclusion doesn't really say anything here. It just gives us an overview of what we went through inside of this room. So hopefully that was actually useful to you. If you are studying for your security engineer or cybersecurity analyst or Pen Test Plus or ethical hacker, any of those certifications, I encourage you to like and subscribe and turn on the notification bell and join our community, because all we talk about on this channel is cybersecurity, security engineering, pen testing, ethical hacking, all that good stuff. So you'll get a lot of value out of it. It'll actually be helpful to you on your certification exams and on your day-to-day task as a security analyst or an engineer, for example. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. I hope you got value from this video. Love, peace, and chicken grease. If no one else loves you, Hank loves you. And I will see you in our next episode. Later. Yo, what's going on, everybody? It's your boy Hank Hackerson at Hank Hacks Hackers, and we are continuing down our security engineer pathway today. This is going to be episode 11, which is Microsoft Windows hardening, which is a part of the network and system security module, which is a part of the security engineer pathway of TryHackMe. And the outline for this video is going to be, the intro, understanding general concepts, identity and access management, network management, application management, storage management, and updating of Windows. And then there's a nice little cheat sheet that's available for us at the very end of this whole thing. All of these different tasks are going to be time-stamped at in the description below if you want to skip around for anything, or if you want to jump to a particular section. If you are studying for your ethical hacker, pen tester, security engineer, cybersecurity analyst, any of those certifications, I do encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out in this pathway. All of these things will be directly applicable to your certification exams, as well as your day-to-day task of being a security engineer, for example. So it would be really useful to you, in my humble opinion, but at the same time, it would just be really nice to have you as a part of our lovely growing community of now 1,100 people going strong. So very, very excited that we're having the growth that we're having, and it would just be really awesome to have you be a part of our community too. And now, without further ado, let's jump into the introduction of this room. I got to start this machine right here, and I'll probably need to start the attack box too. Oh no, you know what? It's going to be a Windows machine, so I think it's just going to be a Windows machine that we'll need, really. We're going to go through some of these objectives here, which is identity, access management, network management, application management, storage and computation, or storage and compute, importance of updating Windows, and the cheat sheet, which is, I love cheat sheets. Connecting to the machine is going to be, if you're using your own machine and you want to connect through VPN or OpenSSH or RDP or anything like that, you can just use the credentials that are going to load when you go ahead and start the virtual machine right here. So it'll give the IP address for that. But I'm using the TryHackMe server or their system, I guess. And so it's going to start that machine for me, and then I'm going to open it up in a full screen, so on and so forth. So it'll be a little bit easier to actually do. And these are some of our prerequisites for this room. I've done all of these things. So there's a video for all of this stuff that's available on the channel. So if you just search through Windows, there's a Windows playlist, or you could just go on the channel and search through the content through that little search bar. So if I went to here, let me see if I can actually open the channel up. If you go here on the channel view itself, you can actually click this little search thing right here, boom, and then search inside the channel to find whatever it is that we have on Windows. So that'll be useful for you as well. And so now that we have that taken care of, let's jump into task 2, which is understanding the general concepts. All right, so services. Windows services are basically a bunch of different functions. I mean, as the name implies, they're literally the services that are running on a Windows machine. So network connectivity, storage, memory, sound, user credentials, data backup, and basically every other thing that can run on a Windows machine. It technically falls under services. And they're all managed by the Service Control Manager panel, and divided into three categories. So you have the local machine, the network, and then the system. Or it could be the local user even. So the local machine or the local user. Many applications like browsers and antivirus software can also run their services for a seamless user experience. So if we search for services.msc, whoops, let me get out of that image, then we can find something like this. And so let's actually go and just do that real quick. So we'll go under here. It could be this, or I think I could even do Control R to do run. I don't know if that's actually going to work. Whatever. I'll just do services.msc. If I do Control R out of here, maybe that'll work for me. I think it's because I'm in a virtual machine that doesn't work. So whatever. So services.msc. There's that. And then it opens it up for us. Do you want to allow this to make changes? Yes, we do. And so there's that. And that should open that up for us in a couple of seconds. And then we'll basically just be able to see, there it is. So we just get to see all the different services that are available on the local machine, local user. These are all of the services, a bunch of stuff. Most of these things you never actually even see or interact with because they're background services. But there are services that are all running, and a lot of other stuff goes under the services category, I guess, or the service manager. And so this is that whole shebang of this thing. Ooh, Xbox Live is over here. Look at that. Xbox Live is there too. Okay, so here we go. Next one is going to be the Windows registry, and it's a container database that stores configuration settings, essential keys, shared preferences for Windows itself, and any third-party application that you have on there. Any installation of most applications uses a registry editor, so it needs to be stored somewhere. The registry for that needs to be stored somewhere. So for example, if it's an application, whether it's normal or if it's like a malicious application, if it wants to execute itself during the boot up process, it's going to store itself in the run and run once key of the registry. So the registry editor or the registry manager has keys. And so this thing right here that you see right here, this is a key technically. And this particular key goes under, the current user control panel and the colors, the default colors that are available here. So we can just search for regedit and then we'll be able to find the registry editor. So let's do that real quick just so you can also see how that goes. And regedit, or you could just do registry editor, either one. They're showing us here as if we're running the command. So if you do run, it's different than the search right here. It's different than this thing that's at the bottom right here. And when you do run, it opens up a very small search bar like this thing. And then if you use this specific search parameter, I guess, or this search bar, you actually have to look for the executable name of it. You can't just type in registry editor the way that you would inside the search bar at the bottom right here. So this is what it looks like. This is the registry editor, regedit. I mean, pretty much the same exact thing as we're seeing over here. So not much of a difference over there. And then we have our event viewer, which is an app that shows log details about all the events that are occurring. And when we were looking at our what was it? The services manager, the event viewer was also in there. Also, the registry editor is also going to be under services. And then event viewer itself is going to show any event that's occurring on the computer, including driver updates, hardware failures, changes in the OS, invalid authentication or valid authentication attempts, application crash logs, anything. And it receives notifications from different services and applications running on the computer and stores them inside a centralized database. And hackers look at Event Viewer to increase their attack surface to see what is actually running and what's available and what they can kind of backdoor themselves into. And then they enhance the target system's profiling. They can look at anything that would be an application, the system record itself, the security logs, any of that stuff. That all falls under the event viewer. And so if we want to search to it, we can do event VWR in the run window, or again, just go inside the search bar at the bottom and do event viewer, and that'll just bring up event viewer for us. So if I did that, there you go. So very, very easy to run, and then it just opens that up for us so we can go through that. And then you have the telemetry or telemetry. I think it's telemetry. Not sure if that's how you pronounce it. Here's our event viewer on the right side right here. So, I mean, it's pretty identical to everything that we see inside this this sample, this screenshot that we have over here. So nothing insane. I probably have to open up those things and answer some of the questions for this task, but this is what we got for telemetry. It's a data collection system to enhance the user experience by preemptively identifying security and functional issues in the software. An application seamlessly shares the data, such as its crash logs and application-specific logs, with Microsoft to improve the user experience. And telemetry functionality is achieved by the UTC, the Universal Telemetry Client. Services available in Windows and runs through the diagtrack.dll, and the contents acquired through telemetry are stored encrypted in a local folder, which is the Program Data Microsoft Diagnosis folder, and then sent to Microsoft after 15 minutes. And then we can access that by going through the diagtrack and then Services Console in Windows 10. So this is actually under our Services Manager, and then you can just go through diagtrack, which is basically what it is. That would be the service name that you'd be able to search for if you wanted to, but in this particular case, it has connected user experiences and telemetry. But then the service name would be diagtrack. So if I wanted to search for this, I wonder if I could just search for diagtrack, and it would not show me that. So what if I did run, and then if I did run, and then I did diagtrack? Let's see if that works, if I search for it that way. And it brings up Windows diagtrack. I wonder if this is the same thing. Not quite sure. Maybe it is, maybe it isn't. Let's see, it says Windows, so the executable path is Windows System32 SVC host, and then KUTC such and such and such. So I don't think this is the same thing. I think we do need to go actually find it through the Services Manager. But that's it. That's for telemetry. And so now let's answer some of these questions here. So at the bottom it says, what is the startup type of app readiness service in the services panel? So now what we're going to do is we're going to go back to services. I should have just left these things open. But we're going to go back to services, and then we're going to do startup type of app readiness. So it's going to be app readiness right here. And let's see if I can do startup type. Oh, it's already here. So startup type is manual for app readiness. So that's an easy one. And then we're going to open up the registry editor and search for TryHackMe. And it says, what is the default value of the key? So registry editor, and then let's search for find the key TryHackMe. So let me see. I'm going to try to see if I can do it without actually going through all the the individual folders. So let's see if I can just search for this. All right, so very nice actually. So there's something in the edit panel or the edit menu right here that says find. So super easy. And then so I just did find, and then I searched for TryHackMe, and look at that. It found it right here. And it's under this is the key. So H key current user, software, Microsoft F12, TryHackMe. And then here's our data. So THM flag right here, and I could just do a copy like that. So you double click to open the thing and then paste that mofo in there. And now we're going to go to the diagnosis folder and go through the various log files. Can you find the flag? So let's go through the diagnosis folder. I think that's also in the registry editor, right? Let's see. Actually, no. So diagnosis folder is in a local folder, Program Data Microsoft Diagnosis, and we can access that track through the Services Console in Windows 10. So I might be able to just go through the File Explorer to find it. So I could do it that way, or I could actually go to the Services Manager. So what I'm going to do is I'm just going to go through the Services Manager and find it in the same place that they have over here for us. So Services Manager, there we go. And then it's going to be under the Connected User Experiences and Telemetry. And so Connected User Experience, Telemetry, here it is. So if I open this thing up, the folder is going to be here. So let's see, I think I might need to actually just go and do this, right? So if I copy this whole thing, and then we're gonna run it. So we're gonna go here and we're gonna search for run again. And then we're gonna paste that in here. And let's see if it'll open that up for us. And let's see if we can find that information that they're looking for the diagnosis folder, and then find the flag inside the various log files inside diagnosis folder. Let's see if we can find that. Okay, so that didn't work. So what I'm gonna do now is I'm gonna actually paste this little thing that we have here, the program data Microsoft diagnosis, and I'm gonna go to that folder and let's see what we can find. It says you don't currently have permission to access this, continue anyway, and open that thing up and let me see if I can find it. Here we go, diagnosis folder. Excellent. So now through here, it says that we're supposed to go through the log files and see if we can find the flag. So let's see what we can find here. Oh, it's literally in the actual home directory of diagnosis. It's right down at the bottom right here. It says flag.txt. Okay, so since this thing won't actually open for me, what I'm gonna do is I'm gonna open up Notepad. And then so what you can do here, this is a neat little trick. When you search for anything, you can right click it and then run it as an admin. And then when you run it as an admin, then you have admin permissions. And so now I can go here and then I can open the file that's inside the Windows diagnosis. Let's actually search for this one more time, which is basically here. Where is it? This thing. Come on, go here, copy this thing, and then go here, and we're gonna paste that in here and enter, and there it is, and then go at the bottom and then open this flag, and voila, there's the flag. Nice. So perfect. Okay, so we got it. And so now we can paste this in here, press enter, and we got our flag. Very good. So we have all that stuff. And so the last thing here basically says open the event viewer and play with various event viewer filters like information, error, and warning. Which error type has the maximum number of logs? So let's go look at that. Let's check that out real quick. We're gonna close all these things. I probably have to open them up in a little bit anyways, but I don't want the machine to get slow on me. So I'm going to open up event viewer and we're going to go through, it says, what is it? Filters like information, error, and warning, etc., etc. So let's go through these logs right here. So if we open this up, you have application and you have number of events, 1400, security, number of events here. This is probably way bigger because it's not even loading. Setup, system, for these things are all still loading. So that means they're gigantic, right? So you see this little time, like the sand clock time. What is that called? I think it's called the time sand clock, whatever it is. Since if that thing is up there, there you go. Now it's actually fully loaded. So security has 4,800 events. Setup has 11 events. Okay. And then system has 2,000 events and forwarded events has 0 events. So security by far out of these things has the most logs. And if we go to application and open these things up, you have the EC2 configuration has 36 events, hardware has 0, Internet Explorer has 0, Key Manager has 0. So if I went into Microsoft here, and then let's go into Windows, this has a bunch of stuff in here. Windows has literally everything in here. So it's asking, so view filters like information, error, and warning, so on and so forth. So there is something that we can do. I think it's under views. Let me see, maybe not this, hold on. There's something that we could do for filtering. I forgot how to look at the filters. So if I just went to event viewer local and click on the local event viewer, and then there should be something that I can do for filtering things. So let's see. All right, so these are, so when you go to custom view, I believe these are the filters that we can have. So you can have critical items only show up. You can have warning items show up, information verbose. I believe those are the filters. View here and then debug logs. and analytics, and those things are probably going to, that's like a certain pre-saved view that's already there. And you have the number of administrative events already here that shows it to us. So if I refresh this and snap in cancel, so these are our information, warning, error, critical event types, and then you have all the number of filters that came here. So audit success technically could be the number of events for this that are the most, and this is kind of what it's looking at: information, error, warning. These are the things that it wants for us to be able to see. So this is just in the general event viewer tab at the very, very top of the hierarchy. And so audit success has the most events based on that question, or the most number of logs, I guess, based on that question. So that was it for our general understanding, general concepts portion. So let's go into identity and access management. All right, identity and access management. One of those things, again, that the name itself kind of implies what you can expect to get from there and what you can do from it with it. Identity and access management involves employing best practices to ensure that only authenticated and authorized users can access the system. So standard versus the admin account, again, should imply what the whole concept and idea is. So you have two types of accounts, right? You have the admin and then a standard or a non-admin account, basically. For best practices, the admin account should only be used to carry out tasks like installation of software, accessing the registry editor, service panel, stuff like that. Routine functions like regular applications, Microsoft Office, for example, or the browser, can be issued to standard accounts. So if we go to control panel user accounts, this is what we would see right here. And then it'll tell us what type of account that we have. So in our case, and I can already tell you because we were able to use the notepad as an administrator, I can pretty much guess that we have an admin account on this computer, right, on this virtual machine. So in either case, a user can authenticate themselves on the system through a password. And then Windows 10 has introduced a new feature called Windows Hello, which allows authenticating based on something you have, something you know, or something that you are. And something that you have could be a password, something that you know could be a password, something that you have could be a device, something that you are could be your retina scan or your fingerprint, some kind of a biometric type of authorization. To access accounts and the sign-in option, we go to settings, accounts, and then sign-in options. And then you'll be able to see that what you can use for your sign-in options to add or change or activate one of those things. So Windows Hello fingerprint, or the face scan, or the PIN, security key that would be actually attached to a physical USB device, which is kind of a recent or relatively recent type of an authorization. And then of course there's just a password, which is standard, and it's been around probably since the inception of these systems. And then you have the user account, the pronunciation of that was horrible. The user account control, UAC, is a feature that enforces enhanced access control, and all services and applications should execute in a non-administrator account. It helps mitigate malware impact and minimizes privilege escalation by bypassing the UAC. To elevate privileges, there are certain actions that are required, and it's going to automatically prompt for the administrative user credentials if the login user is not already the admin. For example, if you want to install a device driver or inbound connections to be allowed, you need more permissions than are available for a standard user. So this is basically, a lot of this stuff is review, because all of this stuff was covered in the fundamentals rooms of Windows. As a principle, you got to follow the principle of least privilege, which is also something that we've talked about severely and multiple times, which basically means give people the least privilege possible and only give higher privilege, escalated privilege to, people who absolutely need it. And this is also applies to access to software or access to different services on the system. Not everybody needs access to everything. So the standard user should only get access to the absolute minimum number of services and applications that they actually need to do their job. To access the UIC, we go to Control Panel, User Accounts, and then click on the Change User Account Control setting. And then this is just some of the things that show us, right? So it says when to be notified about changes to the computer. You always want to be notified. The user account control helps to prevent potentially harmful programs from making changes to your computer. And then so if you are the admin, you always want to get notified, or anybody really should always get notified when apps try to install software, for example, or make changes, or when I make changes to my Windows settings, and you always want to keep that active. That's kind of, I would say this is standard across everything. You should never turn it to never notify. That should never be the case. So we have local policy and group policy editor. The group policy editor is a built-in interactive tool by Microsoft that allows to configure and implement local and group policies. We mainly use this feature when part of a network. However, we can also use it for Workstation to limit the execution of vulnerable extensions, set password policies, and other administrative settings. The feature is not available in Windows Home, but only in the Pro and Enterprise versions. So this is actually not available in the kind of, I guess, the basic installations or distributions of Windows, only for Pro and Enterprise versions, because those are the fancy guys. So this is what it looks like: local group policy editor, and then under the computer configuration or the user configuration, you have individual settings, and it's all the same category: software, Windows, and administrative templates, so on and so forth. And then we have the password policies, which are all under the security settings, account policies, and password policies. So there's a lot of different stuff that you could attach to this. So both uppercase and lowercase characters, or numerical and special characters. Check the password against leaked or already hacked databases. This is a really, really big one. And I feel like this should also, all of these things should be implemented. This is like a basic level of password security, and all of these should be implemented. And in case of 6 failed login attempts within 15 minutes, the account should be locked for at least 1 hour. And a lot of companies have 3 failed login attempts. And that's to prevent brute force attacks from taking place. And again, just very, very basic password rules. And that should be standard to every single machine, especially in an enterprise environment. If you're like the security manager or the security engineer of a company, those should be the basic minimum rules. And these are some of the other ones that are here. So enforced password history. So 0 passwords remembered. Password remembered should be like the last 3 passwords, and somebody should not be able to just reuse the same password as they had the last 3 times or something like that. Maximum password age is 42 days, meaning after 42 days you need to change your password. The minimum password age is 0 days. That's kind of standard. Minimum password length should not be 0 characters. It should be like 10 or 12 or something like that. The minimum password length audit has not been defined, which in this case, because there is no minimum password length, there is no audit that's attached to it either. But if you do a minimum password length, the audit would be turned on. Password must meet complexity requirement. It's disabled here, and it should be enabled. And then relaxed minimum password length limits should not be relaxed. They should be disabled. Stored passwords using the reversible encryption, that should be disabled as well. So reversible encryption means that they can reverse the encryption of the password. And if you store the passwords using reversible encryption, that means that somebody could decrypt the password. So that's not good. Looking at setting a lockout policy is also under the account policy security settings, is under the password policy. No, actually, I think it's different from the password policy itself. So we can set a lockout policy to the account to lock after certain invalid attempts. And this is in the account policies, account lockout policy. And then you can say after how many attempts you want the account to be locked out. And that's very, very important. So what we're going to do is answer these questions and find the name of the administrator account of the attached VM. And so that is going to be, I'm just going to close this. And how do I get back to the top of my menu here? There we go. And so from here, we are going to go to Control Panel. And from Control Panel, we're going to go to user accounts. And then for user accounts, we want to go see what the name of our accounts type is. So let's see. Here we go. So the name of the account right here is Harden, which is the name of our old lab here is Harden. So, all right. And go to the user account control setting panel, which is control panel, all control panel items and user accounts. So we're going to go 1 and then 2 control panel. And then we're going to go to, it says all control panel items and then user accounts. So I guess this is it right here, which I mean, I was already there. What is the default level of notification? So let's go check that out. All right, so I mean, it's always notify, which is I mean, I could have guessed that. The way that they have it here isn't actually what it is inside of this system right here. So when you go to the actual control panel right here, there is no all control panel items that you can click on or anything. So if you just click on user accounts and then click on user accounts again, it'll give you these series of items right here. And then the one at the bottom, it says user account control settings, and that's the one that we want. And so when we click on that, it pops this thing up for us. And so always notify is going to be the answer, and I'm going to type that in, and that's it. So how many standard accounts are created in the VM? So let's try to see if we can find the standard accounts. So let's go back here and let's try to see if we can find any standard accounts here. I mean, on the user account settings, there's something that says manage accounts. And so if we go here, there's literally one account here. So let's see if this is actually, the answer is 1, I wonder. Okay, so 0? Yeah, okay. That, I felt like kind of like a trick question where it's like there has to be a standard user account, but there is no standard user. There's literally just one account. And then when we go to manage another account, there's also only a list of this just one account. And it's an admin account, which means that there is no standard user account. Okay, fair enough. All right, moving on to the next piece right here, which is our network management piece. All right, so here we go. Windows Defender Firewall under network management. It's a built-in application that protects computers from malicious attacks and blocks unauthorized traffic through inbound and outbound rules or filters. So it's basically a firewall. We already discussed firewalls in the last video that we went through. So this should be a review. If you haven't seen the firewall video, you should go watch the firewall video. As an analogy, it's equivalent to who's coming in and going out of your house. That's basically what the Windows Defender Firewall rules, inbound and outbound rules. That's what that means. So hackers will abuse firewalls by bypassing existing rules. If you've configured the firewall to allow incoming connections, they'll try to manipulate it to actually creating a remote connection to the victim computer through whatever port you've allowed to attack or have come in. You know what I mean? Whoever can access that by, we can access that by accessing the WF MSC, which is Windows Firewall MSC, and go ahead and pull that up. So we'll probably look at that in a little bit just to answer some of the questions here, but this is a screenshot for you, and it just opens it up, Windows Defender Firewall. And then from there, we're going to just see what the general rules are. It's all under the Windows Defender Firewall properties. And this is our public profile, private profile, domain profile, etc., etc., etc. There are 3 main profiles, which I just mentioned those. They have to be activated. A private profile has to be activated with the blocked incoming connections while using the computer at home. Detailed settings for each one of them could be available by clicking on the properties. And then whenever possible, you got to enable the default settings. And for blocking all the incoming traffic, it's always better to configure the firewall with a default deny. So default deny or explicit deny should be the rule, like the standard rule across the board for everything, meaning deny every incoming connection with the exception of the ones that you go and you allow. So excuse me, it's not explicit deny, it's default deny and then it's explicit allow. So you default deny everybody and then you explicitly allow a handful of connections to come in. And then you want to disable any unused networking devices. So routers, Ethernet cards, Wi-Fi adapters, access points, any of that stuff. Those things enable data sharing between computers, and if the device is not configured properly, or if it's not being used, then it's a good idea to just disable the thing so that anybody who's trying to attack you can't access those things and use them for data retrieval. And a lot of times if they're not being used or they're improperly configured, actually, so let's rephrase that. If they're not being used, there's a high chance that they haven't been configured recently, so they haven't been patched or updated, so on and so forth, and that leaves it open to a vulnerability. So if it's not being used, just shut it down or disable it so that you don't leave yourself open to a vulnerability, because then you have to update everything, you have to patch everything, and it just makes it easier for you to manage certain things or manage your list of assets that you're supposed to be securing by only looking at the things that are active and enabled. To disable the unused networking devices, we go to Control Panel, System and Security Settings, the System, and then Device Manager, and then you can disable anything that is not used. And so this is what it looks like in this particular case. You go to Device Manager and it shows you everything. You got everything from the Bluetooth to disk drives to the keyboards, monitors, and then you have network adapters. And so for all of the network adapters, these are the things that is available on this particular machine that they took the screenshot from. And so you can go ahead and try to see which ones you need to deactivate because of their lack of use or so on and so forth. So disable the SMB protocol. It's a file sharing protocol exploited by hackers in the wild. The protocol is primarily used for file sharing in a network, and it's the server message block protocol. And we've used this a lot in our exploits running Metasploit, where we've kind of exploited the SMB service or the SMB protocol on a Windows machine. And because of the fact that it's primarily used for file sharing, you have to disable it if your computer is not a part of the network by issuing the following command in PowerShell. So disable Windows optional feature. The feature name is SMB1 protocol. And that's one of those big ones because we've actually used it in a lot of cases to run exploits against the SMB, the file sharing server message block. And then we have the local domain name system, which is DNS. The domain name system is DNS. It's a naming system that translates fully qualified domain names into IP addresses. If the attacker places themselves in the middle, they can intercept and manipulate the DNS requests and point them to their controlled systems, since DNS replies are neither authenticated nor encrypted. And the host file is located in Windows acts like the local DNS. Or what am I saying? The host files located in Windows act like local DNS, and it's responsible for resolving host names to the IP addresses. Malicious actors try to edit that by rerouting traffic to their command and control server, their C2 server, and this is where the file, this is what the file actually looks like. So it literally opens up inside of a notepad. It's like a .txt file, and so these are the local hosts or the host on this particular computer, and the IP address for a local host on across the board with every single machine is 127.0.0.1, and then there's an actual IP address that's assigned to you by your router, and that's where this information goes. It's inside the DNS system or the DNS file. I try to like paraphrase a lot of these things by just looking at keywords and kind of reading, instead of reading word for word, I try to just like kind of glance through the sentence and try to give you a paraphrase, so it doesn't, I'm not literally sitting here just reading a freaking text on the screen. But sometimes I mess up completely what the meaning of the sentence is, like this particular sentence that I just messed up. I'm like, dude, what am I even saying? That doesn't even sound right. So anyways, Now we're going to talk about mitigating the address resolution protocol attack, which is address resolution protocol is ARP. You'll see that a lot. And ARP tables or ARP routing is what you'll see a lot. The address resolution protocol resolves MAC addresses from given IP addresses saved in the workstation's ARP cache. So MAC addresses are a layer 2 conversation or a layer 2 address, and then IP addresses are layer 3. And so the ARP cache connects MAC addresses to IP addresses. And the ARP offers no authentication and accepts responses from any user in the network. An attacker can flood the target system with ARP responses, which point to an attacker-controlled machine and put them in the middle of the communication. MAC spoofing, MAC address spoofing is very, very common. And it's one of those frequent attacks because it's really easy to spoof a MAC address. Not as easy as spoofing an IP address, although it is also easy to spoof an IP address. So it's very, very important to understand this. ARP entries can be checked using ARP-A in the command prompt. And then it's a different command inside of Linux, so it doesn't apply to Linux. But ARP-A, so ARP-A stands for all. And then you get to see what all of the IP addresses connected to MAC addresses are. This is an IP address. This is the MAC address. The table contains MAC addresses in the middle, IP addresses on the left, yada, yada, yada. If the table includes a MAC mapped to 2 IPs, you're probably susceptible to an ARP poisoning attack. To clear the ARP cache and prevent this from happening, you do ARP-D to delete or clear the ARP cache. Now, preventing remote access to the machine. Remote access, RDP, very, very simple. Remote desktop protocol is that port 3389, I want to say. I hope I'm right, but I think it is 3389 for RDP. We've done this a lot in our pen testing exercises. We've gone through a lot of exploits against Windows machines by using the RDP port and the RDP service. And this is something that you gotta plan for and you gotta mitigate for. So you gotta disable remote access by going to settings, remote desktop, and don't do this in the VM. I think if we do this, the VM itself is gonna crash because we're literally remote connected to that virtual machine. But it's something that you wanna do if you don't want anybody to have remote access to your machines. And it's very, very important. And if somebody does get remote access to a machine, or if you wanted to be able to get remotely logged into, you have to have explicit rules for the IP addresses that you're going to allow to connect to that, and times, and a VPN is probably in order. And there are a lot of different steps that you can take to ensure that nobody else other than the person that's been authorized gets to RDP into your machine, which is very, very important. So we're now going to answer these questions here for this task. Open Windows Firewall, click on Monitoring in the left pane. Which of the following profiles is active? Domain, public, or private? So let's open up the Windows Firewall real quick. All right, so here's Windows Defender Firewall, and we're going to click on Monitoring in the left pane here. There is no option called Monitoring, so let's see what we can find. That's interesting. So when you search for Windows Defender Firewall directly in the search pane at the bottom right here, it brings up this thing, which is not the same as Windows Defender Firewall with Advanced Security. And so I will close this thing. And the way that I found this one was I opened up the Run application and I searched for wf.msc. So that is the reason why we couldn't see monitoring, and there's monitoring. And now the question asks, which of the following profiles is active? So let's look at the active profiles. From the very get, it literally just says the private profile is active. So I don't think I need to look at anything else. I'm just going to type in private, and that is indeed the case, and that is the profile that's active. And so the next question here is find the IP address that's resolved for the website TryHackMe in the virtual machine as per the local host file. So we need to now go inside this this text file right here, which is for C yada yada yada. So I'm going to go and run this thing right here. So I'm just going to do run, and we're going to type that in here, C Windows we'll open it up with Notepad, and there it is. So it says TryHackMe. What is the IP address? That's been resolved to that, and that's the IP address for TryHackMe. So we're going to copy that thing and drop that over here, and voila. And so open the command prompt and enter ARP-A. And what is the physical address? So the MAC address. So command prompt is cmd.exe. And so we're going to do ARP-A, and we're going to get all this information here. And so for 255, yada, 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 what do we want over here? And this is it. So this is our piece of information here. Oh, I forgot that I can't right click and copy. So I think Control C should copy it. Not Command C, Control C. That's very important. There we go. We got it. All right, cool. So there you go. We got our info here inside the network management task. So let's go to application management now. And you got the application store. So actually it's the trusted application store. Microsoft Store offers a complete range of applications, so on and so forth. And those applications would not have made it in that store without being scanned, or I guess screened. I guess we could say screened or vetted for being a proper application, right? So malicious actors behind legitimate software with Trojans and viruses go ahead and upload it on the internet to infect and access the victim computer. So downloading applications from the Microsoft Store makes sure that the downloaded software is not malicious, because it's been vetted, and otherwise it wouldn't end up in the Microsoft Application Store. So it's very important to understand that, and don't download stuff from Pirate Bay or a lot of these other places, because believe it or not, there's hackers that upload things on there, and it could be a legitimate software. It could be something that you actually do need or want to use, and it's one of those things that you gotta consider, you gotta factor. I have downloaded Adobe Creative Suite, for example, from Pirate Bay before, and I don't think that something happened to me, and this was before I got into cybersecurity, so I never actually verified to see if there was anything that was installed on those things, and I never scanned an antivirus against the downloads that I had and shit like that. But something as simple or as known as Adobe Creative Suite could be embedded with malware or a Trojan or something that could be running in the background as soon as you install it, and now your computer is hooked, or there's something, ransomware or something that gets installed on your computer. So it's just something to note and something to be aware of. Safe application installation. Only allow installation of applications from the Microsoft Store, and then that's just another one of those things that when you turn it on as a setting inside of Microsoft, then it doesn't allow anything else to take place other than apps that have been downloaded from the Microsoft Store. And this is one of the things that I really have to take my hat off to Microsoft, that they've have all of these features installed in their machines that make it so that Microsoft is the premier choice across most businesses. Something like 90% of desktops and computers and everything like that in the business world is Microsoft. And the reason for that is because there's so many of these inherent security features that have been installed on these things that just make it a great choice for somebody to run a business. So removing malware through Windows Defender AntiVirus, it allows real-time protection, browser integration, application guard, which is web session sandboxing, which is really a big deal as well, to block malicious websites or sessions to make changes on the computer, which means in your web session, there's a sandbox type of an environment, which is a military term for essentially running a test inside a simulated type of an environment or a rehearsed type of an environment to make sure that everything's all good before you actually go into a live environment. And so in cybersecurity, a sandbox is something that if something runs inside that sandbox, it doesn't infect or affect the rest of the system, because the sandbox opens it in there, and then you're like, oh, this is malicious, you shouldn't mess with it. And so that's really amazing that they actually have this in the web session, meaning inside of a web browser, to block malicious websites or sessions, so on and so forth. So, and then controlled folder access, protecting your memory areas in the RAM and folders from unwanted applications. All of these things are really, really amazing stuff. And we did talk about this in Windows Fundamentals. So then you have Microsoft Office hardening. There's something called macros that can be in the metadata of PDF files or text files and stuff like that. So disabling macros is very important so that nobody can actually install malicious code inside of the macros of the file. And this is one of those things, again, that you see a PDF file inside an email and you think it's fine and there's nothing wrong with it. And then as soon as you open up that PDF file, the macros, the code that's embedded inside those macros, goes and releases whatever the Trojan is or ransomware, anything like that. And that just is a big freaking pain in the ass, let me tell you. Banks can't disable macros because they heavily rely on complex invoices and formulas, but universities can disable them because they don't need all the complexity that banks need. The attached VM contains a batch file based on best practices and Microsoft Attack Surface Reduction rules for hardening Microsoft Office. To execute this, right-click on the file that's on the desktop and run it as an admin, and it will go ahead and run it. So let's do that. Let's actually go and run this thing because I don't know how long it's going to take for it to actually run. So office.bash, here we go. And we're going to run it as an admin. Yes, give it permission and let that thing run. And then we'll go into App Locker, which is our next piece. It's recent and it allows you to block specific executable scripts and installers from execution through a set of rules. And we can configure this through the local group policy editor by the following method. So it's under Windows settings, security settings, application control policies, and then App Locker. And then you can configure the rule enforcement of the App Locker and where it can and cannot run. And then when you do that, it opens up the executable rules. So when you go through App Locker to block a file based on the publisher name, and then there you go. This is kind of what it looks like. And it might have us actually run this as well just to see what it can do. And WinRAR is one of those things. And then there you go, file name. And now you have the rule that's been placed for executables. So it's super user friendly. And then when you go and try to run WinRAR and then you say run, it says it's been blocked from your system by the administrator. Right, so you go to executable rules under App Locker, just as a review one more time, click to create a new rule, and then you just go through the wizard and you want to deny access to that rule, and based on the publisher, or deny access to the executable, excuse me. And then so the reference file that you're going to need to refer to is the WinRAR, and then by the file name, and that's it. So very, very, very user friendly. Microsoft Edge is a browser that's available on Windows based on Chromium, in line with Google Chrome, and Brave, which is similar to Tor because it actually runs on a proxy and provides security and privacy. So it often acts as an entry point to a system for pivoting and lateral movement, and those are pen testing terms. And it's therefore of utmost importance to block and mitigate critical attacks carried out through a browser that includes ransomware, ads, unsigned applications, Trojans, stuff like that. Protecting the browser through Microsoft's Smart Screen is, I have actually never even heard of this. So it helps you protect from phishing, malware sites, and software when using Microsoft Edge. It helps to make informed decisions for downloads and lets you browse safely in Edge, displaying an alert if you are visiting a website that's suspicious, vetting downloads by checking their hash, signature, etc., protecting against phishing and malicious sites by checking visited websites against threat intelligence databases. This is huge. This is like a really big deal. And so if you want to turn this on, Smart Screen, you go to Settings, Windows Security, App and Browser Control, Reputation-Based Protection, and scroll down to Smart Screen, and then turn that thing on right here. That is so freaking awesome. Then you open Microsoft Edge, go to Settings, and in Privacy Search Services, set Tracking Prevention to Strict to avoid tracking through ads, cookies, and etc. And that again is also really freaking awesome that they have this. So very, very cool. Let's answer these questions. Windows Defender Antivirus is configured to exclude a particular extension from scanning. What is the extension? So let's go to Windows Defender Antivirus one more time and see what we have blocked here. So, okay, so this one was not inside of this thing. It wasn't inside Windows Defender Firewall with Advanced Security. It's actually inside Windows Security itself. And then there's the shield icon right here, which is virus and threat protection. And then when you go there, there is virus and threat protection settings. And so we go to manage settings. And then from here, we need to find something called exclusions. And then we do add or remove exclusions. And then it shows you what is already on the exclusions list, which is a file type. And that is .ps. And there's our answer. So very good. Now, a Word document is received from an unknown email address. It is best practice to open it immediately on your personal computer, and that would be nay. What is the flag that you received after executing the Office hardening batch file? Oh, I see. So let's go and check. Did I close it? I think I closed it. Let me see. I did close it, darn. Okay, so I will go, I'll run this again. I didn't even notice that. I will run this again. And where's our flag here? All right, here we go. So just so you know, when you right click on this and then run it as an administrator, that didn't work for me. So what I did was I searched for cmd.exe in here, and then I right clicked on this and ran it as an administrator, and then I went and ran the office .batch file. And it finished, and then here is the flag. So THM 110 and there we go, bunch of ones and zeros. That's all we need. So there we go, we finished it and we ran that, and it is now complete. So let's press enter or something, press any key. There we go. Okay, cool. So let us now move on to storage management, which is the task number 6. All right, storage management, encryption through BitLocker. Okay, I've heard this before. Encryption of the computer is one of the most vital things to which we usually pay little attention. The worst nightmare is that someone gets unfettered access, look at that, that's a good word. Unfettered access to your device's data. Encryption ensures that you or someone that you share the recovery key with can access the stored content. Microsoft, for its business edition of Windows, utilizes the encryption tools by BitLocker. So let's have a quick look at this. And it's on the home edition of Windows 10, and we've read about it in Task 8 already. So, actually this is not, I don't think this is this Task 8. I think it's for the Windows Fundamentals Task 8, which we went through and looked at BitLocker right here at the bottom. So we can go to Start, Control Panel, System Security, BitLocker, Drive Encryption, and see if the option to BitLocker Drive Encryption is enabled or not. And that might be something that we do have to check out. So let's see, we do need to check out. So let's, instead of going through the whole thing and then restarting all these things again, I'm actually just going to go ahead and open BitLocker, and from there we'll see what we can do here. So open BitLocker. Oh, there's a BitLocker recovery key that was there too. So BitLocker is off in our case, and then fixed data drives, so BitLocker on, so on and so forth. We don't have any of these things because we're on a virtual machine. So let's see what the question down here says. As security engineer, configured the attached VM and stored a BitLocker recovery key in the same computer. Yeah, we just saw that. can you read the last 6 digits of the recovery key? So that's where it was actually. So BitLocker, where was it? Not BitClocker, BitLocker. BitLocker, come on, I saw it. There was a recovery key. All right, so there it is. It is inside our documents folder. So I'm gonna open up Notepad as an administrator just in case I need access to it as an admin. And then we're gonna go to File and open the file. And we're gonna go to our Documents folder. So which Documents folder is it in? Because it says this PC Documents, and there it is. So let me see. Let's try it one more time. File, open. We're gonna go to this PC, and inside of the this PC, we're gonna go to Documents, and there it is. Okay. Here we go. And there it is. And so now it says, what can you read the last 6 digits of the recovery key, which is this thing right here. So 377564 is our recovery key, last 6 digits. How many characters does the BitLocker recovery key have in the attached VM? I don't know. So 6 times 1, 2, 3, 4, 5, 6, 7, 8. So that would be 64. Oh, wow. Jesus. Oh my gosh. That's embarrassing. 48. That would be 48. I can't even do basic math. You know what's funny? I have to do basic math in Farsi because I remembered my multiplication tables in Farsi. So it's actually really hard for me to do it in English. And so whenever I read something like this, I literally translate it to Farsi in my mind. And then I go ahead and get the result. So I did it at first in English and I was like, no, that's not right. And then I did the Farsi multiplication and I was like, that's what it is. Okay. So anyways, backup file is placed on the desktop on the attached VM. What is the extension of the backup file? And that's BAT, right? Isn't that what this is? Or maybe it's not the BAT file actually. It's my Windows backup. Yeah, there we go. BKF. That's what it is. And I mean, I didn't even need to do the rest of the contents, but let's go through the rest of the contents. Why not? So that was BitLocker. We have Windows Sandbox, which is, we already talked about it earlier in this task, so I'm not going to go too crazy into the definition of it. But there is something called Windows Sandbox, and you can install it in the safe environment, and it's not a part of the host machine that we have. It'll remain sandboxed. Once the Windows Sandbox is closed, everything, including files, software, and states, will be deleted. And we would require virtualization enabled on the OS to be able to run this, and we cannot try this in the attached VM that we have. But steps for enabling the sandbox feature are like this. So you click Start, search for Windows features and turn it on, select the sandbox and click OK to restart it. Windows Sandbox will be included in the Windows distribution itself. If you want to close it, you click the close button and it's going to disappear. Opening suspicious files in a Windows Sandbox before blindly executing them is recommended. And this is, again, another one of those things that's really awesome that Windows does. So Windows Secure Boot, an advanced security standard, checks that your system is running on the trusted hardware and firmware before booting, which ensures that your system boots up safely while preventing unauthorized software access from taking control of your computer, like malware. You're already in a secure boot environment on our virtual machine here anyways. If you run a modern PC with Unified Extensible Firmware Interface, UEFI, the best replacement for BIOS or Windows 10 basically. And you can check the status of it by going to the MS Info 32 and then see if you have secure boot off or on. So just to kind of check this one for ourselves, we can go ahead and do that. So if we go to, we're going to do run one more time here. And from run, we're going to search for MSInfo 32 actually. So MSInfo 32. And then we're going to look for secure boot. And secure boot is unsupported in our case. So it's not even supported in this case. And BIOS mode is legacy. So yeah. In this particular case, it's not supported. I think it's because it's a virtual machine. So that's probably the reason why. Then you want to enable file backups. So it's not the least important one, definitely, but it is the last option that we're talking about here. And you want to enable file backups because sometimes shit hits the fan and you want to make sure that you have backups regularly. And if you lose essential data files, you can recover them by restoring your actual computer through the last backup that you had. And you can do daily backups, which is very recommended, especially if you're running on a computer that is very important and has a lot of information that's necessary. And it's just the best thing to avoid disasters like malware attacks or hardware failure. And you can go to settings, update and security, and backups to do backup using a file history. And then adding a drive is also really good to have as kind of like a one of those things that it won't save on the actual local computer's drive to take up space on the local computer. It will just go into the drive that you have dedicated specifically for your backups. And that way it'll just be guaranteed that you won't have any issues. So the most convenient option is enabling it from the file history option, a built-in functionality of Windows 10 and 11. And we've already answered our questions, so we don't even need to worry about that. So let's go into updating Windows, and then it's one of the quick ones, and then we're gonna get our little cheat sheet, and we will be out of here. All right, so updating it's super freaking basic and understandable. The main reason why you want to update is that hackers are continuously trying to find new exploits and new ways in. And there's literally an entire industry dedicated to penetration testing and companies that make billions of dollars for being hired to do penetration testing exercises so that they can find different ways in. And Microsoft will even pay you if you find different ways into their most recent distributions. And that's actually genuinely something I'm considering to do as a career path, just by getting really good at pen testing and kind of attacking vulnerabilities and trying to find new vulnerabilities and new exploits and stuff like that. So every time that something like that happens, Windows and every other distribution, so Mac OS and all these different companies, they create updates. They come up with a new update that has patched that vulnerability, and then they release that update. And that is very important to consider when you are the security engineer of a company. Like your distribution of Microsoft Windows should be updated at all times, and automatic updates make that easier. At least update notifications should be turned on so you know what's going on. But all of these things are usually patched and taken care of as soon as you just create, or as soon as they create a new distribution and they do an update release. And that's sometimes the biggest thing that you can do to make sure that the system is secure, is just making sure that you have an updated version of the OS and you install an updated version of the OS. So really basic, but extremely powerful. And if you just go to update and security inside the control panel, you can check for updates and it'll tell you whether or not there's a new one. And then, you install it as you have it. You can turn on automatic updates. If you don't do automatic updates, I recommend that you check for updates daily, maybe even multiple times a day, once in the morning, once before you leave, just to see if everything's all good, and then run it again, right? So that's it for updates. Users who run the older Windows versions are always at greater risk and vulnerable to new security threats, so be careful about that. And that's all, again, just make sure that you have the most recent version and the most recent update. So what is the CVE score for the vulnerability CVE 2022, which was literally a couple of years ago? Let's search Google for this thing and see what we can find from the NIST website. What is the vulnerability score for this thing? So we have 7.5 or, whoops, I shouldn't have clicked on it, 7.5 or 7.8. So the CVS version, Common Vulnerability Scoring System, version 3 point whatever or 2 point whatever. So I wonder which one they're grading it by, but it's basically either 7.5 or 7.8. So let's see what we get here. I'll do 7.5. Whoops, do one dot. And that's not it, so they're going by the CV2.
So there you go. And that is the severity of that vulnerability. And if we just look at it real quick, we can see what this thing even is. So Microsoft Windows Server Message Block version 3 suffers from a null pointer dereference in versions of Windows prior to the April 2022 patch by sending a malformed file normalized name information request over a named pipe. An attacker can cause a blue screen of death crash of the Windows kernel. For most systems, this attack requires authentication, except in the special case of Windows domain controllers. Wow. Where the unauthenticated users can always open named pipes as long as they can establish an SMB session. Wow. Typically, after the BSOD, the victim server will reboot. That's gnarly when you think about that. Holy shit. This part is actually really crazy. So, except in the special case of Windows domain controllers, which is literally the highest privilege account on a Windows Active Directory, and they don't need to authenticate themselves, or at least they didn't need to prior to this. That's insane, yo. Okay, anyways, so that's it for that updating Windows. So let us look at this cheat sheet, and I'm gonna download mine. All right, so here's what we got. Is your system still at risk of a security breach? Hardening is a never-ending process. It's continuous. So you can't ever say that your job is done and your system is now fully protected, because there are attackers always trying to find a new way in. So you gotta try to figure it out, right, all the time. So we have to be active and smart-minded to participate in the continuing process. And we must keep in mind the defender's dilemma, which states that breaches are inevitable. Because defenders have to be right 100% of the time, whereas attackers only have to be right once. And in this room, we've learned a lot of stuff. And this is our cheat sheet. I already downloaded it, and this is exactly what it looks like. So this is exactly the PDF. So identity access management, network level, application level, storage, these are the basic actions that you need to take to just make sure that all of this stuff is taken care of. And as we went through the password policy, you saw what all of the different things were to secure a password. So it's not like it's just saying use a strong password. You need to make sure that you actually create different levels of security for that password group policy. And then apart from that, use multi-factor authentication or physical keys or any of those other things to just make sure that it's not only the password that is being used. So very, very cool little cheat sheet. And that is it for our room. And we are now officially done with this. And we can move on to the very next task that we have, or not the next task, I guess, the next specific room in our path for security, which is going to be the Active Directory hardening room. If you are studying for your security engineer certification or security analyst, Pentest Plus, ethical hacker, any of those things, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video drops. We talk about all of that stuff on this channel all the time. And the information is actually very applicable to your certification exams and your day-to-day job as a security engineer, for example. And TryHackMe is the place for millions of people who are studying security engineering. It's literally, they literally have millions of students. And it's just one of those places that I think is very, very valuable to be a part of. And if you're not a part of it, at the very least, check these videos out, because these videos are going to help you. And I have spent a good amount of time on TryHackMe to actually get myself into the top 1%. So it is a little bit of a flex for me. I am 11,297 out of the 2 million plus users that are on TryHackMe. So I really do find this a very, very useful website. And if you're not going to get your membership, which there is a free membership and you can get a discount through the link below for the paid membership. But if you're not going to get that membership, at the very least, subscribe to this channel so that you can get all of this information that you can use as your job on a security engineer or for your certification exams. So apart from that, it would just be really nice to have you as a part of our community. We would love to see you in the comment section. And if you got any questions, drop a comment. If you just want to say hi, drop a comment, yada, 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 blah, blah, blah. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker slash protector. This has been the room for Microsoft Windows hardening as a part of the network and system security module for the security engineer pathway of TryHackMe. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next room. All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, and we are on our security engineer pathway. We are going to go through the Active Directory hardening room, which is a part of the network and system security module for security engineer pathway of TryHackMe. And yeah, so this is what the room outline looks like. We got the intro, the understanding general Active Directory concepts, securing authentication methods, implementing least privilege model, the Microsoft Security Compliance Toolkit, protecting against known attacks, and the Active Directory hardening cheat sheet, which is always nice to have. So let's jump into this. Actually, just got to make that quick disclosure. So if you're studying for a security engineer or security analyst, ethical hacker, pen tester, any of those certifications, I do encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time a video comes out. TryHackMe is pretty awesome with their information, and all this stuff is directly applicable to your examinations as well as your day-to-day of the security engineer job, for example, or security analyst, any of those things. And on top of that, it would just be really nice to have you as a part of our community, because we have a really nice, awesome, growing community. And I love seeing you guys in the comments, and I do make custom content based on the questions that come in. So would be awesome to see you in the community comments. And yeah, that's pretty much it. So now, without further ado, let's jump into the introduction of the room. And I got to start this machine here. And it's going to be a Windows machine, obviously. So these are some of our learning objectives here. So we want to make sure that we secure authentication methods, hosting or securing hosts through group policies, implementing the least privilege model, protecting against known attacks, and a recovery plan just in case you actually get compromised. There's the Active Directory Basics video that I already did, which you are more than welcome to go check out. We have breaching Active Directory, which I also have already done, and the standard technologies used in the corporate environment. Is this a room that I did? No, I did not do this room yet. So this is really cool. I can probably go check this out as well, but I have not done this particular video. But you do have access to the Active Directory Basics and breaching AD. And so this is this is our channel page. And then if you just click on this search button right here, you can literally search for Active Directory, and then it'll bring up all the videos that we have on Active Directory. And this is the Windows playlist that has 28 videos in here that you can go get access to. So there's a lot of stuff that is already on the channel for Active Directory, and you're more than welcome to go check all that stuff out. And I highly recommend that you do, because if you haven't already done it, let me pause this thing. If you haven't already done it, there's a lot of good information just about Active Directory. So I do recommend that you go check it out. And by now, our IP address has already been issued to us. If you wanted to VPN or remote desktop, if you wanted to remote desktop into the Windows machine, this would be the credentials for it. But you do need to have access to the room so that you can go turn on that machine, that start machine button, so that it actually generates an IP address for you. And then that's basically it. So I have already started this. It takes maybe another minute or two, not even, probably should be up pretty quickly. And then once that's up, we'll jump into the actual content of the room. All right, so just understanding some basic Active Directory concepts is pretty important here. So there's the domain, which acts as a core unit regarding the logical structure. So everything belongs to the domain, basically. That's kind of what you need to know. Everything under the hierarchy of Active Directory falls under the domain. And then there's the domain controller, which is a server that acts as the brain for the Windows Server domain. And it supervises the entire network. And within that domain, it's going to act as the gatekeeper for the authentication of users and resources authentication, and a lot of other things that kind of fall under that path. And so you see the user tries to access the domain. The request is first sent to the domain controller, and then the domain controller validates that request, and then the domain controller grants access if it's a valid user. If it's not a valid user, they deny access. Now, a tree and a forest are two critical concepts in Active Directory, and a tree is a set of domains. A forest is a set of trees. So typically what it looks like is that you would find a domain inside of a tree, and then if it's a really big company, you'll find a tree inside of a forest. And companies like Microsoft, you better believe they have, probably dozens, if not hundreds, of forests. And it could be either for each state, or it could be for each country that they operate in. So a forest has a bunch of trees in it, and a tree has a bunch of domains in it. And then you can find the organizational units and things like that. Are we going to talk about any of that stuff? Yeah, we don't talk about any of those things yet. But there's a lot of stuff that are within domains themselves. Trees are responsible for sharing resources between domains. The communication between domains inside a tree is possible either one-way or two-way trust, meaning tree A trusts tree B, and that means that tree B can access everything inside of tree A. That's a one-way trust. If it's a two-way trust, they both trust each other and they both can get access to the resources that each one holds. When a domain is added to the tree, it becomes the offspring domain of that particular domain to which it is added. So it's called a parent domain, right? So the tree itself is technically a domain. You add a domain to that tree and it becomes a child item. It becomes a child domain of that tree, which is now the parent domain. And in a forest, sharing the standard global catalog, directory schema, logical structure, and directory configuration between collections of trees is done through a forest. And communication between two forests becomes possible once a forest level trust is created, and it could be the same thing, right? And then you have trust in Active Directory, which can be done either based on characteristics or based on directions. So characteristic trust is categorized as a transitive or non-transitive trust. Transitive trusts reflect a two-way relationship between those domains. If there are three domains, domain A trusts domain B, and domain B has a transitive trust with domain C. Consequently, domain A will automatically trust domain C. So transitive basically means that everybody trusts each other. And then the trusts are two-way types when classified based on their direction. So one-way or two-way trusts, and we already kind of discussed that already. Non-transitive in this particular case would just mean that they don't trust everybody as it goes along. It's specifically assigned to one or the other, or which one gets access to which one, so on and so forth. And so if you go to the Server Manager Tools, Active Directory Domains and Trust is where you can see all of that information. And this is a screenshot for us to be able to see that. So Active Directory Domains and Trusts, and then you click on the top of the tree, the top of the hierarchy, and it shows you everything that's available inside of it. And then you can just break these down. So this would be just one specific domain, and then inside that you have, or this is one tree, I guess, and inside that you have the domain, but then you could have dozens or hundreds under this thing. So it makes it actually very, very easy to manage objects and organizational units and stuff like that. And then this is where containers come in. So when you create a container, it's also referred to as an organizational unit sometimes, and each part or each network part is treated as an object in AD, and anything from resources, users, services, or part of the network can be an object. And the hierarchical structure of AD defines an object may or may not contain other objects, and when an object holds another object, it's termed as a container. So it's called the leaf object. So what is the root domain attached to the AD machine? So let's actually go and pull this thing up, and let's see if we can do it. We'll do it two ways. So we're going to open up Active Directory, And it's right here. So tryhackme.loc for local, probably. Tryhackme.loc is going to be our domain. And I want to see if we can do this through PowerShell as well. PowerShell is actually much faster, in my opinion, when you want to get this kind of information. And the commands are pretty simple when you learn them. So get AD domain. If I just type that, that should just give me my information that I need. And there we go. We got it. So you see it right here, where it gives you the domain DNS root, which is za.tryhackme.loc, but then you actually have the tryhackme.loc that ends up being your forest. Look at that. It says it right here as well. And then you can go out and do, depending on the version of this. So let's see if we can do get AD forest. Yeah, there you go. It also gives us get AD forest as a command, and then you can get the name like that. So the root domain in this particular case is the forest that they're referring to. And then that was our answer, which is tryhackme.loc. So let's go into securing authentication methods. All right, so there are a few things that we're going to learn about authentication methods in this particular task. We're going to use the built-in tool called Group Policy Management Editor, and it's attached or available in our AD machine right here for configuring various security policies. And the instructions are as so. So I guess we can just open up the server manager, and from server manager we can go to group policy management, and then we can start editing specific parts of this. So let me go ahead and just open up the server manager real quick so that we can go through that. There it is, and they just clicked on it inside the start menu, but I'm going to search for it. And then once it's opened, it's going to take a couple of seconds for it to open. All right, now that it's opened, we're going to go to the tools right here. And from tools, we're going to just choose group policy management, which is right there. And then that's going to open up another window for us. And from there, we can go look at the various policies and kind of manage them. So I can click on default domain policy. I can edit the default domain policy, and then everything else that would have to do with that, and so on and so forth. So I'm not gonna mess with this right now, but that's how we kind of get into the group policy management editor. And then in here, the very next one that we're going to look at is the LAN manager hash. So the user account password for Windows isn't stored in clear text, it's stored in hash representation. And it's basically a bunch of alphanumeric characters. So 15 characters, nothing, what does it say? So it says with the password for any user account, when it's changed or set fewer than 15 characters, both LM hash and NT hash are generated by Windows and can be stored in the AD. The LM hash is relatively weaker than NT and is prone to fast boot attacks. The best recommendation is to prevent Windows from storing passwords in the LM hash, so you can access it through the following. So group policy management editor, computer configuration, policies, Windows settings, so on and so forth. So let me actually go and actually do that. So group policy management editor, computer configuration, is that part of our piece right here, domains, it's right here. So it's actually inside of this thing. So computer configuration, and then from computer configuration, we're going to go to policies, and from policies, we're going to go into Windows settings, and then let me see if this thing is going to load or it's going to be slow. From Windows settings, we're going to go into security settings, and from security settings, we're going to go into local policies, and from local policies, we're going to go into security options, and then we're going to go into network security. So let me make sure that I'm in the right little space here. And so double click network security, do not store LM hash value network policy. So network security, and there's a bunch of options for network security here. So we need to find the one that says do not store the LAN manager hash value on next password change. And that's the one that we want. So we're going to double click that. And then it says select define policy setting. So set policy, security policy setting, define this policy setting. It's already turned on. And so in this particular case, it's enabled. And I think there's a specific thing right here it says change the group policy setting in the VM so it does not store the LAN manager hash on the next password change. So we're already here and it should already do it. So do not store the LAN manager, define this policy enabled, so you do not want to store it, and we already have that, so that should be good. Then it says what is the default minimum password length in the attached VM, and we need to find that in the password settings, and that's also going to be under security. And so let's be, without getting ahead of ourselves, because it's going to be part of this thing that we're going to look at, so we're going to go ahead and check that out. So the next piece is SMB signing. So we did LAN manager hash. So SMB signing can be found in security options, Microsoft Network Server, digitally signed communication. And let's go try to find that Microsoft Network Server, digitally signed communication, always. That's the one that we need to double click. And then it says select enable digitally signed communications. So define this policy and then enable digitally signed communications. And we're going to make that applicable. You're about to change the setting to a value that may affect compatibility with clients. Yeah, that's fine. We want to do that. And I want to be enabled. And this stands for server message block. So SMB stands for server message block. Microsoft-based networks utilize this for file and print communication. We talked about this in the last video. It allows secure transmission over the network. Configuring signing through the group policy is crucial to detect man-in-the-middle attacks that may result in modification of SMB traffic in transit. SMB signing ensures the integrity of data for both client and the server, and all supported versions have an SMB packet signing option. So we already turned ours on, so that's great. And now we can go to LDAP, which is Lightweight Directory Access Protocol, and enables locating and authenticating resources on the network. Hackers may introduce replay or man-in-the-middle attacks to launch custom LDAP requests. Therefore, signing is a simple authentication security layer, SASL property, that only accepts signed LDAP requests and ignores any other request, which is plain text or non-SSL. And we can enable this by going through that specific thing. So it's going to be security options, domain controller, LDAP server signing requirements. So domain controller, LDAP server signing requirements. There we go. And then you want to define that, and then we want it to require signing. So there we go. Boom, and we got that. So there you go. Bam. So password rotation. So here's another one that's kind of a big deal, right? So password rotation, Active Directory password security is critical to address because of the security breaches and password reuse. It becomes challenging for any organization to reset account passwords or update them everywhere, so they prefer not to do it. In this scenario could have a few alternate approaches. Each method has pros and cons. So first technique is creating a script to update passwords automatically in the scheduled task with the help of PowerShell. This does not require any additional overhead and removes all the manual efforts for password rotation, but it requires you to write and maintain the script, which could be challenging, especially if you don't know how to do that. The second technique would be add multi-factor authentication and choose not to change the password often. It adds a security layer and you won't need to change your password often, and you can learn about why that is great or not good. And the third technique is Microsoft provides a solution for services account password rotation through group managed services accounts, which changes passwords every 30 days or so. And that's probably the best thing that you want to do, and maybe even combine these two, because this is kind of like a good approach, is to have multi-factor authentication as well as a password rotation requirement that every 30 days or however many days it actually gets changed, that they force the user to change their password. And then we have the password policy itself. So it's under Windows settings, security settings. So security settings right here. And then we're going to go to account policies, which is this thing, and password policies inside the account policies. And in this particular case, it says what is the default minimum password length in this particular case. And if we go here and you look at minimum password length is 7 characters, which is pretty weak, honestly, when you think about it. So 7 characters, and that was it for the password policy. And password signing policies, just to kind of get an understanding. Enable or enforce password history prevents at least 10 to 15 old passwords from being set as new ones, which is really good. Minimum password length. The minimum password length should be set at least 10 to 14 characters. and complexity requirements must not contain the name of the user account and ensure that the password has uppercase, lowercase, and digits or special characters inside it. A lot of people actually use their username as their password, which is also really, really bad. So, okay, so now we can move on to implementing least privilege, the concept of least privilege. All right, so let's talk about this. The least privilege model requires limiting the user or application to the minimize security risks and attack surfaces to access those things minimally at the lowest level that they absolutely need and nothing more. When the application or the user is allowed to operate with administrative privileges, they grant access to everything to modify things, alter things, create new things, or perform any action that an admin can actually do. And contrary to this, the least privilege model is the very, very opposite. So they don't get very many privileges, the lowest number of privileges that they would actually need to be able to do their job. And the advantages are pretty immense, right? So it prevents malware spread, minimize cyber attack chances, improves productivity, demonstrate compliance, and aids with classification of data. So creating the right type of accounts is very important. When you create a new user, you just want to make sure that they only get the privilege that they need, and you don't have to go back and fix something that was done that shouldn't have been done. So implementing the least privilege model requires setting up different account types for diverse purposes. So you have user accounts to promote using a regular account users for most people in the network, and it's unnecessary to perform regular duties, or excuse me, who are necessary to perform regular duties, not unnecessary, who are necessary. So user accounts do regular stuff, basically. Regular user accounts to do regular duties. Privilege accounts are accounts with elevated privileges, and they're further classified as the first and second privilege accounts. And then you have shared accounts that are shared amongst a group of people as the visitors with bare minimum privileges like guests to give limited access to a specific time or specific resources, those things. These accounts are not recommended and must be utilized in limited scenarios. And libraries have these. There's like guest accounts that you don't need login or anything like that. Shared accounts are, they don't need to be in every business. So if you have a shared account, or if you just got signed on to a company and you see that they have shared accounts, figure out why they have them, and if you don't need them, get rid of them immediately. Then you have RBAC, role-based access control on hosts, which can be simply defined as the permission that somebody gets based on their role. So management would have different permissions than a new person, like a teller. So a teller of a bank is, the lowest rung on the ladder, as you can kind of imagine. And then the branch manager has the most privileges in that specific branch. And then there's the district manager, right? And then there's the CEO of the bank. So the higher you go based on your role, you have more access to the environment, to the resources of the environment, so on and so forth. Per Wikipedia, so the official translation of Wikipedia, is the principle of minimal privilege, or the principle of least authority requires that in a particular abstraction layer of a computing environment, Jesus, every module, such as a process, a user, a program, depending on the subject, must be able to access only the information and resources that are necessary for their legitimate purpose. So a very long-winded, complex way of saying basically what I just said. Role-based access control allows you to indicate access privileges at different levels. It includes DNS zones, the server, or a resource record levels, and specifies who has access control over creating, editing, and deleting operations of various resources of Active Directory. Then you have the tiered access model that comprises plenty of technical controls that reduce the privilege escalation risks. So there's a logical structure that separates assets by creating boundaries for security purposes. The primary goal is the protection of the top valued identities, which is the tier 0 identities. And at the same time, domain members and other users can perform routine tasks such as checking email, internet, yada, yada, yada. And those are tier 1 and tier 2. And there are 3 tiers, 0, 1, and 2. So tier 0 is top level, includes admin accounts, domain controllers, and domain groups. Tier 0 would be domain member applications and servers, and then tier 2 are the end users devices such as HR, sales staff, non-IT personnel. And this is what the screenshot for that would look like. Then to implement this is based on the principle of prevention of privileged credentials from crossing boundaries either accidentally or intentionally, and implementing technical controls via GPOs, group policy objects, is crucial to avoid such scenarios. And group policy objects put together the security rights that can deny access or grant permission, and we can read more about those inside the EAM, which is a Microsoft Enterprise Access Model article here, and very, very fancy. I'm not going to read this, but it's available to you. Enterprise Access Model, it's an article on the Microsoft documentation or the Microsoft Learn website. Then you have auditing of accounts. So it's a crucial task that mainly carries out by the correct account, meaning the admin account, assigning privileges and applying restrictions. There are 3 audit types: usage, privilege, and change audits. Usage audits allow monitoring each account's specific task and validating their access rights. A privilege audit allows you to check if the account in the system has the least privilege. And then change audits allows you to look for any improper changes to permissions, passwords, or settings, and any unacceptable change may lead to a data breach. So change audits are things that somebody could have breached your system, assigned themselves a new user, and given themselves permission, and then you see that a change audit was done, and then you're like, who did this? Why did they do this? And then you try to figure out if it was actually authentic, like authorized or not. So computers and printers must be added to tier 0, yay or nay. We're going to say nay to that. Suppose a vendor arrives at your facility for a 2-week duration task. Being a system administrator, you should create a high privilege account for him. And that's also nay. Dude, why? Why would you give the vendor that information? Jesus. Okay, let us now go into the next piece right here, which is Microsoft Security Compliance Toolkit. The MSCT, Microsoft Security Compliance Toolkit, it's an official toolkit by Microsoft to implement and manage local and domain level policies. We don't have to worry about complex policy syntaxes and scripts. Microsoft will provide pre-developed security baselines for the end user environment. You can download MSCT from their official website link, and you can find all the baseline policies analyzer software on the desktop scripts of our attached machine. So inside of this thing is where are the stuff that we're going to be using, probably is going to be. So installing security baselines, Microsoft offers security baselines readily available in consumable formats like group policy objects, backups. You can easily download it as a zip file and extract the content, and you can download and install the security baseline for Windows Server in a simple way. Go to Microsoft Security website, that link that they gave us, click download, click Windows Server Security Baseline zip, and then download, and that's it. Very, very simple. Open the extracted folder, and then scripts, and then select the desired baseline and execute with PowerShell and the policy analyzer. So let's see if we need to do this actually. So policy analyzer, there we go. Policy analyzer 4.0. And then you have the policy analyzer executable inside this thing, which is right here, and add manage local level policies. So be careful while downloading security baselines, as they should only be downloaded from the official Microsoft website. So find and open the baseline local install script in the PowerShell editor. Can you find the flag? So baseline local install script. So let's go back to scripts here. Security policy baseline. Find and open the baseline local install script. So let's see what I can do. Local script, baseline local install, and then we're going to run it with PowerShell. Okay, I see. So I was trying to actually run this instead of opening the actual script file to look at the script contents, and I was literally opening it inside of PowerShell, and I kept trying to run it. And I was like, why isn't it working? But you're not supposed to run the script. You're supposed to look at the contents of the script. And the way to do that is to open Windows PowerShell ISE, which is the editor And then from there, you can click on File and then open the file so that you can see the contents of the file. And here's the contents of the file. So now what I need to do is I need to find the flag, which is typically, they have a very similar, right here, so flag. Usually it starts with THM and inside these squiggly brackets, and that is the content of our flag. There you go. And so find open merge policy rule script, which is inside the policy analyzer, and then find that flag. So we're going to go here and we're going to do the same thing. So open, and then we're going to go back to the one more. We're going to go to scripts and then policy analyzer, and then find that script, which is the merge policy rule, which is this thing, and open this thing and go in here and try to find this flag. And right there at the very, very top, so that is the flag that we got here. So there you go. We got the flags. And now let us continue on and the last or second to last task here, which is protecting against known attacks. If an intruder successfully gains domain admin account access, you got to consider that the game is over. No one is ever ready to disclose the company's confidential data for financial loss or for financial loss. Before we discuss some known attacks, it's crucial to think like an attacker and develop a mindset wearing their shoes. And there's some already developed interesting rooms to this. The zero logon, have not done that one. I've done breaching AD, I've done exploiting AD, I want to say, and I think I've even done post exploitation. So let's see. Breaching, no way, I thought I did this already. Okay, I have not done breaching AD. Exploiting AD, I have not done either. And I haven't done post exploitation. Okay, so I mean, dude, I totally thought I did these. But there you go. And zero logon for, I don't think I've done this. Watch me having done this. No, I haven't done this either. Okay. So these are some good rooms, which best believe there's going to be videos about those coming out. So here are a couple of methods that they use for attacking AD. So Kerber roasting. It's a common, very successful post-exploitation technique for attackers to get privileged access to AD. The attacker exploits Kerberos ticket granting service, TGS, to request an encrypted password. And then the attacker cracks it offline through a bunch of different ways that we can do it. And they are difficult to detect because the request is made through an approved user. And from there, no unusual traffic pattern is generated during that process. So you can prevent the attack by ensuring an additional layer of authentication through multi-factor authentication by frequent periodic Kerberos key, distribution center, service account password resets. And we can learn more about that at this link here. And this is a Microsoft documentation. So there's Kerber roasting. And weak and easy to guess passwords. This one's kind of fairly easy to understand. And we have a password report PNG that we can check that out and see what that looks like over here. But it's basically passwords, right? It's like weak passwords, and they're easy to guess. And you can use a password dictionary attack to do those things, or you can use something called CrackStation, which is a website that has a giant rainbow table, which means that they have clear text passwords attached to the hash value of those passwords. And all you need to do is just drop in the hash in there, and they'll give you the clear text password within a second, literally less than a second. And it gives you the response to that. So those things are only possible because the password originally was just a weak password. And that way you kind of get, screwed, basically. And so this is our image here. So right here you have, let's see, the number of accounts with the same password, 186 with the same password, 181 with the same password. So these are the ones that they say that, I guess, they're not compromised, or the password is not weak, but there's 186 accounts that have that same password. So that's kind of, it's not good. It's not good. So then we have brute forcing remote desktop protocol, which is done through password dictionaries as well. And they attack, essentially it means that they try all the different variations of a password for a user. to try to brute force their way in. Once the brute force is successful, they quickly access the compromised system and try to do privilege escalation to give themselves higher privileges and do some really nasty stuff. The best recommendation is never expose RDP without additional security controls. Continuous audits for scanning attacks or brute force attempts are also an important step. Then you have publicly accessible shares. So share documents that are public or shared directories that are public that people can just get access to that share by doing a basic enumeration using a lot of different enumeration tools. And then once they know what your shared folder location is, they can just get into it and put scripts in there and then launch those scripts once they have RDP. So it's like some of these things are combined attacks. They put something inside a shared folder, and then because it's a shared folder, all they need is access to your system using a lower privileged user. And because they have access to that shared folder as the lower privileged user, they can do whatever's inside that shared folder. And so they go and they dump a malicious scripts in there. And then once they launch that script as the lower privileged user, they get themselves higher privileges. So public accessible shares are pretty big deal, you know. What it does is, this is the description here. So during AD configuration, some share folders are publicly accessible or left unauthenticated, providing an initial foothold. You can use the get smb open file commandlet in PowerShell to look for any undesired shares on the network and configure access to those things directly. So if I go into PowerShell here and I just clear my screen real quick, and then let's go back to the original C directory, and from here we're going to do get smb open file, and it should say, oh, nothing. So there's nothing here. So there you go. This is a secure computer. So during does Kerberosting utilize an offline attack scheme for cracking password encrypted? And that would be yay. Yeah, there you go. As per the generator report, how many users have the same password as Aaron Booth? So let's see. Let's go find Aaron Booth. 186 people have the same passwords at this guy. My God. And that's it for protecting against known attacks. So we have a cheat sheet here. The cheat sheet in this particular case is not downloadable, which is unfortunate. So I think I have to go open image in a new tab and save it myself. But it basically talks about everything we just talked about in just one single image. So I do recommend that if you want, let me see if I can kind of zoom out of this. Is this a free room? It's a free room actually. So just go get yourself a account with TryHackMe, go into this free room and get access to all this information for yourself. You can even run the virtual machine here for free. So they have a lot of great free rooms. This is another one of the reasons why I like TryHackMe so much. Even if you don't feel like spending the $7 to get access to their paid accounts, it's $12, but if you use the link in the description below, it becomes $7. So even if you don't feel like paying that $7 to get, you know, paid access to all of their rooms, the advanced stuff, and the attack box, all that stuff, then you still get, there's over 300 something free rooms. One of the users in our community was the one that told me about that. Like, he went and searched all the free rooms inside TryHackMe, and he dropped a comment and he said, yeah, there's literally over 350 something free rooms inside of TryHackMe, and this is actually one of them. So you can go and just download this image instead of trying to take a screenshot of like a low quality image of this thing. So that way you can get access to this cheat sheet and just keep that in your toolbox, right? Or in your toolkit, your tool belt, whatever you want to call it. And you will be better for it. So there it is. There's our Active Directory hardening room, and we killed it. All right, so that was it for Active Directory hardening. If you're studying for your security engineer certification, security analyst, pen test plus, ethical hacker, any of those things, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out in this path or any of our other paths. There's an entire playlist dedicated to SOC Level 1 for the junior security analyst, and we're going to be going into SOC Level 2 pretty soon. We have a playlist dedicated to Pentest Plus already, Pentest Plus already. So all those things are available to you already on this channel, and it's just going to keep coming. I do multiple uploads per week, sometimes one every single day. When it does get pretty busy for me, I can't do one a day. So for example, I think this last weekend I wasn't able to do any uploads. So I try to do one every single day, but at the very least you'll get several uploads per week and sometimes even multiple per day. So I do the best that I can to put out as much content for you as possible so that it makes it easier for you to do your job as a security engineer or to pass your examinations, because this information really is dope. TryHackMe's info is really, really dope. And so it would be really awesome to have you as a part of our community. We're at 1133, and it would be just one of those great things to have you be a part of our community. I do answer all the comments that come in, and sometimes I even make a video. If your comment is a really good comment and it asks a really good question, I'll get a video just for you. So I love the community. I would love to see you as a part of the community, and it would be an honor to have you as our community member. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. Hopefully you got a lot of value out of this. The next video that we're going to be doing is network device hardening. And until then, love, peace, and chicken grease. If no one else loves you, Hank loves you. And I will see you in the next video. Peace. And hello and welcome back to your boy Hank Hackerson at Hank Hacks Hackers, and we are continuing down our security engineer pathway today. We are on room number, or I guess episode number 13, excuse me, which is going to be the network device hardening room, and it's a part of the network and system security module of the security engineer pathway of TryHackMe. And our outline is as such. So we got the intro, common threat and attack vectors, common hardening techniques, hardening virtual private networks, hardening routers, switches, and firewalls, hardening routers, switches, and firewalls, more techniques. So I guess part 2. And then important tools for network monitoring, and of course the conclusion. So that is the outline that we got today. If you are studying for your security engineer or security analyst, ethical hacker, pen test, any of those things, I do encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. We basically talk about security and ethical hacking, pen testing on this channel. That's really all we talk about. And it would be amazing to have you as a part of our community, and you really get a bunch of good things to help with your certification exams as well as your day-to-day job of a security professional. So without further ado, let's jump into the introduction of the room. All right, so the intro is as follows. Network devices are the building blocks and backbone of today's contemporary and large-scale networks and systems. The role of network devices is to ensure reliable and efficient transfer, filtering, and management of data across or within networks. Really just a really fancy way of saying you need network devices to actually set up a network, which is a local access network, an LAN, local area network. I think that's what it's called. Local area network, LAN, wide area network, which is a WAN. And then you have something for specific, what is it called? Campuses, like a campus of the Google campus, for example, where they have a bunch of different buildings and locations, and that entire area, I think it's called a MAN, a MAN, which stands for a municipal area network. I'm not for sure, but I know that there is one specific term for that as well. And the WAN in general could also be considered that, and then the internet at large is also considered a WAN. So there's a lot of different devices. So you can have the layer 1 hubs, which aren't really used that much anymore, or repeaters, to layer 2 switches, layer 3 routers, load balancers, virtual private networks, VPNs, and intrusion prevention systems, which also fall as a part of your network and IDS. So there's an NIDS, which is the network intrusion detection system, and NIPS, which is a network intrusion protection or prevention system. So all of those things fall under network devices. And the learning objectives are basically for us to identify and mitigate any kind of security vulnerability that has to do with those devices, hardening, which means basically securing those configurations for those devices, and implementing security best practices to just make sure that it is perpetually secure. So by the end of this whole thing, we should be able to assess and strengthen a network device security posture of a company, enhance the network resilience, and effectively defend against common cyber threats. Some of the prerequisites are here. So you have the networking in general as a concept. So you need to understand basic networking, which would be the TCP/IP model or just networking in general, network services, open systems interconnection, which is the OSI model, and then firewalls. And so let's see if I think I've done all of these. Yeah, I've done network services, enumerated SMB. I think there's actually a video on this already. So there's the network services video, introductory to networking. I don't think I've done. Maybe I have done this actually. This seems like I did something for this recently. But this is just one of those things that if you just go look at the OSI model, what encapsulation means, what the TCP/IP model looks like, most network engineers work based on the OSI model, and we're going to be talking about that in a little bit anyways. But just understanding the OSI model, the layers of the OSI model, and the various networking tools as far as pinging something, or trace route, which is routing the number of hops that a specific packet takes to get from its originating IP address to its destination IP address, the whois lookup, the dig lookup. All of this information you could Google and get very, very quick and easy information about these things, because these are very, very basic. The most important thing out of this entire thing that you're going to need is the understanding of the OSI model. And this is the specific breakdown of it. So we have, it starts from layer 1, which is the physical layer. So it goes from the bottom up. So layer 1 is the physical layer, layer 7 is the application layer. So going from layer 1 all the way to the top, the acronym that helped me understand this is please do not throw sausage pizza away. So if you can remember that, please do not throw sausage pizza away. You'll at least have the first letter of these things, and then you can kind of remember what all of those things stand for. And it goes from the physical layer to the data link layer, network, transport, session, presentation, and application. And this is what most network engineers work off of. The TCP/IP model is a more current version of this thing, which instead of 7 layers, it just breaks it down to 4 layers. But everybody in in network engineering and networking in general, most people go based on the OSI model, even though technically it's the older model and TCP/IP is the newer model. Most network engineers go based on this specific 7 steps instead of the condensed version of TCP/IP and its 4 steps. So that is just a very, very brief basic overview of these things. And from here, now we can actually jump into the first task, or I guess the first main task, which is task 2, which is common threats and attack vectors. The difference between network devices and endpoint devices is as such. So the network devices essentially are the ones that provide the service to the network, and then the endpoint devices are the devices that use the service. If we were to just keep it super simple, the technical definition here, it'll give us some better understanding. So endpoint devices refer to any device that can generate or consume data on a network. So that's the laptop, the desktop, smartphones, tablets, printers, servers, IoT devices, any of those things are using the data that's being provided by the network devices. And then you have the network devices themselves, which is the routers, the modems, the switches, wireless access points, stuff like that. Those are all considered network devices. And those devices provide service to the network, and then the other devices consume the service of the network, and they generate data. So a laptop generates data. A network doesn't generate data. The network processes the data or transfers the data, transports the data. but the devices that generate the data are the laptops, the desktops, the phones, and anything else that can generate data, right? So printers technically generate data, servers and tablets and all of those things generate data. So we can, if we looked at it from a kind of like a basic flow chart type of a graph environment, you have the function, the endpoint device, and then the network device, right? So the function, or the, I guess we can say the feature, my bad. So the feature, the endpoint device, and the network device. So the feature would be a function, and the endpoint devices used to access and consume network resources, and the network devices used to manage and control the resources on the network. Traffic, sources and designations of the network traffic, or sources and destinations of the network traffic. So the endpoints are the sources and the destinations of that traffic, and then the network devices actually forward that traffic. They route the traffic and control that traffic. The configurations of endpoint devices are very simple configurations. Network devices have complex configurations that require a lot of specialized knowledge. There's certifications that you can get just for Cisco devices for networking, and that's called the CCNA. And then it goes up from that. So there's like several certifications just for Cisco devices, and so that's a whole world all in itself, and it requires more specialized knowledge. Then you have the examples. So you have endpoint devices could be any of these things: PCs, laptops, printers, scanners, IoT, smart TVs, any of that stuff. And network devices would be the routers, the switches, the firewalls, load balancers, gateways, and several other things. So common threats and attack vectors for the network device side network devices are actually getting attacked more so now than any other time in history, honestly. Today's ICT, information and communication technology networks, they've transferred the world into a global village. Basically, everybody's connected to everything. And so on the other hand, it's given rise to multifarious, I like that word, multifarious malicious activities by cyber attackers. And various network devices are the backbone of the modern information and communication technology, ICT networks. So to ensure CIA, confidentiality, integrity, and availability in our networks and systems, we have to implement security hardening measures to these devices. And some of the goals of hardening include protecting from unauthorized access, attacks and exploits, enforcement of access policies, prevention of data theft, and a lot of other things, including the network just needs to be up all the time. So it needs to actually be available. You don't want to lose service. Imagine if Amazon Web Services, AWS, imagine if Amazon Web Services lost internet service in one of their warehouses or in several of their warehouses, and that crashed. That would mean that probably hundreds of thousands of websites, if not millions of websites, are also going to crash because their servers crashed. So this is very important. So understanding how important these things actually are in the global landscape of information is very, very important for us. And that's kind of where security professionals come in, right? So unauthorized access would be one threat. And the name implies, right? Somebody gets unauthorized access or control of a device, and then they do something to the network or get access to the entire network. The attack vector would be a password attack, so brute force, dictionary, exploit known vulnerabilities like remote code execution. Then you have social engineering and phishing attacks to trick network administrators into disclosing sensitive data, such as their usernames and passwords, so that they can actually do a password attack or get into the system. So that's one threat vector, which is the unauthorized access. Then there's the denial of service. So if something crashes, so disruption of critical devices to make them unavailable to real users. Going back to our Amazon example, if the Amazon Web Services warehouses of all of these giant web servers, if those things crash, that's denial of service, and people who actually need to use those things can no longer access them. So that's called a denial of service. So flooding devices with fake requests, probably not going to work with Amazon because they're so gigantic and they have load balancers and a lot of other things that will prevent that from happening. A lot of redundancies, meaning duplicate warehouses with duplicate servers, that if something were to crash one specific server, it'll just transfer service to another server and it'll keep running. So that is a little bit tough to do against a company like Amazon. Exploiting vulnerabilities in the logical or resource handling, or manipulating network packets. Maybe those might be a little bit more practical, but again, against a company like Amazon, they are so secure. So that's also why people love using them. So it's like it makes it a little bit difficult to do something like that. So, but that is very much indeed a possibility. You can do a DOS attack against a small company and their web servers and their infrastructure. So that is actually a feasible attack vector. And then you have man in the middle, which is basically getting in the middle of the flow of traffic, intercepting the flow of traffic so that you can capture the information between them. And from there, do a variety of different things, either stealing the information or manipulating the requests that are being made. And so this could be address resolution protocol spoofing, DNS, domain name service spoofing, rogue access points, and a bunch of other ways that you can also do man-in-the-middle attacks. Then you have privilege escalation, so gaining access to a lower level user and then escalating your privileges to get access to more sensitive information, weak passwords or the same passwords for user and admin accounts, exploiting vulnerabilities, misconfigurations. There's a lot of stuff. We've done a lot of videos on privilege escalation. So this is literally just a small fraction of the things that you can do to escalate your privileges. And then bandwidth theft and hot linking, which is linking a bandwidth intensive resource, which is basically an image or a video as an example, from an external website to the original website without permission. And it causes increased traffic to the original website, which means you're stealing their bandwidth, their processing power. Scraping large volumes of data, that could be one thing. DOS attacks is another thing. Malware attacks is another thing. Crypto mining is one of those things that you can steal their bandwidth so that you can use their processing power to mine cryptocurrency for yourself. That's one of the big ones. So there's a lot of stuff that you can do. So some of the questions that apply to this are: the device that is used to control and manage network resources is called what? That would be a network device. And a threat vector that includes disruption of critical devices and services to make them unavailable to genuine users is called a denial of service. And we are done with this particular task. So that was it for our common threat and attack vectors. So let's look at common hardening techniques or common securing techniques. There are general techniques that can be applied to pretty much anything for securing the device or the software or anything like that. So you have updating and patching. Updating means stay current with the most recent version of the thing. Patching means find out what a released vulnerability is or what a recent discovered vulnerability is and patch that vulnerability. Then you have disabling unnecessary services and ports. And so unnecessary services typically applies to the host itself, the client, or the computer, the phone, whatever. If there's a service that you're not using, disable it so that it's not part of the surface, the attack surface. In network devices, it's typically ports that you have to disable if you're not using them. So disabling those ports are really important. So you have physical ports and virtual ports. You can have virtual private networks or virtual LANs. So a switch, has a bunch of different ports in the back of it, and one port out of that switch could come out and go connect to a router or wireless router, and that singular port that comes out and connects to that one wireless router creates a small little LAN, and everything that connects to that one particular LAN or that one particular router and becomes that LAN. And then typically on the back of a switch there's dozens of ports. and some of them are not used. So if the ones that aren't used are still active, they haven't been blocked, then that's a part of the attack surface, and somebody could take advantage of that. The principle of least privilege, we talked about this in one of our previous videos recently, which basically means that restrict users and processes to the bare minimum privileges that would be needed to do the job that it needs to do, and nothing more than that. Monitoring logs is one of the constant things that a cyber analyst ends up doing, a SOC analyst, security analyst. That's basically your job, is to just constantly monitor logs. Thankfully, you don't have to do them yourself. There's things like IDS and IPS systems. There's things like SIEMs, security information and event managers, things like that, that allow you to monitor them, and they help, they monitor for you, and they bring up events of interest for you to go address. Regular backups, kind of the very easy concept to understand. If anything happens and shit hits the fan, you want to have a recent backup that you can go back to, just in case you've either lost your data or in case you're being held at ransom and they won't release your information unless you give them the money. And so you need to go back and use one of your recent backups to reactivate services, stuff like that. So enforcing strong passwords, again, one of the big ones. Things like have a capital letter and a lowercase letter, as well as a number and a special character. Things like, have more than 12 characters in your password. Don't reuse old passwords. There's a lot of different things that you can enforce as far as your passwords themselves are concerned. And then your password policy could be, every 30 days or every 45 days, you need to change a password to just make sure that it's constantly rotating, so that you don't have to worry about people. If somebody finds it, they don't take advantage of it. And then MFA, multi-factor authentication, is a bunch of different things. So it could be sending a text message to your phone. It could be sending a code to your email. It could be a thumbprint or a face scan or a key card or even a USB drive that has a key on it that counts as your physical key. So there's a lot of different things that you can use for multi-factor authentication these days that can make it helpful to secure or harden your network devices. The importance of secure protocols is another big deal. So Telnet, we did something earlier in this pathway for security engineering where we were attacking the weak protocols, and Telnet is a very weak protocol, and it was previously used for making remote connections to devices. And it's weak because everything is transferred through clear text. So if you submit your username and password on Telnet, it can be somebody could just sniff that traffic, and from there they get your username and password, and they don't have to do any decryption or anything, because it's all just being passed through the port or the protocol using clear text. But then there's a secure version of that process, which is SSH, secure shell, which does pretty much the same thing that Telnet does, except now the whole conversation is encrypted and nobody can see anything through clear text, and they would have to go through a series of steps to try to decrypt the information that's going through secure shell. Same thing for HTTPS versus HTTP. So HTTP is the hypertext transfer protocol, I want to say, but it's basically the protocol that's used to access a web browser and send information via the internet, access information via the internet. HTTPS is the secure version of that encrypts everything. And then there's SSL and TLS, which is applied to HTTP to make it secure, and then IPsec and a bunch of other things. We can learn more about those things inside of this room. Let's see which room they're referring to. It is the Network Security Protocols room, which I have not gone through, so you can definitely expect a video on this somewhere in the future. But it's just important to use secure protocols to set up your network and to use your network, and don't use insecure ports and insecure protocols. It's basic. It seems like common sense, but most people don't even know, and most people aren't even aware. So it's one of those things that you just got to make sure that you take care of. Then remove or block insecure protocols. So very, very similar to the last one, right? So, remove Telnet. right here. It's listed as an insecure protocol. Remove telnet or block telnet port from being used so that it's not even an option for somebody to use it to get into your system and then escalate privileges or get other data from you. So remove or block insecure protocols. Very, very simple to understand, but a lot of people don't do it. So that's another one of those things that you just want to make sure that you do. And then you have implementation of monitoring and logging controls. So we have syslog, which is a Windows protocol, and it's the standardized transfer of log messages with the purpose of storing and analyzing log messages to a central server. Then you have SNMP, the simple network mapper protocol, I want to say. It traps a notification sent by a network device to a management system when a predefined event occurs. Then you have NetFlow, and then there's a NetFlow analyzer tool, which is a protocol that's used to collect and analyze network traffic data for monitoring and security analysis. Then you have packet captures, which can be done using something like Wireshark or TCP dump or a bunch of other tools as well. That, again, it's a monitoring and logging control. And they haven't mentioned it, but there's SIMs and IDS systems and IPS systems and all those things as well. So the question here is, suppose you are configuring a router. Which of the following could be considered an insecure protocol? So IPsec has kind of sec in it, so we can say that's secure. SSH stands for secure shell. HTTPS stands for HTTP secure. So the one that we have right here is file transfer protocol, which is an insecure protocol. And then the protocol for sending log messages to a centralized server for storage and analysis is called what? And let's see, I'm just going to take a guess here, see if it's Telnet. It's not Telnet. So the protocol for sending log messages to a centralized server for storage and analysis. Let's see what that is. Oh, it's literally right here. I can't believe I didn't even think about that. So syslog. Syslog is that protocol. Very good. And just like that, we got our common hardening techniques. So let's jump into hardening virtual private networks. All right, for this one, we had to start a virtual machine right here, and it's for the VPN, the virtual private network. And so hardening a VPN is what we're going to have to deal with here. So VPNs are now needed in the age of remote work and online communication to protect sensitive data and preserve privacy. Hardening VPNs is crucial to ensure that the VPN itself it's protected against cyber attacks, and it doesn't it serves its purpose basically. It entails adopting additional security measures such as multi-factor authentication and encryption techniques to make it more challenging for hackers to access the network. By taking these extra precautions, businesses can better safeguard their data and defend cyber attacks, etc. So that's what the job of the VPN is. So the VPN connects the computer to the intranet. Let's say somebody's trying to use the intranet through a VPN, and the hacker wants to get a man-in-the-middle attack, and they can't because the VPN is protecting the connection between these two entities. So it's very important. So we're going to cover the hardening of a VPN server by focusing on secure authentication, strong encryption, and proper updating. Then we'll see what else we can find later on. So connecting to the machine I've already done by clicking Start Machine. It's going to, in a split view, it's not visible. The VM is not visible. Use the blue show split. Okay, whatever, that's fine. It is visible, as we can see the little extra pan on the pan on the side? The extra column on the side, let's just call it that. Standard hardening practices. So OpenVPN is one of the things that TryHackMe uses. And so to be able to configure OpenVPN to work for you, you have to download a configuration file, a config file, and then you typically don't have to do any kind of modifying to it, but if you want to, you can, and then you would end up securing your overall connection. So the system admin must understand that the file's content must understand the file's content and edit it per best security practices. So what we're going to end up doing is go find the server config log, which is located at this directory, and then open the terminal and load it by doing sudo nano. And you should understand what that means. I'm not going to go into the explanations of that because that's very, very basic Linux command line terminology. So we're going to use nano as a root user to open that file. And then once you've made the changes, you do Control O to save it, press Enter, Control X to exit. Again, very, very basic things. And then sudo systemctl restart, and then the service that we want to do so that we can restart the OpenVPN service. And then moving forward, the following are some of the significant hardening practices for a VPN server. Use a strong encryption algorithm. So anything like a AES 128 versus MD5, for example. MD5 is pretty old and fairly weak compared to AES 128 or SHA 512 or something like that, SHA 512. There's just a lot of different encryption algorithms that are more secure than the older ones. So just having an understanding of what that is. The possible options for Cypher includes AES, Blowfish, Camellia, and more. AES 128 CBC means that AES encryption algorithm with a 128-bit in cipher block chaining mode as shown below. So this is what this looks like right here. And then cipher options can be this is the comment right here. So this is the original comment that they ran. This is what the contents of it are going to look like. And you see that they used AES 128. Then keep the VPN gateway software up to date. So just make sure that it's patched and upgraded and updated regularly. Then you want to implement strong authentication. So strong authentication mechanisms such as combination of TLS and a secure hashing algorithm. We can use auth to specify the exact algorithm that we want to use. Then you have other options like SHA-1, 128, 256, 512, and MD5. And as I mentioned, SHA-512 is more secure than MD5, so you kind of want to use the most secure thing. And then SHA-512 is more secure than SHA-256, which is more secure than 128, etc. You get the idea. Then you can do the same thing. So you go into the configuration file, and then you just say auth SHA-256 versus over here where they did cipher AES 128. That's actually, so this is it right here. So they already have SHA auth 256 right here. So this is part of their encryption or authentication that they're talking about. Change the default settings and the usernames and passwords that are unique so that you don't have to worry about them being in a big dictionary attack. Enable perfect forward secrecy, PFS. In OpenVPN generates unique session keys for each session to strengthen the security of it. Because of this, even if a hacker successfully obtained the session key, they could not use it to decode more sessions. For each session, PFS generates a new set of encryption keys, which makes the old one obsolete. So it's much more challenging for them to spoof the VPN connection and steal sensitive data. We can use TLS crypt to be able to enable that PFS, and it requires a key that can generate using the command that can be generated using the command sudo openvpn generate key secret, so on and so forth, and it should be placed in the same directory as on the server. So choosing the appropriate cipher and authentication like AES 256 and SHA 256 supports PFS if combined with TLS. And this is what it looks like here. So you have authorization, SHA 256, cipher, AES 256, and then you have TLS script and the key, and then TLS minimum version to make sure that you have at least the most secure version. And then we have dedicated users for the VPN service. So just limit access by creating dedicated users, and don't create any other users, or don't leave it open, so on and so forth. And of course, this is just kind of the surface level stuff. There's a lot of other stuff that you can do based on what the enterprise or the organization requires. But by default, providing restricted access to the users enables a limited attack surface so that you are not vulnerable in a bunch of different areas. So question number 1, it says update the config file to use Cypher AES-126. What is the flag value linked with the Cypher directive? So let's go ahead and update the Cypher. So let's open this up and go to our file location to make it a little bit easier here. All right, and there's that, and there is that. So we have our server config file right here. So the first thing that we want to do is we want to nano into it, and then we want to update our Cypher to use AES-128. So let's do sudo nano and server.conf. There it is. And there we go. So there's our information. And we want to change the Cypher to be AES-128 CBC. So let's go in here and try to find that. So we changed that, and here's the flag value already for us right here. So this is the Cypher flag. And there's a flag up here too. That's for the authentication. So there's that. And then we're gonna update that to be SHA-512. So let me just take this flag real quick and copy that and update that over here. And so let's just change this to be SHA-512. There we go. And then as per the config file, what is the port number for the OpenVPN server? So what is the port number for that? Let's try to find that. All right, so we have at the very top here, we have 1194 as our port number. So let's make sure that that's it. Yep, that is it. And just like that, we finished it. So now we're going to do Control O, and it's going to say, do you want to write to this? And we press enter, which is yes. And then Control X, and it closes it out. And we have updated our VPN file for OpenVPN. So now we can move into hardening routers, switches, and firewalls. Routers and switches, they have to be hardened for network infrastructure to be secure and reliable. Every network needs routers and switches, often the first line of defense against potential security risks. By hardening those things, we can lower the possibility of unauthorized access, data breaches, network service availability can be ensured, and a bunch of other things. And improve network performance, increased resilience against cyber attacks, and regulatory compliance are just a few advantages for securing routers and switches. And without enough hardening, they are very susceptible to various attacks, including DOS, denial of service, and network profiling. Profiling meaning they can enumerate our network and try to find out what kind of services we have and what kind of gear we have, so on and so forth. So we studied how to harden a VPN using the command line interface in our previous task. So what we're going to do is we're going to use the web interface to learn different methods for hardening a router, and we'll be using a router that has OpenWRT installed, which is free and open source Linux-based operating system for embedded devices. And we know that a router configuration varies from product to product. However, a few standard techniques can be applied to protect from potential attacks. So we're going to go to this specific address in our web browser and use this username and password to log in. And then from there, we're going to run the rest of the exercise here. All right, so we have that loaded now and setting it up. So here we go. It says, while setting up any network device, it's necessary to fill in all the relevant details like the host name, the time zone, logging, and stuff like that. It makes sure that conducting incident handling is a little bit easier. Logging must be enabled to log all the events with the default alert level of debug, and then time zone and synchronization can be accurate, can set accuracy or can set accurately to properly correlate events with the time of the occurrence of it. So we can do this in the system tab right here to just make sure that we have all of those things set, and that's what the screenshot of that looked like. Then we're going to change the default credentials, which I believe is in the system administration tab. That can be done. And let's see if I need to do any of these things. So use the password to update the password of the router to TryHackMe123. So we can definitely do that under the authentication tab. So let's go over here and let's go to administration and then enter a new password, which is going to be TryHackMe123. So we're just going to update our password real quick. Cool, we saved the password, so that's good. So what is default SSH port configured on OpenWrt? I'm just going to guess that it's 22 because it is the default port for port 22 for our SSH and SSH in general, really. And so that would be enable secure network protocol. So we can do that under administration and SSH access, which is the next tab right here. And it'll show us some information about that, which includes our default port, for example, as well as if I click on this, we can see this a little bit better. We have interface, and then the port 22, obviously, password authentication that's required, and allow root logins with that password, and then you can even assign a gateway port, and that's still loading a little bit, so we can look at that later. And then disable unnecessary scripts if you have certain scripts that are running. And so here we go. We have our default port set to 22 right here, which is all good as well. And so if we go to system and startup, we can see the scripts that are available that we can potentially turn off. So it says go through the general settings option under the system tab in the attached VM. The administrator has left a special message in the notes section. So general settings of our system tab in the notes section. So let's see what we can find here. There we go, that's our note. So THM system 101 is the note that was left in our notes. And it says, what's the default system log buffer size for the OpenWRT router? And that is probably not going to be under scripts. So this, I actually have to kind of click around and try to find what the buffer size is. So let's try to find that. And that was under logging, under the general tab for system. So that is 64 is our default buffer size. And it says, what is the start priority for the script UHTTPD? So now we actually do have to go to scripts and try to find that. And I think that was under startup. Yeah, so we're going to go under startup and we're going to try to look at the UHTTPD script and see what the start priority for that thing is. And there we go, it's right here, UHTTPD, and then it's 50 for the start priority for that. And there we go, we got all our information for OpenWrt. OpenWRT, OpenW router. That's basically the system that we were using to configure our router for this task. So that was pretty cool. It was fun to do. Doesn't require a command line interface, which is very nice, and it's actually pretty helpful. But I think it's also really important for you to learn how to do stuff like this through the command line, because a lot of companies require for you to understand command line for setting up information on routers and switches and stuff like that. So that was it for hardening routers, switches, and firewalls part 1. And now we're going to go into part 2, which is still going to use the OpenWrt tool, and we're going to be looking at a different tab, which is the network tab. So let's go into that. And network devices allow us to create specific rules, which is accept or deny network traffic. So if you have, for example, data of users connected with our network devices being exfiltrated to a C2 server, we can create a rule to block all the traffic with that specific IP for that C2 server. And you can do that through the network firewall traffic rules. So if I go to network and then I go to firewall, then it'll show me the traffic rules that I can implement, and if there's anything that exists already or if it doesn't. So that could be one thing, and maybe we have a question for that. So it says, what is the name of the rule that accepts ICMP traffic from the source zone WAN and destination zone as this device? So that's probably going to be in our firewall rule, and source zone WAN, and what's the name of the rule? So that's what we need to see, and this is under traffic rules. So let's see what that is. So there is a couple of rules that have the protocol of ICMP, and it says from the source zone WAN, and the destination zone is going to be this device. So if we have protocol ICMP from WAN to this device, and that would be allow ping, and then if we go down a little bit more, we have another one that's IPv6 from WAN to this device, which is allow ICMP v6 input. So that could be one, and then you have another one from WAN, but that goes to any zone, and then that's pretty much it, I think, for all of the rules. Yeah, so I think it's the allow ping that is from ICMP, from the WAN to this device. There we go. And so what is the name of the rule that forwards data coming from the WAN to port 9001, or from WAN port 9001 to LAN port 9002? From WAN to LAN port 9002. And so let's see if we can find that. And I have actually gotten ahead of myself. So there, there's a section to monitor traffic, which is for our status tab that's at the top right here. And then you can just go to traffic for that real-time graph. So status real-time graph, and then we can look at the real-time traffic that's taking place. So that's really interesting. And then you have port forwarding, which might be the location that we're going to be able to find our port answer, the question for our ports. And so if I go to port forwards in this case, and it says, a firewall port forwarding capability enables inbound traffic from the internet or other sources to be routed to a particular device or service on the internet network. The firewall can send incoming traffic to the appropriate device or service on the internal network by establishing port forwarding rules while blocking any other incoming traffic that does not comply with those rules. And this feature helps host applications that need outside access, granting remote control of internal devices. Port forwarding should be used carefully because it can expose internal devices and services to potential security issues if improperly secured and configured. Threat actors could add new lines here for creating connections to external command and control servers, and we can configure it here. So this is where we are, and this is what we're looking at, and this is actually it right here. This is the rule. So it's called THM_port, and it goes from WAN to this device on port 9001, and it's going to forward it to LAN port 9002. So that is what is actually called, is THM port, and that is it. And so what is the version number for the available APK package? And that's what we're going to find under software. And then we have a specific tab right here for scheduled tasks that you can actually have a reboot set up, and this is a command line interface as it looks like, that you can say this is the system cron tab that schedules tasks can be defined, and then reboot in this particular case. So it's important to monitor scheduled tasks to confirm that the original scheduled tasks are not modified by a threat actor, and we can add and remove those by going to the scheduled tasks. over here. Since we don't have a question that's relevant to that, I'm just going to stick with our screenshot here and move on to that. You can learn how to create cron jobs here, and this is for the Phoenix NAP website for that OpenWRT software for modifying and configuring your router. So that's the software that we're using right here, and it's powered by that wonderful company. So now we can go into the system software to try to find the version that we need for our specific question, our very last question here, that says what's the version number for the available APK package. So I need to go find that package, and let's see what the version number for that is going to be. And here it is, APK, and this is our version number. So we're going to copy that, and we're going to go over here and we're going to paste it, and there it is. And that was the last question for our part 2 of hardening routers, switches, and firewalls. And this actually, honestly, I like this. I like the fact that there's a GUI, like a web GUI for this software. So let's go into the last task here, which is important tools for network monitoring. Network monitoring tools are enablers for maintaining the security and performance of networks. They use sophisticated algorithms and protocols to capture and analyze real-time network traffic. In addition, they enable network administrators to detect and troubleshoot problems such as bandwidth bottlenecks, network outages, security threats. Commonly used tools are Nagios. I actually had to learn about this when I was studying for my CYSA examination. So it's an open source software for monitoring systems, networks, and infrastructure. It provides real-time monitoring and alerting for various services and applications. SolarWinds, a really famous name, and it has a bunch of different uses. One of them is the Network Performance Monitor that provides real-time visibility into network performance. It includes network mapping, also known as heat mapping, automated network discovery, customizable dashboards. Actually, I think network mapping is very different from heat mapping. Heat mapping has to do with the strength of your devices and the signal that they're emitting. Network mapping is finding the various points in your network, so they're not the same. Automated network discovery, customizable dashboards, so on and so forth. SolarWinds is a really, really big deal. It's a very, very big deal. And they actually got hacked at one point, and that was like a big old scandal. But obviously they've patched it and they've recovered. But it's a big name. You're going to hear that a lot when you're going into cybersecurity. So big companies use them because it's a big freaking enterprise software. And if they have a budget, they're going to use some of the best softwares, which includes SolarWinds. And then you have PRTG, all-in-one network monitoring that provides comprehensive performance and availability monitoring. It includes real-time traffic analysis, custom dashboards, and alerts. And then you have Zabbix, a powerful open source network monitoring tool that provides real-time performance and availability monitoring. Includes features such as customizable dashboards, network mapping, alerting. So these are just a few. There's a lot. There's a lot of network tools, and it would be to your benefit to go ahead and learn about them, especially the big name ones like SolarWinds and Nagios and stuff like that. And open source software is going to be used in a lot of companies. So it's not like companies who have budgets want to throw money at things. If you can find a really good software that is open source that'll get the job done, they will most likely go for it. So that is not bad at all. And our network monitoring tools capable of detecting bandwidth bottlenecks? And the answer to that is yes. So we have our task, and that is done. We just finished our room. That's because I had already clicked on the complete session for the conclusion, so I'm not going to jump into the conclusion, but it's really important. I think this is like one of those things that you're going to deal with network security that will be completely separate from system security, and understanding the difference of those things is very important. especially as a security engineer, right? Because that's what we're studying for right now, is the job of a security engineer. And you're going to run across tasks and requirements at jobs and just a bunch of stuff that are absolutely crucial for you to understand what network infrastructure looks like and what network appliances are and how you can secure those things. So that is it for our network device hardening room on TryHackMe. If you learned anything in this video, or if you're studying for your security engineer, security analyst, pentest plus, ethical hacker, any of those things, I do encourage you to like, subscribe, and turn on that notification bell and join our community. All we talk about here is security engineering and ethical hacking and pen testing, cybersecurity analysis. And I think all of that information and everything that we talk about is directly applicable to you in your examinations and certifications and day-to-day jobs when you go into the world of cybersecurity. So there's already a completed playlist for the SOC Level 1 content that is all TryHackMe, including labs and examples and engineering tasks, as well as challenges and a lot of real life scenarios that we went through, a lot of different tools that we used. Includes endpoint detection and response. It includes digital forensics and incident handling. So there's a lot of stuff that already is on the channel, and we're making our way. We're making progress with our security engineer path. So that's going to be another one of those things that will be available to you. And I think you'll get a lot out of joining our community. And honestly, personally, I would love to see you in the comment section and to just see you in our community. It would be amazing to have you be a part of this very growing world that we got going on here. So hopefully you find value from it, and hopefully you'll actually join us. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. This was our network device hardening room. And love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next room later. Oh, right. What is going on? It's your boy Hank Hackerson at Hank Hacks Hackers, and we are continuing down our security engineer path. And in this video, it is going to be, I want to say, episode 14 in our playlist. We're going to be going through the network security protocols room, which is a part of the network and system security module of the security engineer pathway of TryHackMe. And our outline is the intro, and then we're going to talk about the application layer and application layer secure protocols, and then presentation and session layers, and then the network layer. So this is looking at the ISO model and just kind of outlining all of those things, and all of this stuff is going to be time-stamped in the description below. So if you wanted to jump around or go to a specific section, you could do that. If you are studying for your security engineer or security analyst, pentest plus, ethical hacker, any of those certifications, I do encourage you to like, subscribe, and turn on that notification bell and join our community, because literally all we talk about here is cybersecurity and ethical hacking. And I think all of this content is going to be very useful to you in your certification exams, as well as your day-to-day tasks and job as a security professional. So I would love to see you in our community. I would love to see you in the comment section. I answer all the comments, and I even sometimes make videos to answer some of the questions that come through the comment section. So it would be awesome to have you in our community, and I think you'll get a pretty big benefit out of it. And without further ado, let's jump into the intro of this room. So a network protocol is basically how two devices or processes, we can call them, communicate with each other. And it's predefined set of rules and processes to determine how data is transferred or transmitted between devices, such as end user devices, also known as endpoints, or networking devices and servers. And then the fundamental objective of all protocols is to allow machines to connect and communicate seamlessly, easily, streamlined, all that stuff, regardless of any kind of difference that might exist in their actual design or structure or logic or operating system or any of that stuff. So if you want to get an analogy, a networking protocol is a common language that helps make communication possible among people with different native languages and from various parts of the globe. So, for example, if people speak, Mandarin, French, Spanish, and Farsi, and then they all want to communicate with each other, they could use English as the communication language, and they can all communicate with each other. And that could be a version of a network protocol. So the objective in this particular room is to basically learn the primary protocols that are needed for network security at each OSI model layer. And then what you need to know is the OSI model, just so I understand what we're actually going to be talking about, and the HTTP protocols and methods, and then just basic principles of security. So I know I've done a video of security principles and HTTP protocols. Let's see if we have that. I have done this actually, protocols and servers. I have done a video on this as well. So, HTTP, file transfer protocol, which is FTP, simple mail transfer protocol, which is SMTP, post office protocol, which is POP3, and IMAP, which is Internet Message Access Protocol. And there's a video on this stuff as well. So if you want to go and kind of search on the channel, you can click the search button at the top of the channel, the little magnifying glass button, and then you can search through the contents of the channel. And then we have the OSI model, which I have also done. I don't think I've done a video on this though. So you can find a lot of great content on this. And it starts from the layer 1 being the physical layer, and a great acronym to try to remember this is please do not throw sausage pizza away. So PDNTSPA is please do not throw sausage pizza away, and that would be a really easy acronym to try to remember basically the 7 layers of the OSI model. So we are going to be talking about the application layer, presentation and session layers, and the network layer in this particular video, and how to secure those protocols. That's kind of the whole idea, because we're talking about security. So we're talking about networking, yes, but we're looking at networking from the security perspective and the security lens. So let's jump into the very first layer that we're going to talk about, which is layer 7. So we're working our way backwards. So layer 7 is going to be the application layer. So let's look at that. All right, so the application layer, we're going to talk about the core technical concepts of a lot of protocols. We have to be understanding of 2 specific things before we jump into it. So one of them is each protocol represents specific layers of the OSI or TCP/IP model and operates as per the functionality of that layer. Most network engineers and most networking professionals, they operate based on the OSI model, which is those 7 layers. The TCP/IP model is 4 layers, and they condense a few of the layers into 1 layer. And so we're going to be talking about the OSI model. Most networking professionals, if not all networking professionals, talk about networking in the context of the OSI model. So if you're going to choose one of those things to memorize, I think you should learn both of them. But if you have to choose one, I don't know why you would only choose one, but if you have to choose one, it would be the OSI model. And then there's that, and then you need to know the difference between TCP and UDP based protocols and how they work on specific ports. And that's basically it. Those 2 concepts we need to kind of keep in mind as we go through everything. So the first thing is going to be HTTPS, which is the secure version of HTTP. And so the technical overview. So Hypertext Transfer Protocol is HTTP, and then you have secure, which is the secure version. And it's a client service protocol. So your computer is the client, and the server would be a web server that you get access to. So for example, the TryHackMe.com web server, that ends up being the server, and then your computer is the client. You're on your phone right now, or maybe on your computer, and you're watching a video on YouTube. So YouTube is the server, and your phone is the client. This specific protocol is responsible for securely securely, sending data between a web server or a website and a web browser. And its encrypted variant of HTTP, which sends data in an unencrypted format. So basically, it's literally the secure version of HTTP, and HTTP sends data unencrypted. So it's been kind of grandfathered, and nobody really uses just HTTP. And if you land on a website that only has HTTP and it's not secure, you'll get that message where it's like, hey, proceed with caution, or turn back or something. This website is not secure. So that's very important to understand. HTTP would be enough to browse a website to learn about a company product. However, HTTPS is a must if you want to provide your credit card information, or if you want to put in a username and password, or anything else that involves sensitive data. It was developed to securely share sensitive information, including passwords, contact info, financial info, between web browsers and websites. So for example, your bank will never have an HTTP only website. It has to have HTTPS, because online banking and online payment wouldn't be possible without those things. So the workflow is the HTTP uses the unencrypted version of itself and adds a layer of encryption. So in this case, SSL or TLS certificates through a certificate authority, and the rest of the workflow remains exactly the same. So before proceeding forward, we need to understand how HTTP requests and responses actually operate, so that you know what goes on kind of behind the scenes, right? So the request and the response is very similar. So the web browser sends a GET request, for example, to the web server, and the web server responds, and it provides the information that we sent the GET request for. We can also send a POST request, which we would send data to the web server, and the web server would respond a certain way. Both request and response are in clear text when you're talking about HTTP specifically, and anyone can read that information. So the request might be a GET request, which is an image. So you want to get an image, or see an image, or a file, or something like that. PUT is an update request. POST is sending data, which I guess they can technically be the same thing, but PUT is more to update something, and POST is to send something like a search query, or username and password, and it sends data. And then you can just read more about it inside HTTP in Detail Room inside of TryHackMe, or you can just go look at HTTP requests on Google and get a bunch of information. So if an attacker can capture the packets between the client and the server that's communicating over HTTP, they'll be able to read those contents because it's sent in clear text. It's not encrypted, okay? That's why HTTP is insecure. But then when you do HTTPS, same thing. You're sending the same exact GET request, same POST or PUT request, but now it's all encrypted. Your request is encrypted and the response is encrypted. So if somebody's listening or watching or sniffing that traffic, they don't see anything except a bunch of random letters and numbers, and none of that stuff, it means anything to them unless they know how to decrypt the information. And cryptography is another video that we did as a part of the security engineer path, and that's inside of the playlist for security engineers. So if you want to learn about ciphers and encryption, decryption, and all those things, algorithms, all of that stuff, it's inside of the cryptography video, which I actually recommend you do because it's actually a really, really awesome video. But yeah, that's basically the difference between HTTP and HTTPS. So the encryption method of HTTPS is SSL or TLS. And it relies on asymmetric, which means there is a public key and a private key, or symmetric, which basically uses the same key. Asymmetric encryption uses two keys, as it says, and the rule is to negotiate the symmetric encryption and the secret key. The default port of HTTPS is 443. HTTP is port 80. Again, this was all covered inside of the freaking intro to HTTP in Detail Room, excuse me. So encryption protects against interception and alteration of data, maintaining confidentiality, integrity, so on and so forth. So then you have File Transfer Protocol Secure, so FTPS protocol. File Transfer Protocol Secure is a communication which is refined and secured version of FTP, and FTP was developed in 1971 published as RFC 114, and there were a lot of improvements and changes that were made to it in the following versions. And it was designed as a model to send files, basically, file transfer protocol, as the name implies. So it is connections between a client and a server, along with the username and password. They both take place in an unencrypted form, which is basically in clear text, and the FTPS is encrypted. So the workflow is basically it adds TLS security to FTP, but everything else is exactly the same. And so you would send a request and a response in the same way that you would in HTTP. And the communication channels would be the control connection and the data connection channels. So in the control connection, the client, the FTP client, such as FileZilla, CuteFTP, or GoDaddy has their own FTP clients, and there's a lot of different ones. I've used FileZilla a lot because it's pretty nice when you set it up. You don't need to log into your web portal or your cPanel or anything like that. You can just run FileZilla from your desktop and it works very quickly. So it sends a connection request to the remote server on the default port, which is port 21. And then a control connection is used for sending and receiving commands and responses. Then there's a data connection after you've been authenticated, which is used for transferring data, which is files and folders and stuff like that. So there's two connection types for FTP, which is active and passive. And in active mode, the client, which is your computer, connects to the server on port 21 to establish a command connection. Then the server connects to the client on port 20 to establish a data connection. So you send a command connection, it responds with a data connection, and it's an active mode of FTP. And this type of connection is unsuitable in an environment where the client is behind a firewall because it's going to block incoming connections to the client. So in case of a client behind a firewall, the passive connection would be more suitable. And in passive connection, the client establishes the control and data connections. The client sends the passive command PASV to the server over the command channel. The server sends a random port to the client. And as soon as the client receives the port number, the client establishes a connection to the provided port so that the server can initiate the data transfer. So command connection sends via passive. So you first send the passive command. The server sends the port number for the data to be transferred through the port. And then the client opens the data channel on the port that the server said would work, in this case, port 21. And this type of connection works well when we are behind a firewall, which is usually how it should be processing. So then we have data types. So ASCII is type A, and it's the default type. It's used for text file transfers, and it's converted into 8-bit before transmission and then converted back upon reception. Image type I is commonly referred to as the binary mode, and it uses byte by byte transmission. The recipient stores the received bytes upon reception. Then you have EBCDIC, which is type E, and is suitable for text communication using the character set EBCDIC. And then you have local type, which is LN, and it's typically used for file transfer between machines that don't support 8-bit transfers. So N is the second parameter that represents the byte size that you would be putting into there. Then you have your request and response via FTP. So everything that we talked about so far has been FTP, and request and response via FTPS, excuse me. So it's the secure version of FTP. It adds an encryption layer to it. And then the two methods would be implicit and explicit. So implicit, FTPS client and server establish a link in which both command and data channels are secured automatically with SSL. Explicit, the FTP client explicitly requests the server to invoke a secured session on SSL or TLS on port 21 and then continue the transfer based on a mutually agreed mechanism for authentication. And then with explicit connection, you can choose which channel to encrypt by choosing among the three modes of the communication, which is either control only, data only, or both. and both control and data would be encrypted. The standard port for FTP and explicit FTPS is 21, whereas in 990, the case of implicit FTPS. So adding FTPS protects against sniffing attacks. Same thing. So essentially, all we're trying to do is protect against sniffing or man-in-the-middle attacks or anything like that. And really, all it takes is to just either use the appropriate port or just make sure you're using the appropriate protocol via your original method of communication. And then we have SMTP, Server Message Transfer Protocol S. So, excuse me, Simple Mail Transfer Protocol, my bad. So Simple Mail Transfer Protocol S, which is secure. So it's an extension of Simple Mail Transfer Protocol, which is used for email. And don't confuse it with POP3 because they're both used for email, but SMTP is the email push protocol, which is used to send messages out. So it would be the equivalent of your outbox if you want to think about it. And then POP3 is used for your inbox, so the stuff that you're receiving. So SMTP is outbox, POP3 is inbox. SMTPS is the secure version of SMTP. It uses SSL TLS, basically same shit, right? And then the protocol is you have SMTP end-to-end or SMTP store and forward. So end-to-end is used for communication between organizations, and it sends the client, in this case, the client initiates, and then the connection to the recipient server. And then SMTP store and forward is used for email communication within the organization, so not across organizations, within the organization. And in this model, the server, the SMTP server, will maintain a copy of the mail itself until the copy is forwarded to the receiver. Okay. Then you have your components of it, which is the user agent, which is, Outlook or Gmail or whatever. And then you have the mail transfer agent, which will transfer the mail from the user agent to the recipient mail transfer agent, and then go through the appropriate protocol. So SMTP used for outbox, it goes from the sender to the mail server, and then SMTP goes to the cloud, SMTP goes to the mail server, and then POP3 is used for the inbox to download the information, right? So the TLS process in SMTP, to make it secure, is not proprietary. It basically wraps SMTP inside TLS so that you can say that it's similar to SMTP on the application layer. There's just an extension of TLS at the transport layer. So for encryption, start TLS, is used between the email client and the email server to make sure that the transport layer encapsulates the data. We talked about that in the last video. It encapsulates the data so that it's transferred securely to the application layer. And so port 587 and 465 are frequently used for SMTPS traffic, and mail that's transmitted on regular SMTP is not encrypted, so they're prone to sniffing. Therefore, the secure version is used to encrypt the emails before you transmit it, and it also forbids attackers from sending spam messages from vulnerable or compromised domains, which is you have the spam mailbox that's how that actually knows what's going on. And then exfiltration sensitive information doesn't happen, conducting phishing attacks doesn't happen. A lot of those things are done by just making sure that you're using this secure TLS protocol before getting your email sent out. And then you have POP3S, right? So post office protocol, secure. And it's an extension of POP3. And it's used for encrypted retrieval, downloading, inbox of the email messages, and just understanding what POP3 does, and then securing it, right? So you have, like SMTP, POP3 has two components, which is the mail user agent and then the mail delivery. And so the email client establishes a connection with the server. The client downloads all the queued emails from the server, and this is the default option. The client can also select only particular emails to download, and then all emails are saved on the device that initiated the connection. So let's say your phone, and then the email server deletes the email copy, which is not good. You want it to stay there just in case you delete it from your phone. You don't want to lose the email. You know what I'm saying? So the limitations are the emails are processed locally, so no synchronization across multiple devices. When it downloads the email on the current device, it usually deletes them from the server. That's not good. Transmission is done through clear text. Again, not good. You don't want people to see your username and password. You don't want people to see your emails, so on and so forth. So POP3 secure, POP3S, is considered weak from a security point of view. It requires an added layer of security, or excuse me, POP3 is considered weak. So you add a layer of security, POP3S, and it's an extension of POP3. You wrap the communication or encapsulate the communication with TLS on the transport layer. And then same thing, start TLS as shown in the figure below, and then EHLO. After that happens, the POP3 server will trigger the switch to TLS, and it stands for extended hello. And then when it's used to identify the server. So you send the TCP handshake, which is, SYN acknowledge, and then acknowledge. The server responds, okay, ready? And then it also responds with hello, and then start TLS, or start TLS, excuse me. The client responds, start TLS, and then server says, okay, send it out, and then it sends the negotiation, and then the encrypted mail happens. So POP3S uses 995, POP3 uses 110 as far as the ports are concerned. And then we're going to talk about the ports for the application layer as well. So the default port for HTTPS is 443. In a passive FTP connection, what does the client send the first command over the command channel? And that would be passive. And then use the SSL Sharper website to check the SSL certificate of TryHackMe. Okay. I mean, we don't need to even do that, because you can literally just go up here, click on this little button that's usually a lock, and then it opens something up like this, and then you can go to connection is secure, and then it says connection is secure, certificate is valid, and then you just click on that, and then it brings the certificate of TryHackMe. So this is the general information of the certificate, the common name, organization, issued by E1, let's encrypt, and then the SHA-256 fingerprints of the certificate, and then the public key, right? And then you have the hierarchy of the details that goes into here, which is all the info to just make sure that it's a valid freaking thing right here. So that is the information about the TryHackMe certificate. But if we go to SSL Shopper, we can always just do it this way too. And there you go. So it resolves to that IP address. Server type is Cloudflare. It should be trusted by all major web browsers. Will expire in 25 days because they're going to renew it regularly so that people don't decrypt their certificates. Common name, SANS, valid, serial number, signature algorithm, the issuer is E1, so on and so forth. So this is it. See? That's just some good info about the site that we're using to make sure that we're secure. And then open SuperTool and select test email server option and check the SMTP security for smtp.gmail.com. So smtp.gmail.com, and here we go. This is what we got. DMARC record published, DMARC policy not enabled, DNS record published, DNS record not found, and that's basically all we got. So there we go. We got our info. So let's move on to our next task. This was a long task. Look at that. We talked about a bunch of stuff. So let's talk about application layer secure protocols here. So DNSSEC would be the secure version of the domain name system, and it's responsible for resolving domain names from IP addresses. So instead of having to remember the IP address, you just remember google.com, right? So it works by sending a DNS query. So when you look at the web browser, for example, and you send a query for the record type A or quadruple A, which is either IPv4 or IPv6 addresses, the output will be like this. So if we do sudo tshark port 53, for example, it'll give us the information as such, right? So standard standard DNS query, excuse me, and then example.com, and it gives us the IP address for it, example.com, and then you have the IPv6 version of the address as well. So it sends two DNS queries to the DNS server, and then regarding the domain name example.com, and we can see the responses for A and quadruple A. So the name to IP address resolution is very convenient. However, anyone on the network could have responded with a forged response. Furthermore, the host that sent the query would have accepted any response. In other words, the host would connect to a rogue server, and to avoid this would be using DNS secure. And that makes it possible to ensure that the response that we receive is from the actual domain owner. So it requires two things. The DNS zone owner needs to sign all the DNS records using their private key, and then the zone publishes the public key so that users can check the validity of the record signatures. And we saw that when we looked at the certificate for TryHackMe. So the data to the DNS queries is signed to ensure its integrity and authenticity, and we can efficiently check that signature. And with signed records, the DNS secure provides the following. You have authenticity and you have integrity. So you can confirm that the owner has authored and sent the record, and it's possible because the received record is signed by the owner's private key, and then we can ensure that no changes have been made by looking at the key itself and to check the records to see that the signature is actually valid. Open PGP. It's the first email that was sent in 1971, was sent in a completely different environment. So email protocols like SMTP and POP3 are designed to send emails in clear text, which happened in 1971. And IMAP is the same thing, and it allows synchronizing your mailbox with what's on the server. So it makes it no different than an exposed postcard that was open for everyone to see as it's handed from one person to another, right? And the image that we're looking at here is a very simplified example where a user uses the email client to send their email, and the mail server uses SMTP to deliver the email to the intended recipient, and everything is done on clear text. And the person who may intercept any of this stuff can read their email messages and maybe even their usernames and passwords and so on and so forth. So all of this is done without any of the secure methods that we just talked about in the previous task. So as email became more secure, or more popular, we started to connect to a web server and read their messages, and this is what it looks like getting it from the actual web server, this image right here. And in turn, it used a mail server to send the composed messages and receive incoming ones, and it was all through HTTP, which also means that it was all done through clear text as well, which was pretty much the same security issues. So then Google and Microsoft and Yahoo and all these different people realized that this is probably a big problem. And so they secured everything. And similar to the exact image right here. So nothing different as far as the process itself is concerned. It's just that all of this stuff got encrypted. All of these steps are now encrypted and everything is secure. So nothing is done in clear text. So you can't just read the stuff if you happen to be able to intercept that traffic. And then it got adopted by everybody. The S at the end of all that stuff refers to the word secure, which means that it's all secured on SSL or TLS. And this is what it would look like if the mail that the client uses SMTPS to send the email and POP3 or IMAPs to receive the email. And again, everything is encrypted and secure. So SSL TLS has secured a lot of things. It's changed the concept of a lot of stuff through the point that people feel comfortable sending their social security number, their bank account information, and a lot of those things via email. And it's, worlds different than what happened just a few decades ago. So you need to consider OpenPGP, which is pretty good privacy, and as an encryption program developed by Zimmerman, which is a badass, and he's developed a bunch of stuff for signing and encrypting files and email messages. GNU Privacy Guard, or simply GPG, is a free and open source implementation of OpenPGP, and it allows you to sign and encrypt your data and communication. So there's multiple layers of encryption if you don't just trust the secure versions of these protocols. And I mean, I don't think there's anything wrong with being more paranoid or more cautious, let's say. So it can easily integrate with your mail client to seamlessly sign, encrypt, and decrypt messages, and can be make sure that it's only readable by the intended recipient, because you now have an extra key that's attached to it. So it provides just an extra level of security. When used with email, it requires each user to generate a key pair, private and a public, and then you encrypt your stuff with the private key, they decrypt it with a public key, and then they get access to the content that's inside the email. So not very different from web browser interactions, except we're just using an open source software to create our keys, and then you just got to make sure that nobody else gets access to the decryption key. You know what I mean? That's kind of the whole idea here. This is what the simple example of this would look like before and after the encryption. So you have message text, and then you see the message, and then both parties would need to generate their key pair using GPG, and then it'll ask the user to provide their name and email address, and the private key should only be stored securely, obviously, while the public key could be shared with other parties that we want to communicate with. And then you use the GPG encrypt, and we actually use this inside of the cryptography video, so you can go check this out to see how GPG is used and what the different applications of it are. And just to kind of break it down, encrypt R so-and-so will encrypt the actual message text file using the public key, and then sign will sign the message using the private key, and armor is to produce the output using ASCII. And so now if you wanted to cat that, which would be the actual key right here, this is what it looks like, and it's not legible anymore. And then you have SSH for secure shell, and this came out to make up for the fact that Telnet and RLogin, which are not secure, and they do everything in clear text, those things need to be secured. So both of the protocols made it possible to log into a system over a network. Neither focused on security aspects, and the confidentiality of exchange traffic, especially credentials, was not protected. So that's why we went to SSH. And what you're seeing over here is a Wireshark packet that's been captured on a Telnet conversation. And then you can see that the password is literally, it says password, and then it has the actual password here. And then you have the login, which is Michael, and there's literally zero attempt at protecting the login information here. And if you just take the blue letters or just the red letters of this, you can see that the username is Michael, and then the password, then at least they didn't even try to turn it into red or blue. It's all just here, and that's ridiculous. But if you looked at the secure shell version of this, there's nothing. There's literally nothing that you can do here to try to figure out what the username is, what the password is, and you have to go through a completely different set of steps to even try to decrypt this information. So it's all great stuff. So first question here is, what is PGP? And that is pretty good privacy. And GPG, which is GNU privacy something. So what is GPG? Let's go look at that up here real quick. GNU Privacy Guard. There you go. That's what it is. So GNU Privacy Guard. And what command would you use to generate a key pair using GPG? And that is the command that we got here. So GPG encrypt is what we're going to use. And let's go here and do that and press that. It's not it. That's not the answer. Okay, so what's the answer? Oh, my bad. So it's GPG gen key. That's what it is. And there's that. And considering these following three clients, provide the number of the client that encrypts the traffic, and that would be SSH that encrypts the traffic. And that's it. That's all we had to do for this thing. So let us move to presentation and session layers, and it has a site attached to it, so that should be fun. And the technical overview of SSL TLS, so secure socket shell and transport layer security, the protocols that are used to encrypt data exchange between a client and a server. So we can consider it as a wrapper, not a person who raps, but a wrapper, like a candy wrapper that encrypts various communication protocols like FTP, HTTP, so on and so forth. So SSL is not commonly used nowadays because TLS has mostly replaced it, but you can find still a lot of SSL certificates and things like that for websites. And the handshake looks like this, right? So the client sends a hello message, the server sends a hello message, and then the authentication starts with the client, and it authenticates the server certificate, and then the pre-master secret, which is encrypted by the client as random bytes with the server's public key, and then the client retrieves that public key from the server's certificate when it checks through the authentication step. And then the decryption of the pre-master is done by the server with its private key. And then the session key for that session of that communication, that authentication, the session key is now generated. And based on those information, they should arrive at the same result, and it's not transmitted to anybody. So that's kind of important. That's why it's bolded here. And then the encryption and decryption are based on that key that's generated. And then once that is all done, once all of this stuff is done, these first 6 steps, then they're ready to communicate and actually do what they need to do. So client sends hello, server sends hello. The authentication step takes place with the pre-master secret, and then the server decrypts that pre-master secret and generates the session keys. And for this entire thing, it's not transmitted, the dotted line here. And then now you have an encrypted session, and they both just verify that the session has been encrypted. And so now you have SOCKS 5, which is a proxy protocol that's used to delegate the server for the SOCKS 5 proxy. And you can find this on the Tor Onion browser, the Brave browser. They use these proxies. And there's different versions of SOCKS as well. But they use mostly, there's a long list of IP addresses that can be used for proxies, and then it shows you what type of protocol that they're running for that proxy. So it's used to secure application layers. So for example, a Squid server implements the SOCKS 5 protocol and transfers data via HTTP. So the workflow here is the user A wants to connect with user B. There's a firewall between them. So the handshake is initiated by the client, and the client connects with the SOCKS 5 proxy and sends the first byte, where 5 is the SOCKS 5 version. Then they also send the second byte, which 1 means authentication is supported, and then they send another byte that could be any of these things, and they denote the supported authentication methods that can be of variety of lengths. And so you'll see that through the communication here, right? So you see that it sends the first one, that it could be either a 5, 1, or 0, and then the proxy responds with either a 5 or a 0, and then it sends the second one using the B host and the B port. and then it goes through the proxy, and then the proxy does a successful connection as well as sends back the B host and the B port. So the proxy replies, sends back a second byte, which is the chosen authentication method, and then after the initiation packet, the client sends the request packet, which includes B host and B port numbers, and a successful session is established between the proxy and client A. And the steps are involved with the association of client B with the proxy. So this happens between the client A and the proxy. The proxy sends the authentication request to the server and then responds back. And then the connection is actually officially established between these two, and they can now exchange data. So data transfer, after successfully associating both clients with the proxy server, they can now exchange data. So that's basically what it is. First, you connect with the proxy, and then the proxy sends the successful connection as well as the port request. So it first communicates with the server to verify, because we get it right here. So where is it? It says proxy sends back a second byte, which is the chosen authentication method by the proxy's server. And then from there, it sends the successful connection to the second client. And from there, you can actually establish the connection and transfer the data. So in direct communication, the internal details from the routing of the internet are hidden, and it acts as a relay server, bypassing the internet censorship based on the IP address of the client. So that's what the benefits of SOC 5 are. So does the hello message during the SSL handshake include the TLS version? And we're gonna say, let's see, it does. It includes the TLS version. So we're going to say yay to this, or yeah. During the client initiation process of SOC 5, what is the SOC version? If the client sends the first 5 bytes, and it would be 5. So in this case, it says 5 is the SOC version. So 5. And then we're going to click the view site and launch the site. What is the flag after completing that exercise? So let's actually launch this site and see what's going on here. So what do we got? We got, do you know how an SSL connection works? Place the blocks in correct order, showing a successful handshake. So let's see if we can figure that out. And there is our flag. So the client sends a hello, the server sends a hello, the client sends an authentication with the pre-master secret, the server decrypts the pre-master secret, the keys are not transmitted. This is one of the parts that we need to keep in mind, because we don't want those to be caught by anybody in the man in the middle for whatever reason. And then the session is encrypted. And just like that, we got our flag. And so, boom. And now we can move on to the last piece right here, which is our network layer. So let's go and check that out. IPsec, which is Internet Protocol Security, IP security. IPsec v3 is what we're going to be talking about in this particular room. And it provides security by adding authentication and protecting the integrity and confidentiality of the network traffic. So it uses the authentication header, which provides authentication integrity. It encapsulates the security payload, which is authentication integrity and confidentiality. And then you have the security association for negotiating the encryption keys and the algorithms. So the IKE, which is the Internet Key Exchange. And that's just one example of the security association. And we're not going to be talking about this in too much detail, because this is, networking in general is a very monstrosity of a topic, so we're not going to jump into the details of this. But what we're going to talk about is AH, which is authentication header, and the encapsulating security payload, ESP. So authentication header is responsible for the authentication and integrity of the traffic, but it can't protect the confidentiality of the data. So it works in two modes. You have the transport mode and the tunnel mode. And transport mode does authentication for TCP UDP, and tunnel mode provides authentication for the IP header, the TCP UDP header, and the data, right? So you have transport mode right here, and you have the AH header, and it provides TCP UDP header and the data, and then you have tunnel mode, which is the AH header, provides IP header, TCP UDP header, and the data. And the AH protocol, authentication header protocol, is suitable if providing authentication and integrity is enough without confidentiality, but it's, I have to understand that it's optional in IPsec version 3. It's mandatory in IPsec version 2. So encapsulating security payloads, ESP, it provides encryption in addition to authentication and integrity. So it has transport mode and tunnel mode as well, and it does pretty much the same thing, relatively or respectively. Confidentiality and integrity for TCP UDP header and the data, and then confidentiality and integrity for the IP header, TCP UDP header, and the data. And that's what it looks like. So you have the ESP header, the information in the middle, and then you have the ESP trailer, and then the ESP authentication, and then the header, the data, the trailer, and the authentication. So it's more secure, as it seems, right? Then you have the VPN. So when TCP/IP was designed, confidentiality and integrity were not a design target. So in contrast, availability was priority, as one of the purposes of the internet is to withstand a nuclear attack, as evident by the routing protocols adapting quickly when a link goes down. But we have to allow a corporation to use the existing internet infrastructure to connect the offices securely, and it sets the answers inside of the VPN. So if we do a virtual private network, it makes it possible to establish a private connection over a public network, and we can establish that secure connection over an insecure infrastructure. So if we look at this figure, we can see that a remote office and a remote user connected over a VPN to the main office. And the connection requires a VPN client like OpenVPN and a VPN server or concentrator. And all the traffic between VPN client and the server is encrypted. And all this talk about the VPN, there's something in the description of this video that actually has a really great VPN service that you can check out, because it's literally one of the, I guess we can call them the kind of like the sponsors of our service here, or not our service, of our videos and everything that we talk about, which is the SurfShark, SurfShark VPN antivirus, and all in one, and you can literally get it for $2 a month. That is more secure and more robust than something like OpenVPN, and you can get it in as many devices as you want. So unlimited devices getting a VPN and antivirus attached to it, and all of that can be done through SurfShark as a VPN. So, and in this case, the VPN client, in this particular case, trying to access to the main office and then the remote office, all that stuff. This little cloud security, this lock, all of that would be SurfShark in that particular case. That would act as your VPN client, or not as your VPN client, as your VPN specifically. And you would be able to get access to everything from the main office, whether or you're at the remote office, or if you're at home, etc., etc. Or if you just want to protect your data. That's also another reason why VPNs are used for. So it's a big deal, and I think most places now require that people have a VPN to do work, especially if you're going to be working remotely. It's mandatory. But even if you're not working remotely and you just want to use one of your IoT devices, for example, your phone, to access some resources, they come pre-configured with a VPN. so that you can get access to anything that's on their data centers or on their main servers through an encrypted and protected connection. So the common protocols are IP security, IPsec, and SSL TLS for VPN connections. And it's the perfect tool. IPsec's ESP is the perfect protocol for setting up these secure tunnels between networks or a computer, and making sure that security and integrity of all data that's transmitted between those points is all present. And then even if the IP address can be hidden in the tunnel mode if you wanted it to. So the system must be behind a VPN concentrator for the IP address to be hidden, and VPN systems offer IP security. So although SSL was created to secure HTTP traffic, SSL TLS has found its way to establish secure VPN connections with OpenVPN using various tools and libraries that are built around TLS. OpenVPN offers different authentication and encryption mechanisms to establish VPN connections. And of course there is SurfShark. So I'm gonna recommend SurfShark because it's not an open source. It's paid, and more often than not, and especially in this particular situation, you just get more with the $2 that you would be paying investing in the security of your devices, especially if you have multiple endpoints and you have a laptop and a tablet and a couple of phones and anything else that's inside of your family, and with the stuff that your family uses, to just make sure that you have secure connections and nobody sees your data, nobody can potentially do a man-in-the-middle attack or listen to your devices, and a bunch of other things that we are all susceptible to in the modern era of cyber attacks. So older protocols can also be used to establish VPN connections, but they are no longer considered secure. So one of them is the PPTP, point-to-point tunneling protocol, and it's no longer considered secure. So there are a bunch of things that can be used for establishing VPN security or VPN-like security. It just doesn't make sense to use them because hackers have caught up and they can mess with your data. So ESP stands for encapsulating security payloads, so encapsulation of of payloads itself. Which protocol does the Cisco VPN client use to establish a VPN connection? So the Cisco VPN client, let's see. I think we might be able to search for this in the page, but I think I might need to Google this. Oh no, actually it's right here. So Cisco VPN Systems offers IPsec. And which protocol does the OpenVPN project use for encryption? And that would be SSL TLS. And just like that, we are now done with our network layer security. So let's real quick look at the conclusion here. So we've covered various network security protocols for transferring of data and security of data. And most used mechanism for securing data over a channel is SSL TLS. And HTTPS uses it, FTPS uses it, POP3S, SMTPS, all those things use SSL TLS. The security protocol against man-in-the-middle, replay, and eavesdropping attacks is the SSL TLS protocol. So there's a lot of stuff that you can study about these things. The Wireshark room, which I think we've already done, and there's multiple. Yeah, I've definitely done the Wireshark 101. There are several Wireshark videos on this channel, including a 2.5 hour advanced session into Wireshark. So if you want to learn about Wireshark, I highly recommend that you check out those videos because they are pretty badass videos. So that was it for our network security protocols room. If you are studying for your security engineer, security analyst, Pentest Plus, ethical hacker, any of that stuff, I recommend that you like, subscribe, and turn on the notification bell. If you found this video useful, I recommend you do those things. If you want to get more videos in the future, I recommend you do those things. Everything that we talk about on this channel has to do with security and ethical hacking, pen testing, all of that stuff. So I think it'll be useful for you in your personal life, in your day-to-days as a security engineer and security analyst. And if you're taking any of those certification exams, I think this information will actually directly apply to that stuff as well. So I very much hope to see you in the comment section. I would love to have you as a part of our community, and I personally think that you'll get a lot of value out of it. So it would be awesome to have you in our growing community of ethical hackers and pen testers and all that good jazz. This has been your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker slash protector. And I will definitely see you in the next video. Love, peace, and chicken grease. If no one else loves you, Hank loves you. And I'll see you in the next room. Later. What is virtualization? How and why is it used? What are the most common virtualization technologies, including hypervisors and containers? And how can you use virtual technologies practically and understand their applications to security and modern computing? These are some of the questions that we're going to be answering in today's video. This video is of the virtualization and containers room that is of the network and system security module in the security engineer pathway of TryHackMe. My name is Hank Hackerson at Hank Hacks Hackers, and if you want to get more video about the security engineer pathway or cybersecurity analysis, ethical hacking, pen test plus, any of that stuff, I do invite you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. And definitely click around on the channel because we have a lot of playlists right now that had a lot of great content that you can use to become a cybersecurity professional. Now, without further ado, let's jump into the virtualization and containers room. All right, so what is virtualization? At the most basic level, it's the concept of encapsulating the abilities and features of a physical machine in a virtual environment. It's also known as a virtual machine. So when you virtualize something, that means you're basically creating a virtual Windows machine or a Linux machine, and then you can access that on any other type of machine. And one of the greatest images that I saw was this like really cool image. I'll show it to you right now that basically gives you a really perfect one-shot idea of what virtualization actually is. And this is basically it. So you have a car inside of another car. And this is, as far as I'm concerned, the best image that can describe what a virtual machine is. You have a machine inside of another machine. And virtualization essentially means creating, setting up a virtual machine inside of a physical machine. So why would you do something like this? Why would anybody do anything like this? Mostly, and the biggest reason is that it's really less expensive than anything else. So imagine having to pay, I don't know, a few $1,000s, depending on what kind of server that you need or what kind of computer that you need to build a physical server and then create, run it. And then there's the cost of the running of it, the electricity, all of that stuff. And then imagine that you need to upgrade it. And so if you needed to upgrade it, you would need to buy new pieces and new parts and upgrade it that way. And it just becomes even more expensive versus going to Microsoft Azure or Amazon AWS or Google Cloud, any of these cloud service providers, and getting a virtual machine through them. Another really good one is Linode, and getting a virtual machine through Linode. And then that way you essentially can get any kind, any level of virtual machine, any operating system. If you don't need it anymore, you just cancel that machine and you only pay for the week or for the month that you used it. Or if you need to upgrade it, you would upgrade it at a couple of clicks, and it would be literally a fraction of the cost that it would take to build a physical machine and update the physical machine. And then there's the scale of it. So if you need to scale up your physical servers, that means you need to go buy more physical servers and create more computers and get more storage to be able to house these things, and the security of it, and then the insurance and all of that stuff that goes into it, versus you just scale up by adding a couple of more machines to your virtual servers and adding some more virtual machines. So it just makes it super easy to scale up the resources that you need to do something like that. And then of course there's efficiency that has to do with it, which means it decreases the resources that are allocated. So if you have to spend, if you only have a limited amount of money to spend, then you go ahead and use a small portion of that and you get a bunch of virtual machines instead of spending that entire budget on building one machine. And then same thing again to the electricity that you would need to pay for, and you would need storage to be able to house all of these machines, and rent that goes to that, and the lease, and then you need to get fire and hazard type of insurance to make sure that if anything hits the fan, then you actually are covered for the cost of those things. So there's just so much cost and inefficiency that comes with a physical environment instead of getting a virtual environment. So there's a lot of benefits to it, honestly. And these are just a few of the key important ones. So virtualization technology is one of the big things that a lot of people have kind of in mind. And especially this was one of my questions to them, like, well, how the hell does this even work? Like, if I wanted to do this, where do I need to go? What do I need to do? And what are the different pieces, the steps to getting this done? So it's an in-depth question. They call it an intricate question. I think it's a sophisticated, in-depth question. And we're going to break down a few of the different technologies and platforms that are used to making something like this work. Something like the what was it called, hypervisor and containers and stuff like that. These are all things that actually happen or happen to be the technology that's used to make these things. And there's something called VMware, and there's a lot of different techs that it allows you to do this. And we need to expand on the definition of this to be able to understand what that actually means, what the different technologies are. So virtualization creates an abstraction layer, and this is a technical term, right? So it creates an abstraction layer over computer hardware. An abstraction layer allows a single device to be divided into multiple virtual computers, also known as VMs or virtual machines. So one computer, your computer that you're on right now, if you're watching this from your computer that you're on right now can house a bunch of different virtual machines. And that's what that specifically means. And you could do it by actually downloading the ISO, the image of the virtual machine that you want, and then putting it on a USB drive or installing it on a separate drive on your actual computer that you have right now. Or you go and you buy a VM for a couple of weeks or a couple of months from Linode or Google Cloud or something like that, and then you pay for that monthly. And then from there, you get a lot of different perks and benefits. For example, not having to download the actual disk image, and we'll get into that in a little bit, the disk image of the machine onto your computer, and then taking up space on your computer, and then launching it from your computer, which will take up memory and RAM and processing power from your computer. So all of those things happen when you download the disk image onto your computer and virtualize from your computer, versus when you go into a service like Linode, and that's the one that just keeps coming to mind because it's easy to pronounce, and launching it from the Linode portal and from that platform. In simpler terms, it means that the virtual machine will have access to logical resources that are abstracted from the physical resources. That's basically what that means. And that's supposed to be the simpler terms. So if you don't know what logical resources versus physical resources are, that might be a little bit over your head, but I think you can probably figure it out. So then there's the virtualization structure, and it's implemented using an engine machine format, which means a software or system creates an abstraction layer that we talked about, and it allocates resources, while an operating system or application can then be installed on top of that virtualized environment. And the operating system installed on a VM is also known as the guest operating system, guest OS, as opposed to the host OS, which is where the virtualization engine is running. So we're going to talk about this in a little bit, and we're going to talk about virtualization engine called hypervisors. So the first couple of questions here is scalability a primary benefit of virtualization? And we already discussed that, and that is a yes. And what is the operating system of a virtual machine often referred to as? And so that would be the operating system of the guest OS. There we go. So we got that, and now we can move on to our next piece, which is hypervisors. So in the virtualization, what is virtualization? We looked at a high-level view of this, and now we're going to actually go into the first type of virtualization engine, which is the hypervisor. and it provides the ability to create the abstraction layer that we talked about before between the hardware and the software. So between your computer and whatever it is that you want to download as your virtual machine. So it also generally includes some form of management application and software to provide an interface between the end user and the abstraction layer to create or load the actual machine. So there needs to be a specific third, not a third party, but an in-between kind of a software that allows you to launch the machine. That's kind of the big deal here, is that once you download the disk image on your computer and you want to launch it, you need to use some kind of software to be able to launch it. Hypervisors are separated into two categories, and they're determined by their position relative to the hardware. So they can either directly create a lightweight operating system on top of the hardware, or add a hypervisor as an application on top of a pre-existing operating system. So type 1 is also known as the bare metal hypervisor, creates an abstraction layer directly between the hardware and the virtual machine without a common operating system between them. So instead, the hypervisor is the operating system, and it's often headless with a web-based management portal that's remotely accessed. So we talked about this. Linode would be an example of this. These hypervisors are designed for scale and deploy a large number of virtual machines at once, and they're extremely lightweight to dedicate the most resources to the virtual machines. And this is kind of what it looks like. So you have the hardware, which is your machine, and then you have the hypervisor that ends up acting as the portal. And then on top of that, inside of the hypervisor, you have the guest OS. So this is one machine, this is another operating system, so on and so forth. So examples include VMware, ESXi, Proxmox, VMware vSphere, Xen, KVM, but there's a lot of them. So type 1 hypervisors, if you Google it, or a headless hypervisor, if you Google it, you'll get a lot of different examples of that, and companies that offer them. And a lot of these things are open source, by the way. So you can get open source free versions of this. Obviously, they're not as robust and they don't offer as many features, but they're functional and you can run machines from them. So type 2 hypervisors, they're known as hosted hypervisors. They create an abstraction layer from a software application built on top of a pre-existing operating system. And unlike type 1, type 2 are often managed directly from the application through a GUI, and these are often designed for end users or individuals such as developers, and are not strictly designed to run a large number of virtual machines for scale. So you have the hardware, and then you have the host operating system, meaning the operating system of the hardware, and then you have applications that are inside of the host operating system, and then you have the hypervisor that is also part of the applications, or I guess on the same level of the applications. And then from there, inside the hypervisor, you can launch your guest operating system. So the host operating system would be if you have a Windows machine. So I have a Mac right now. So my Mac OS would end up being my host operating system, and then I have a bunch of applications on my Mac. And then in addition to my applications, I can have a hypervisor that can allow a guest OS, a Windows machine or a Linux machine to be run from my Mac. And that would be considered a type 2 hypervisor. And it's going to be available only to my specific Mac because I'm using it as the developer, and it's not meant to be accessed by a million other people inside of the organization, right? So that's kind of the big difference here. So what type of hypervisor is VirtualBox considered? And that is a type 1. And what are type 1 hypervisors also known as? And they are known as bare metal hypervisors. All right, now on to containers. Hypervisors work as expected for a large number of use cases, but begin to encounter issues when scaling lightweight applications. So they're called microservices, and they give us a good example of an application architecture that encounters issues when deployed from a hypervisor, right? A microservice is an application structure that's broken up into smaller services, as the name implies. It's a microservice. And those smaller services are scalable and use lightweight protocols and features. And the lightweight nature of this poses obvious issues that require a large number of virtual machines, each with high resource usage. So containers are the current solution to the issues that are encountered with hypervisors at scale. So if you can imagine what a container, a microservice would be inside its own container, right? Containers have a lot in common with virtual machines, but instead of being completely abstracted from the host operating system, containers share some properties with the host operating system. They have their own file system, a portion of computing resources like the CPU and the RAM, a process space, and a few more other things. Apart from obvious benefits, containers are also portable and robust. So they're portable and robust, which usually don't go hand in hand. So that's what makes them actually pretty freaking useful, because they're not completely abstracted, right? So container engines are second types of virtualization. So we had virtualization or the hypervisor as first the type of virtualization, and then you have the container as the second type of virtualization. Since virtual machines use a hypervisor to create an abstraction layer for virtualization, containers use a container engine to create an abstraction layer using resources logically instead of physical resources. So what we're going to talk about in the next one is the Docker, which is a really big concept you're going to run across if you have to do anything like this, any kind of sysadmin type of an job or job description. You're going to hear the word Docker a lot. Help desk and IT support, all of those people also use Dockers, and they have to learn how to navigate Dockers and basically know how to manipulate them, install within them, uninstall, troubleshoot, patch, things like that. So containers are containers completely abstracted from the host operating system. They are not. They actually use certain pieces of the host operating system like the CPU and the RAM and things like that. So let's actually talk about the Docker now. All right, so this task requires for us to load a virtual machine, and that one is up and running in a little bit. So while that's running and loading, let's read into this. So it says, if you're familiar with containers, Docker is likely the first name that comes to mind. It's a container platform and engine that is used to run Docker images, and we talked about disk images earlier, and it runs those images as individual containers. And our machine seems to be loaded. Well, it has a connection error now, so we're just going to wait for that to fully load. So each Docker image is built of a base image, such as Alpine, Ubuntu, anything like that, and it's specifically built for use in containers, and it's very lightweight. So to build one, a Docker file must be created, and it defines the base image for a container. And image in this case, we're going to be using this a lot. An image is essentially a compact version of the actual operating system inside of that container. Is called an image. We're not talking about like a visual picture kind of a thing. You're talking about a disk image, operating system image, a machine image. That's what we're going to be talking about, and that's what it means in this context. So for more information, you can go to the Intro to Docker room, which I have not done actually. So that will be something that we can check out later, and we're probably going to run into it at some point. So running and interacting with a Docker container is done typically through the command line, unless you actually use a GUI, and those things actually are super helpful as well. But I always like learning about the command line first so that you know what's going on in the background and your foundation is super strong. And then when you use a GUI, then it becomes even more useful for you, and you have even more appreciation for it because you know what's actually happening behind the scenes in the actual command line itself. So Docker Hub is a remote repository for Docker images, similar to GitHub, which is a remote repository for Gits. Using Docker Hub, we can pull images and push our own images, or push our own images. So Docker pull pulls the image, and so it would be the user as well as the image that that user belongs to. Alternatively, a container image can be automatically pulled when running the container for the first time. Once a container is pulled for the first time, it'll be cached locally, and Docker will look for it locally before attempting to download it. So if it doesn't exist, obviously it's not going to work. So Then you have run the user image. Once it's started, we can verify that Docker engine is running running the container by listing processes running in Docker using this below command, which is the PS for process command. From the process command right here, you may notice that the container will be assigned a random identifier, IP address, and network interface. So now we can actually do this with our virtual machine that is now populated, and we have the user and password for it. So before starting it, we have to first introduce two new flags that must be used with it, which is the D flag as well as the P flag. And the D flag is detaching the container from the current terminal and exposes the external and expose ports externally, which is the P flag right here. So the required syntax will look like this. So Docker run P on port 5000, right? The D, which is this, is the username, and then this is the image that we're going to be running. And then to verify that it's running, we can scan the container or access the designated work in a web browser. Certain special characters may not be visible in the provider VM. Doing a copy paste, when doing a copy paste, it will still copy all the characters. So that is all good. So now what we can do is first we're going to virtualize this machine, and then from here we're going to go and access it by going to our web browser at that port, and then we're going to find the flag that we need. So here's our Linux machine. If you haven't seen this before, this is exactly what a Linux server or a Linux machine looks like. It does not have a graphic user interface. It's all command line. So that's why it's very important for us to be able to do this. So what we're going to do in this particular case is we're going to run the command that we have here and see what we can find when we actually go into the web browser. All right, so I just went ahead and typed in clear to clear the screen of the text that we had previously. So the first thing that we want to do is we just want to check to make sure that we actually have this image of this sample that we're looking at down here. We just want to make sure that this is actually running in our repository. So we're going to do Docker images as our command, and there it is. So we actually have the repository Krylik, I don't know how to pronounce that, Krylik THM example app. And so they did mention that some characters aren't going to be visible, for example the underscore. The tag would be the latest. The image ID is here, created 13 months ago, and it's a 59 megabyte file. So from here we're going to go ahead and just run the command that we have over here to just make sure that we're going to be able to run this particular repository that's here. So we're going to do we're just going to type this out. Okay, and that's running, and I think it's running because it finished and it gave me my little $sign, which means that the command line is now all good. So which means that I should be able to just go to this link now because there's no web browser or anything. So let's see if this actually runs. No, it's going to machine IP 5000, so I don't think that's actually going to work. So let me see, how am I supposed to access this? Because this doesn't have a web browser inside of this machine. Which means that I have to probably go into my attack box or something like that and then access it that way. So I'm just going to start the attack box, and that's going to take a few minutes as well. And once the attack box is up, I'm going to be able to go ahead and do it. And if you want to use your own Kali Linux machine, or if you want to just SSH secure shell into this machine, you can. For the intensive purposes of this video, I'm just going to use the attack box that's provided by TryHackMe to go ahead and just run this, and from there we're going to be able to get access to our little server that we just launched. All right, cool. So this is what the attack box looks like. It's basically an Ubuntu Linux machine that allows us to do all kinds of fun things. In this particular case, the only thing that we're really trying to do is just go to this web address right here. So I am going to type that inside this browser, and we're going to see what our flag is. So let's check it out. Okay, there you go. Very basic web page. Nothing fancy about it, just one giant headline That is our flag. And that's it. Just like that, we copy that and then we paste that and boom, it's running. That's it. So just to kind of review what happened, right? So I didn't need to pull any kind of an image. I didn't need to run any kind of an image because it was all just running. So all I did was I just went into our Ubuntu machine and I just ran it. I just ran the command that they gave us right here. And I could have done the same exact thing by doing an SSH and logging into this machine and running it that way. So what that looks like, so if you did this from your own machine and you wanted to SSH into it before you did the run command, you would be able to do it by literally just opening up a terminal and just SSHing into this. So here's what that's going to look like. So I'm just going to minimize this real quick. And then we're going to open up a terminal. And then we're literally going to SSH using these credentials right here. We're just going to SSH into this machine. So there's the SSH command. You press enter. Do you want to do this? Yes, I do want to do this. And then now I have to type in the password, and it doesn't show you what you're typing. So you just got to make sure that you actually type it in correctly. And there you go. Now I'm into the actual machine itself. And so if I just did the same exact command, right? So if I just do Docker images, it'll give me what the image that was available on that Linux machine. It'll just show it to me on this thing like that. So same exact image. And so then what I could do is I could just go ahead and copy paste this and just run it and then go into my browser and then visit that address, so on and so forth. So the rest of the commands would be exactly the same. This is just what it would look like instead of actually loading it from the Linux machine that it gave us, from this machine. Instead of loading it from this, you would load it from your SSH portal or your web shell, so to speak. So that's pretty much it. That's all we had to do for our Docker task here. And so now I'm going to terminate this because I need to start another machine for our Kubernetes task right here. So let's go and look at Kubernetes. All right, so Kubernetes, through the use of hypervisors and containers, most problems associated with traditional computing are resolved, such as cost and efficiency. But it still leaves the question, what if we need a faster and more scalable solution? And that is load and other criteria changes, the resources or the number of instances allocated to the application increase or decrease on the fly as needed. That part, that on the fly part, which means like with a couple of clicks, you need to be able to click around, virtualize something, take something down very quickly on the fly, right? So Kubernetes, also shortened to K8s, is one such solution as an orchestration platform. An orchestration platform aims to integrate into other products such as Docker and extend their capabilities or synchronize them with other products or applications. It relies on these traditional virtualization models like hypervisors, containers, and extends their uses, features, and capabilities, which is literally basically what this freaking thing said right here. I don't know why they rewrote that sentence. These capabilities include horizontal scaling, traditional vertical scaling. Horizontal scaling refers to adding devices or machines to handle increased workloads rather than adding logic or resources such as CPU or RAM. So I'm going to show you what this looks like. Hold on. So this is a pretty good demonstration of vertical versus horizontal scaling. So vertical scaling means instead of having this small server, you just get a much bigger server, right? So you add processing power to your current one server. So you just make it more powerful. You vertically scale up. Horizontal scaling means instead of making this thing bigger, you just add another server or add another server or add 10 more servers, whatever that may mean. And sometimes what you need to do is you just need to duplicate the same current server that you had by 100. And instead of virtualizing every single one, a lot of different portals and platforms allow you to say, hey, you know what, this thing that I have, I want to duplicate this by 100 and create 100 new copies of this one particular server horizontally, which means what? In this particular case, in this vertical environment, that same user, so let's say you have one system admin or one user that is using this machine, and now they have a much more powerful machine that they can use. In this particular case, instead of just having that one user, now you have 3 users, or if you had 100 of these, you have 100 users, right? So that's what that looks like, that they can go and access their own account on their own machine with their own files, so on and so forth. So that's the difference between vertical scaling and horizontal scaling. And it's just a lot of times it's easier to see it in a visual instead of just reading through some text and stuff like that. So that's what horizontal scaling is. Then you have extensibility, which means that clusters or a bunch of machines, it's also known as a cluster. So let's say you have 10 machines, that's a cluster of 10. They can be modified dynamically without affecting containers outside of that particular group or outside of that particular cluster. Then there's self-healing. Kubernetes can automatically restart, replace, reschedule, and kill containers that are not properly functioning based on user-defined health checks. Very, very cool. Automated rollouts and rollbacks, so it can progressively roll out changes to the containers. As changes are made, it will monitor the application's health and decide whether to continue the rollout or roll back. This ensures the constant uptime of your cluster, even if some containers fail, which is very, very useful. So another version of this is that you have 10 machines and you need to roll out another 10. You can do that without affecting the first 10. You have 10 machines, 3 of them fail. You can just add another 3 and get rid of the 3 that failed without affecting everybody else. So automated rollouts and rollbacks, automated. The automated part means that you literally check a box that says, I want to automatically roll out or roll back something based on its function. And so if it's not working, automatically it just goes to another machine that will actually work, just in case that first one for whatever reason crashed. So whoever the end user is, there is no disruption of service for them. And that's very, very important. It's done automatically. Your cloud service provider will do it for you. Kubernetes in this particular case being the specific platform that you're using, Kubernetes will end up doing it for you. The orchestration of Kubernetes, that's literally what that means, is that you just assign certain tasks and you choose certain options, and from there Kubernetes does all of the management and administration for you. It's super freaking useful, honestly, when you think about it. Instead of you having to constantly be there stressing out and trying to figure it out, and it does it for you just by you predetermining what you want. It's super useful. So to get hands-on with Kubernetes, we've given access to a pre-deployed cluster. So we're going to actually make sure that we launch this, and while that's happening, we can read the rest of this. So to get hands-on with this, we got access to pre-deployed cluster configured with kubectl. And because Kubernetes provides most of the basic automation by default, we want to explore the differences between Kubernetes and a traditional virtualization platform on our own. So that being said, Kubernetes is a large platform with a pervasive list of features. What a word, pervasive. We encourage you to continue investigating DevOps and the features of Kubernetes, and we will only provide you with a basic set of questions to get started. So to access the cluster, deploy the machine. We can also SSH into the machine, so on and so forth. So I'm just going to wait for the IP address of this thing to actually load. And then once it loads, I'm going to give it a few minutes. It's telling us give it 3 to 5 minutes for it to fully load. So once it actually does load, and it looks like it's loaded. So let's see if it actually works. Once it does, then we're going to go ahead and start this whole thing. So let's do it. All right, so while we are waiting for this thing to fully load, there is a little reference link that they've given us, which takes us to the Kubernetes quick reference guide here. And so we can run a bunch of different types of commands to get access to a bunch of different types of things using the Kubernetes command line. And from the very, very top, it seems like it would be a good idea for us to turn on autocomplete so that we can, autocomplete things without having to manually type everything out. So I'm probably going to do that first. And then from there, we'll just go ahead and answer the rest of these questions. And it actually tells us right here that before proceeding, ensure that all clusters are started by running minikube start. So let me run minikube. Or you know what? Let me go to the attack box and do this just to make it a little bit easier, because that allows us to copy paste things a little bit more easily and kind of go back and forth between this thing. So we're going to first clear that, and we're going to SSH into our new machine by using the new IP address that we got. And yes. All right, cool. We are now in the machine. So let's do mini cube start. Okay, so it's basically saying that it's not running yet. So I'm gonna give it a few more minutes before I try to restart that thing. Okay, cool. So that time it actually worked. And so this is what it actually looks like when you do minikube start, and it goes through all the prompts and it says done. kubectl is now configured as a minikube, or to use minikube, versus the other one where, you know, it didn't work and then it says signal killed, so on and so forth. So we now actually have our minikube started. So we can click on complete on this thing. And the first question here, it says how many pods are running on the provided cluster. So let's see what the hint says. It says kubectl get pods. So that would be the command that we're supposed to run. So we're going to do kubectl get pods. And let's see how many pods we got. Okay, so one pod. Hello, TryHackMe gibberish. Yada yada yada. So that's what it is. Okay, so hello TryHackMe is one of one. How many system pods are running on the provided cluster? We're going to look at this, and it says get pods, or excuse me, it says get pods dash A. So same thing, we're just going to do a dash A at the end. So I think dash A may stand for all. So kubectl get pods, and then dash A, and it's a capital A in this case. So let's see how many of those show up. Okay, so maybe instead of it all being one word, which this is kind of what it looks like over here at first glance, but now I realize that maybe there's a little space in between those two. So instead of it being as one thing, I'm going to do kubectl get pods space dash A, like that. And that should probably work. There we go. All right, so we got it. And so it says how many system pods are there. So we actually have several that are running. This first one is the default, and it doesn't seem to be a system pod. So if we're counting only the system ones, I think that is 7. So let's see if 7 is the right number here. And it is. Okay, great. So what is the pod name on the provided cluster? So hint is what? Get pods. So same thing. So it's going to be this thing right here. This full thing, I believe, is the pod name. So I'm going to copy that. Cool beans. And what is the deployment name on the provided cluster? So let's see what that is. So it says get deployments. I mean, these seem to be pretty freaking intuitive, really. Get deployments. Let's see what that says. It says hello TryHackMe. So we'll just type this out. All right, cool. So what port is exposed by the service in question 5? What is this? I'm guessing this one is the question 5. So now what is the hint for this? So it says get services. Okay, so let's do kubectl get services. All right, so we got it. And so let's see, what is the port here? Node port? Is that the name? So hello TryHackMe is the name. And so I think I need to kind of expand this a little bit just so I can see what's going on. Oh no, here we go. So we got the ports right here. So once we expanded that, it made it a little bit easier to read this. So it's either port 8080 or 31449. So let's see. Let's try 8080. Yeah, it is 8080. Okay, great. So there is that. And how many replica sets are deployed on the provided cluster? So it's going to say get rs. So kubectl get rs. And there we go. How many replica sets? We have one replica set. Very good. And what is the replica set name? And it's very similar to the other one, but now this time it has different numbers and characters at the end of it. So boom. And last but not least, what command would be used to delete the deployment from question 5? So it would probably be kubectl delete. I'm just going to try that. And then paste. Oh no, that's not the answer. Dang it. Okay, so what's the answer? It says kubectl help menu or online resources. All right, fine. So now we're going to actually go and use our online resources for this one. And I'm going to search for delete to see what I can do here. So kubectl config unset. So maybe unset is the word that we want to use. Let's see what else we can find that has delete in it. So these are all the different delete patterns. So kubectl delete pods, delete so on and so forth. So delete a pod using the type and name specified, delete a pod with no grace period, delete pods and services with names as Baz and Foo, delete pods and services with label name, my label. Let's see, all pods and so on and so forth. So what is this? This is, what are we doing? It's a replica set name. So maybe we're looking for delete replica. Maybe that's what we need to do. Let me see. Let's go see what else we can find here. Yeah, I think it's one of these things. So specifically, I'm not sure which one it is. I think it's going to be pods and services. But I am not sure in this particular case. So let's see what we need to do. It's what command would delete the deployment from question 5. All right, so did a little bit of Googling because I actually couldn't find it inside this quick reference guide because none of the delete commands actually helped us. And then I searched for deployment because that's actually what we have here is a deployment. And it said, what is the deployment name? And that's what it is hello TryHackMe. So from question 5, this was the one. So hello TryHackMe, and it's a deployment that we're trying to delete in this case. So we need to find a command that deletes deployments. And so that's basically what I Googled. And the command is right here. So it says kubectl delete deployment and then the deployment name. So that's what we're going to try now. So I'm going to do this kubectl delete deployment, and then it's going to be hello TryHackMe. Hey, look at that. Oh, they've updated a lot of things about the design since the last time I accidentally clicked out of it, and now I can't share that I finished my thing for this room. I'm so upset. I wanna be able to share that on LinkedIn. Anyways, that is it. That was literally it for our virtualization and containers tasks and room. So hopefully you actually got a lot of value out of this and you learned some good things about virtualization, containers, of course, the hypervisors, Docker, and Kubernetes. As always, I encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. We have a lot of good stuff that's coming out on this channel. It's all about security engineering, security analysis, penetration testing, ethical hacking, all that good stuff. And if you're studying for any of those certifications, or if you want to do any of those things for your day-to-day as a job, then this channel will be super helpful to you, I promise you. And there's already a lot of people that are coming through the comments and asking their questions, and we talk back and forth about a lot of these things. And if certain requests come in, I do go ahead and fulfill those requests for content and things like that. So I will do my very best to create content to actually answer your questions. Apart from that, I would love to see you in our comment section and just as a part of our community. And I will do my very, 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 very best to make sure that you are catered to and you're taken care of and you get some good content so you can learn some good stuff and become an ethical hacker, all that shit. So anyways, It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker slash protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next room. Later. What is cloud security? What are the different cloud security models? How do you achieve cloud security through policies and procedures? How do you achieve cloud security through identity and access management, which is IAM? How do you achieve cloud security through networking management? And finally, through storage management. These are some of the questions that we are going to be answering in today's video, which is Intro to Cloud Security. And this is a part of the network and system security module inside of the security engineer pathway of TryHackMe. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker slash protector. And if you want to get more videos like this, then go ahead and like, subscribe, and turn on that notification bell so that you can get notified the next time that a video drops on this channel. Now, without further ado, let's jump into the introduction of the cloud security room. All right, by now you should have probably heard of cloud computing in some capacity at some point. It's become really popular, especially as it becomes cheaper for the infrastructure and all of the server rooms and the physical infrastructure to be set up so that companies like Google Cloud and AWS and Linode and all these different companies can provide cloud computing services to us. And it's an evolving world, and so the term cloud computing is an evolving term. And to make it as simple as possible, cloud computing means delivering computing services over the internet, which is considered the cloud. So the customer, being you or me or a company, they don't need to buy and maintain physical data centers and servers like the traditional world. They rent those things from a company like AWS or Google Cloud, right? Or Microsoft Azure, stuff like that. So all of the services that they would need would come from a pay-as-you-go pricing, meaning pay per usage of the service, and you can cancel it at any point, buy it for or rent it for a couple of weeks and cancel it. So there's a lot of different ways that you can do it, and it offers scalability, it offers flexibility, allowing you to do a lot of cool stuff. And we discussed this in one of the previous videos when we were talking about virtualization and containers and stuff like that. So we did go over that already. So what we're going to be talking about in this particular video is the security of those environments. So very much like having a physical computer, there is a lot of vulnerabilities that comes with having a cloud-based computer or virtual machine. And so as a security engineer, it's our job to make sure that those computers and the services attached to those computers are all secure. Some of the prerequisites that you'll need is HTTP protocols and servers, as well as principles of security. I've already done a video on security principles, so you can go check that out. And HTTP protocols and servers, we've already actually done as well, but you can just go and check these things out. But there is already a video on this as well. So protocols and servers for HTTP and just the regular stuff. So you should be familiar with all of these things already. If you're not, go ahead and check out those videos so that you can get familiar with them before we dive into the rest of this video. So now that we've gone through that, let's talk about architectural concepts of the cloud. As we talked about in several other videos as well, and again, you've probably heard of this by now as well, characteristics of a cloud come in 4 general categories, I guess, that we can talk about them. And all of these things are meant to serve business continuity operations, which is acronymed as BCO. And there's a lot of different services for, or reasons for this, benefits for this, purposes. There we go, that's a good word. So storing data, taking backups, disaster recovery, all of those things fall under continuity. So being able to continue operations for a business, all of those things are really important to do that. And then you have the option of scaling. So if you wanted to scale the virtual machines that you have because you hired 10 new employees, or you need just more power for one particular server. You can do all of that. You can buy resources at a time, then buy upon the need of your business, and then they can be scaled up or down per the needs of your business. And then you have simplicity, just making it super freaking easy to do all those things. Nobody needs to learn how to set up a server or build a computer, anything like that. With a couple of clicks, usually you can just get something running. And same thing, with a couple of clicks, you can get rid of it and delete that computer and just never have to worry about it again. Cost effective, super cheap in a lot of cases. For literally just a couple of bucks per month, you can get a virtual machine. And like the more expensive ones would be like, let's say $50 a month or something like that. And then versus, comparing that to several $1,000s for one computer, it's not even comparable in a lot of cases. And then you can customize the stuff that you're getting so that you only pay for what you need. And then as soon as you're done with it, you can just get rid of it. And again, it'll be like, if you only needed it for a month, you just use it for a month and then you get rid of it. So for $40, $50, you got something done, versus having to spend a few thousand just to build it and then worry about selling it and all of that stuff. So, and then you have enhanced automation. So there's a lot of great automation stuff that comes with most cloud computing services, that they limit human administration. So if you need to scale something up, you can just click a button and it'll scale it up when it reaches its capacity. Or if you need to set up some kind of a backup just in case one crashes, and you want to continue the operations of the business, you can literally just click a button. And for whatever reason, if the main server that crashed, or the main server that your virtual machine was on crashes for whatever reason, it automatically goes to a backup server, so your business just continues. And that's like a really important benefit, because sometimes an earthquake could happen, or like a fire or a hurricane or something could happen, and the physical server database or the physical server warehouse can crash or go out of service, and then you will be SOL if you didn't have that backup. So all of that stuff is just some basic but really important benefits of having cloud computing. Then we have the models of cloud computing, and they go into different tiers and levels as well. So you have infrastructure as a service, platform as a service, and then software as a service. So infrastructure as a service has a few distinct characters, and as you go further along in this, it becomes less and less required for management from us as the users, and setup and configuration and stuff like that. So infrastructure as a service, the customer has complete control of the operating system, servers, and applications. The cloud provider maintains and provides data centers with racks, machines, cables, and all of the physical utilities. So they have all the infrastructure. Our responsibility in this case is to manage the logical resources like the software and the operating system. So they let you have the machines and the physical infrastructure, but then you would have to install an operating system on top of that, and then install software on top of that. Then when you go a level up from that, the servers, the responsibilities of the cloud provider ends up being the infrastructure and the platform, and then customers can choose the platform that we would need, and the service provider is just responsible for managing the infrastructure and the platform. And the only thing that the customer would have to worry about is installing software based on our requirements. So in this particular case, you get a Windows machine, for example, and then all you got to do is worry about installing the software on the Windows machine as you need it. And then finally, they have all of these things provided for you, and then the only thing that you need to do is just choose the software that you want to use, right? So in software as a service, everything is managed by the cloud provider, including infrastructure, OS, and the software, and all you're literally doing is choosing which one that you want, which type of software that you want to use, versus the other one. So if we were to use kind of like an example of this, you could say in this one, you're choosing to use Microsoft Exchange, for example, or Outlook, which is the software. In this example, you're using Outlook, but you also need to worry about installing the Microsoft machine. And again, it's not like you have to actually do the installation. You just choose to do the installation, and then they do the installation in the background for you. In this particular case, you end up doing essentially making all of the choices. So you say, I want a computer that has all of these capabilities, and you pick and choose what types of RAM and processor you want to use. On top of that, you would choose what kind of OS you want to use, and then once you have all of that set up, you choose what type of software you want to use. So it becomes more controlled in this environment, but it also means that you need to be better at managing the resources, and this is less controlled. You just choose the software that you want to use. To show you the comparison between on-site infrastructure, platform, and software as a service, you get to see what you would have to manage and what the service provider manages. So the blue boxes are the things that you have to manage, and the red boxes are the stuff that the service provider manages. And so when it's on site, when you build the service or the server, let's say, you build the server, you build the data processor, data center, whatever it is, the computer, any of those things. When you do it, you literally go from the bottom up. You set up the network, the storage, the server itself. You got to virtualize the machine and install the OS on it. Then there's the middleware, which is everything in between the OS and the actual applications. Then the runtime, the data, all of that you have to manage. Networking, storage, servers, and virtualization are all offered by the cloud provider, by the service provider. And then all you got to worry about is the OS, middleware, runtime, data, and applications. And this is for infrastructure as a service. Then when you go platform as a service, they literally offer all of these things, and all you got to worry about is the data and the applications. And then finally, software as a service, they provide everything. They literally provide everything. You don't have to worry about installing any of this stuff. You just use them at this point. And it becomes less and less for you to manage and worry about the further along you go with all of these things, okay? So the deployment models would be public cloud, private cloud, or hybrid cloud. And public cloud is resources provided by a cloud provider that are shared among multiple customers. So you could have multiple companies be a customer. So organization A will use resources from the same hardware and offer services to any other organization. For example, Microsoft Azure and Amazon Web Services are examples of public clouds. However, they also offer virtual private clouds services. So you could have two organizations using the same server, right? That could be a public cloud. Private cloud, customers don't share the underlying resources, hardware or software, and resources are dedicated to one single customer. So organization A will get their own virtual machine hosted on a system specifically dedicated for that particular customer. And then you have hybrid, which is the combination of public and private. So organization A might want to use some private cloud resources for themselves to host confidential data, but then they also want public cloud just so, for testing applications and software so that the production system doesn't crash during the testing. And then you have the important terminologies, virtualization, we talked about in the last video. In this specific pathway, in this module actually, computing, so defined as processing power customers require to run applications and data for processing and carry out different tasks. In cloud computing, customers can get computing power from a combination of virtual machines hosted in their environment. Then you have storage, which is pretty self-explanatory. So you don't need to buy and maintain physical hard drives when you're using the cloud. Instead, the data is stored in logical pools of physical storage on the cloud provider's premises. And then you can scale up or scale down based on what you would need. And then networking, cloud computing is a system of computers and processes that are interconnected. You have a network, so you maintain a high-speed network and you need to have that connection, and that's very, very important. So the cloud provider is responsible for providing network connectivity to meet customer needs without disruption. So in infrastructure as a service, what will be the deployed by the vendor, the hardware or the software? And so if we're going to infrastructure, that refers to the physical stuff, which is the hardware. And then what is the type of cloud dedicated to a single customer, and that is a private cloud. So we got all the stuff that we would need for architectural concepts, and now let's jump into cloud security concepts. All right, now that we understand what a cloud is and what cloud infrastructure and software and platforms are, the key concept that we need to understand is that we need to protect stuff that is inside of the cloud. And the infrastructure, for example, the physical hardware of stuff, of a server, the physical hardware is protected by Amazon if we're using AWS. So Amazon has security guards, they have warehouses, they have security cameras, and all those things. They protect that physical infrastructure. So you don't have to worry about protecting the physical stuff. What you need to worry about is protecting the digital stuff. And that, in this case, is considered to be data. And it's an asset that can be anything, any piece of information that a customer organization has, and it can be categorized in different levels. So you have confidential data, and it's considered the most critical data. And it could be something like credit card information or customer information, and it can damage the organization's reputation and include personal identifiable information. So anything, if something happens to this data, it damages the business in many, many ways. Then you have internal data, and it's information that if it was exposed, it causes moderate risk or harm to the company, but not as much as if their confidential data was released. And then you have public data that it's literally available to the public. You can go to their website and anybody can get access to it. So there's literally no consequence if it's leaked, because it was meant to be leaked. It was meant for people to view it publicly. So when you look at this series of information, these categories of information, you can consider their life cycle, the data life cycle. And in our world, in the modern world, companies use and store large amounts of data, including critical and sensitive data of their customers. And if that stuff is on the cloud, it needs to be managed through the life cycle to ensure secure usage in every phase. So these are the phases. You create the data, you store the data, you use the data, share the data if necessary, archive the data, or destroy the data. And it all leads, so in banking, for example, there's a 3-year life cycle or a 5-year life cycle for certain pieces of information. And then once that information has gone past that 5-year life cycle, it has to be destroyed. So it's created, it's stored, it's used whenever necessary, it's shared whenever necessary. Once it's done with this specific portion, it becomes archived for future reference. And then after a certain number of years, they just destroy it because it takes up space. And sometimes you don't need it anymore. It becomes outdated. So if it's outdated and it's not needed anymore, it has to get destroyed so it opens up space, but also it alleviates the liability. It removes liability from the company that is storing it, so that they don't have to worry about, it leaking or it getting accessed by people that shouldn't access it. So when you look at this life cycle, then you need to consider the security aspects in that life cycle. So each phase requires protection, and the life cycle stages, security considerations and requirements for all of those stages are individual, but there's a lot of overlap in all of these things. So when you create or update data, then you need to make sure that you implement SSL or TLS, which is essentially security algorithms or encryptions, we can call them. So secure communication through SSL and TLS, so that it's difficult for the attacker to listen while the data is being created or transferred between the customer and the cloud provider. And then you have the encryption, that the data should be encrypted so that if it's exposed for whatever reason, or if somebody can listen in, they can't just read the data, right? They would have to go through certain decryption methods to be able to read that data. And then finally, you have the secure connection between you and the cloud provider, so that the data transfer and the change of data is minimized, and there is no worry about somebody listening in on your communication with the cloud service provider while you are creating or updating your data sets. And then when the data is being stored, so based on its form, if it's structured data or unstructured data, and stored in a container generally known as some kind of a database, there needs to be encryption of that data and backups happening regularly. Backups can also be referred to as redundancies. So if you have encryption of data, which is fairly easy to understand, you encrypt it so that it can't just be accessed willy-nilly, and people would need to go through certain decryption processes to be able to get access to that. But then the backup is just another one of those things that if the data is lost for whatever reason, the server crashes, the warehouse burns down, there's an earthquake, there's a hurricane, anything, whatever happens, there needs to be backups. So redundancies and backups usually refer to, if there's a location in California of a server that you have your data on, you also want that same data to be stored in a location in Texas. And then you also want that data to be stored in a location in New York or something. So you have 3 different backups of that data. And if something hits the West Coast and hits California or hits Texas, at least you have your other locations that have backups of your data. And then regular scheduled backups, so that if there's any major updates to your data and the systems and all those things, the scheduled backups ensures that if anything does hit the fan, you don't have to go back and recreate a lot of the stuff that happened since your last backup. So it's all very, very important. And then you have the usage of the data. So if the data is encrypted, it has to be decrypted so that it can be used by some kind of an application. So the secure connection comes back into play. Notice how we had secure connection on the creation and updating of data. Now we're looking at secure connection so that we can have a good path of communication before the data is transferred or used, and the confidentiality and the integrity of the data is ensured. And then you have a secure platform that is using it. So an authentication mechanism needs to be used so that it can be protected from attacks and vulnerabilities. Restricting permission so that there's only a handful of people who can access it. And then once the owners of the data create and set strict permissions to be able to read, modify, delete the data based on their rule sets, and then anybody who's unauthorized shouldn't be able to do any of that stuff. They shouldn't be able to read it if they're not supposed to. They shouldn't be able to write to it or delete it if they're not supposed to. And then you have secure virtualization. The concept of virtualization in cloud computing, which stores among users, which resources among users are shared. So this is one of the concepts in virtualization. So the cloud provider needs to make sure that the customer's data is not visible to another customer's data, right? So if I want to virtualize my data, somebody else shouldn't be able to virtualize my data. It should only be available to me, which goes to restricting permissions, which goes to the security of the platform and the security of the connection, right? Then you have the sharing phase. So there needs to be a jurisdiction. There's a lot of regulation that is attached to this. Certain states have different regulatory requirements. Certain countries have different regulatory requirements. There's standard regulatory requirements that go all across the board with everybody, but each state, for example, in New York, has like strict rules for insurance companies, for example, or banking. And so their rules are much more strict than another state that doesn't get as much business, therefore doesn't get as much attackers, right? So if there's a lot of busyness that's going on inside of that state, it means it's going to be susceptible to more attackers. So they have to have more regulatory environments and restrictions to make sure that their jurisdiction is better protected. Then you have DLP, data loss prevention, which goes across the board with a lot of stuff as well. So data loss prevention helps to detect and prevent data breaches or unwanted destruction of sensitive data. That's really, really important. It just happens sometimes that randomly, if you don't have "are you sure you want to delete this" notification that pops up when somebody accidentally clicks delete, then all it takes is for somebody to misclick something, or their mouse pad is dirty, and so when they're trying to scroll to an area, it just jumps from this area to this area, and all of a sudden they clicked delete accidentally, and there was no notification to verify if they wanted to delete it, and now the data is deleted, right? That's crazy. Or if it gets deleted, it actually gets fully deleted, and it doesn't go into a trash bin, for example, or a recycle bin, and then it's actually completely deleted and it can't be recovered. All of that stuff is, it sounds silly, but it's very, very possible that it could happen. Then you have archiving. So encrypting the data so that once it's archived, it can't be decrypted easily. Physical security of the archive, right? Because typically archives mean that they're now going into some kind of a storage device, and so the storage server needs to be physically secured and prevented from unauthorized access through biometrics or cameras or guards or electric fences, something, whatever, like any kind of physical security. The location, which is the physical location where the data, the drives themselves are stored. And there's stuff like natural disasters and climate, too much humidity and mold can destroy certain things. So all of these things need to be considered when you're considering where you want to store your devices or store your storage. Store your storage. There you go. Backup procedure. So how will the data be recovered if something does happen? And how often do you need to have full or incremental backups to make sure that all of your stuff is current in the archives? And then you have the destroying of the data once there is no use for it and it can't be misused by anybody, or you don't need it for whatever reason, then you just get rid of it. Crypto shredding is a process which encrypted data is useless, and by destroying cryptographic keys, so without the keys, data cannot be decrypted. So if you just delete the cryptography that is securing those data sets, then you're technically destroying access to it. So this is all stuff that you would go through just to make sure that you're securing the various aspects of the cloud life cycle. And then you have security issues that happen in the cloud and the solutions for those things. So data confidentiality is a security issue. When data is inside the cloud, the privacy of that is at risk, and so the users have no physical access to that data. Once it's been stored into the cloud, they don't know what they have to worry about when it comes down to the confidentiality of the data. And so the cloud service provider can examine the data of the users without any kind of a detection, and that falls under confidentiality of data. The virtualization issue allows for the resources to be shared among users. So we need a mechanism to ensure that the isolation and secure communication between virtual machines is happening. And users aren't isolated in a multi-tenant environment, so one user can examine the data of another user. That's what that means. That's what virtualization means. So one user should be able to get access to their own data without another tenant being able to access their data while they're virtualizing the data. Then you have insecure interfaces and APIs. So cloud services are managed by customers with the help of software or APIs. You get access to the API of, Endpoint Manager in Azure or something, or Intune or something like that. Those are endpoints that you're using. So vulnerable software APIs can be risky, and data and customer confidentiality and integrity are at risk. So this is actually one of the big deals. Like if you're storing your data and you're running your business through a service provider that inherently is insecure, that means that the hacker, all they have to do is hack that service provider and they get access to your information and everybody else's information that's using that service provider, right? So they don't need to hack you, they just need to hack the service provider that is storing your information, and now they have access to everything. Then you have insiders who are malicious. So malicious insiders can cause data breach of other clients, taking advantage of shared technology vulnerabilities. These insiders can leak the data of other users, or exploit security weaknesses, thus causing security threats to the other customers on the cloud. So how many times, I literally just got one from AT&T earlier today, that they were like, or maybe it was yesterday, but it was sometime recently, where there was like, oh, there's been a breach in AT&T's information. It was posted on LinkedIn that AT&T's data, something across like 76 million users, their data was breached and leaked. And it's like, could that have a malicious insider, or could it have been an insecure interface and API of AT&T, right? Isn't that crazy? And then you have the account or service hijacking. So you can hijack a service or an account, and they include phishing, vulnerability exploitation, password reuse among users, dictionary attacks, brute force attacks. All those things can fall under hijacking. And then you have access control mechanisms, which is in a cloud computing environment. Users and cloud servers are not in the same domain. Enforcing efficient and reliable access to information is critical when the data is outsourced to the cloud. An unauthorized person can gain access to the data due to a lack of access control rights. And that all falls under access control mechanisms and whether or not they're secure or weak. So what is the first phase in the cloud data lifecycle? It would be to either create or update the data. And so then what we got to do in this case is we got to use this view site button at the top right here to go ahead and answer this last question, which reveals a flag for us. So this is what we got here. And it says, do you know about the sequence of steps in the cloud data lifecycle? And your task is to select the correct option for the highlighted steps. So we have 100 seconds. So it includes the newly created data and data that is being freshly imported from other data sources. This is called the creation. And then you have data is processed based on its form, unstructured or structured. That would be use. It's not use, so let's see. Stored. So that's what it is. Then we have encrypted data is decrypted in this stage for optimal usage. So that's probably use. Data is shared within or outside of the cloud infrastructure, and that is shared. Long-term storage of data and applications, that's probably store. Oh no, archive, excuse me. That's archive. And then undesired data is shredded or removed, and that is destroyed. And there we go. We got our flag right there. Copy that. And then we're going to paste that here. And there we go. So we got cloud security concepts done. So let's now jump into cloud security risks concerning deployment models. All right, each cloud security model or cloud deployment model, excuse me, each cloud deployment model has associated risks. So when you have private cloud, there's personal threats, natural disasters, external attacks, malware attacks. When you have public cloud, there's the vendor lock-in, conflict of interest, escalation of privileges, and then community cloud, vulnerabilities in policy administration. These are literally just a few of the vulnerabilities or associated risks that go along with these types of clouds, right? So you can go deeper into this because it all technically falls under the OWASP top 10 sets of rules. And if you haven't heard of this, we've done videos of this, and I literally look into this all the time. The last deployment of the OWASP top 10 was 2021. And so OWASP stands for my God, I can't believe I've forgot it already. It's the Open Web Application Security. Hold on, what does OWASP stand for? The Open Web Application Security Project. Yeah, oh, I was right. Okay, good. I was right. So it stands for the Open Web Application. So Web Application Security. So when you use a cloud service provider, you're using a web application technically. And when you're using a web application, there are security risks associated with that. And the last update of the OWASP top 10 list was this, right? So, and you can see from here each one's, if they went down in criticality or severity or if they went up. So 2017 was the update, and then 2021 was another update. And in 2017, for example, injection attacks were a really big deal. So they were the number one, and then they dropped down to number 3, and then sensitive data exposure ended up going to number 1, or no, excuse me, number 2, which goes under cryptographic failures. So sensitive data exposed means that it wasn't properly encrypted. And then you had broken access control went from number 5 to number 1, which means that the access control. So 94% of applications were tested for some form of broken access control, and common weakness enumerations, there are 34 of them mapped to broken access control, had more occurrences as application. And then you can just go Google that to see what that means. But there's a lot of actually like really good videos that's around this as well. But you could just literally do some Googling about these different these attack vectors or these different vulnerabilities to understand what web applications go through and how you need to secure your web applications. And a lot of companies will say that we operate based on the OWASP top 10, and you need to understand what that is. You need to know how to get access to this list. You need to know how to protect for it. And then there's a lot of open source stuff that's available, and then there's a lot of stuff that you can get from YouTube or just paid content, stuff like that. But if you just go through this stuff right here, how to prevent, examples of attack scenarios, references that are for the, if you just go through what's available on the OWASP website, you would be good. You would have a better understanding than most people of how to first, how to understand what the list is, how to, you know, measure a company's posture against the OWASP top 10, and then from there, how to remediate and protect against it. So that is what that is. So you have the cloud security risk concerning the different deployment models. And so you have the private cloud. So personnel threats, it includes unintentional and intentional threats from the personnel. So they don't have control over the providers, data center and administrators, and any insider can cause damage to the customer's data, either intentionally or unintentionally. So that's the personnel of the service provider. Then you have natural disasters, which is very basic to understand. Then you have external attacks, so such as unauthorized access, man-in-the-middle attacks, and distributed denial of service attacks that can compromise the user's data. So if we're the user and we're talking about the cloud service provider, somebody attacking the cloud service provider affects us, right? Then you have the public cloud. So the vendor lock-in means that the customer becomes a dependent service provider in the public cloud. It becomes nearly impossible for the customer to move the data out of the cloud infrastructure, the cloud infrastructure end at the end of their contract term. Thereby, the customer becomes the hostage of the provider, right? So if you're locked in with your vendor, and for whatever reason you're not current on your billing, or something happened with your vendor, and now they have all your data locked in and you can't get access to your data because of the fact that there was some kind of issue with you and your vendor, and now the customer, being us, become a hostage of the cloud service provider. Isn't that crazy? Then you have threat of new entrants. So the cloud provider may provide services to your competitor in the public cloud. And an escalation of privilege authorized. In the public cloud, users may try to acquire unauthorized permissions. A user who gains illicit administrative access can be able to gain control of devices that process other customers' data. And then you have the community cloud, which is vulnerability. Any node may have vulnerabilities which can cause intrusions on the other nodes. And in a community, cloud configuration management and baselines are almost impossible, meaning very difficult to enforce and very difficult to manage and notice. And then you have policy and administration to enforce decisions and procedures in the community cloud. It's very difficult, posing a severe challenge and a threat. So community clouds are essentially computing and storage infrastructures that are shared between a community or the members of an organization. So that's what that is. And public cloud we already discussed, and private cloud we already discussed. But a community cloud is kind of like a hybrid cloud, but not really. It's like shared between a community. And if you have a membership on the Hive project, for example, we discussed that in several videos ago. But a Hive infrastructure, the Hive project allows you to have a community around a certain case in cybersecurity that your company may be dealing with. And so that has its vulnerabilities, and enforcing policy and administration changes on those vulnerabilities can become challenging. So that's really basically the difference between these different clouds, and then the security risks that go to those clouds. So the answers, the questions here is, in which cloud model does the customer become the hostage of the cloud provider? And we talked about that over here, right here. So it's the public cloud, which allows it for the vendor lock-in situation. So it would be the public cloud model. And is it challenging to enforce specific decisions and procedures in the community cloud? And we already discussed that, and that is yay, or yeah. So there we go. We got that down. Now let's go to security through access management, which, if we went back and looked at the OWASP top 10, the first thing was broken access control. That was the first issue that was available in the OWASP top 10. That's the most recent one, broken access control right here. So security through access management. Let's talk about that. We discussed IAM, Identity and Access Management, in the first module of this pathway, of the security engineer pathway. So you can go and find that, the identity and access management video. You can just literally search through the channel contents for identity and access management, and you'll be able to find that video. But access management and IAM is becoming more and more important. I actually had an interview earlier on this week with a very large company. I'm not going to disclose the name of the company, but it's a global company, very, very large company. And one of the big things that they were concerned with was my ability to understand access management, identity and access management. So you're probably going to run across that as well. So what it means is that the right people should do the right job within the right set of permissions. That's what identity and access management stands for, or what it means, right? So you create identities. So the cloud infrastructure creates digital identities that can relate to a person, a user, API, or service, and the entity is a set of properties that can be recorded, right? Then you have authentication factors. So each identity is allocated with a specific set of characteristics unique to that particular identity and helps to distinguish it from other identities. So if those things are matched, if the identity and the authentication factor are matched, then the essence of that user is confirmed. And so the authentication factors could be their username and password, or their username and PIN, the biometric fingerprint or a scan of their face, or a certificate that is attached to their session, the Face ID I already mentioned. So there's a lot of different factors that you can have to authenticate yourself. So you have an identity, the identity needs to be authenticated, and then you have roles, right? So each identity has a specific role which defines the domain, under which that particular identity functions. So that role gets access to certain services inside of a certain domain, and they are allowed to do those things according to that role. And every time that that person wants to go and access those services, they have to provide their identity, authenticate themselves, and then they go and get access to the services assigned to their role. So a bank teller has a different role and different permissions than the bank manager, and they should get access to different things according to their roles. And it's basic to understand. It's very, very basic to understand. It's just really freaking important to understand, and really important to have security around these concepts. So who can access what? That's identity access management. Really, really basic. And I love this. This is very, very simple. Who can access what? That's it. Who falls under user, the identity, can access management. What are they going to access? So in Amazon, access management is implemented through identity and access management. IAM is considered the heart of access management services to configure and perform fine-grained control and access policies to AWS resources. It's a web service that enables Amazon users to grant access to various services and resources to different users. Features of IAM. So give rights and permissions of resources in your Amazon account to other people without sharing passwords. Grant role-based access to users based on their access rights. Enable multi-factor authentication. Enable and manage permissions and access policies across Amazon accounts and resources. And this is not just limited to Amazon, by the way. It goes across the board with everybody, every service provider. It's just that Amazon is the example in this case. You have some important terminologies in this case. Resources are the object within a particular service. They include the users, the roles, groups, and policies. All of these things fall under resources. These are all resources. Identities represent certain users permitted and authorized to perform specific roles and actions. Entities are the subset of resources which are used for authentication purposes. It includes the users and their roles. They're all considered entities. And principals are a person or application requesting to use Amazon resources after signing in. So these are IAM terminology specific to Amazon. Okay, Azure can have different labels for these things, but they typically represent the same description. So their label might be different, but it represents the same description. Using the cloud environment. So we're going to be using examples from AWS through this room. Although the room can be completed with the provided text and image content, the practical exercises require an AWS account. Having an AWS account is optional for this room, but if you're interested, you can visit this URL to understand how to create and activate a new AWS account. So let's go over here, and for the hell of it, I might actually just create one just for the purpose of this thing. We'll see if they said that we can probably answer the questions through just the text, but I would recommend that you just go, because it's free. You can set up the AWS account for free so that you can go around and click around and see what's going on. But it's important to, at the very least, read through the text and watch this video, etc., etc. But I think it's useful to go create an AWS account just so you can understand what's going on. So create an IAM user account with administrative privileges in the account. IAM users with administrative privileges will have complete access to AWS resources. Moreover, it can grant permissions to other users. So you log in by going to console.aws.com, navigating IAM, go to the users and navigation pane, click add users, which is IAM, users, add users, enter the new username, assign the access to the AWS Management Console, which is what you want them to have access to, so that they can actually be an admin, so to speak. And then you go to next, and then you go to permissions, and then you add them to a group, and then you got to create a group if you don't already have one, which in this case, if you're creating a new account, you won't already have one, so you got to create a group. And then you're going to do administrator access for the group itself, which is a permission policy. So it's a group policy that's already been established. So once you have the group name, you do administrator access as a policy name, which gives them full access to everything. And then you create the group and then review to go through the settings. And if everything's all good, you do create user, and your user has been created. And then you can save the details for that user as such. So are Face ID and biometric types of authentication factors? Yes, they are. And then we've completed the practical exercise. I guess I should do this. So I'm going to do it just for the hell of it, just so we can kind of follow along with this whole thing. Okay, I did not create an account with AWS because it requires that you put a credit card as your initial sign up. And I honestly, out of pure laziness, did not do it because I didn't feel like going to the other room and grabbing my wallet and taking my credit card out of it. So I didn't finish setting it up, but I think we should be able to just learn from what we got over here with the information on the screen. We should be able to kind of pull through. But just to give you more experience with it, I think you should go create one. I do have an Amazon AWS account. It's under my actual name, and I didn't want to log into that account, and I was trying to create a new one under Hank Hackerson, and that's where I kind of ran across the thing. So I do have an AWS account, and I know how to navigate it, and I just do recommend that you go ahead and do it for yourself. Do as I say, don't do as I do in this particular case, because I'm super lazy right now, so I apologize for that. Okay, so let's jump into security through policies. Policies are a set of guidelines and controls which attach to identities, which are roles, and make permissions for those identities and those roles. The cloud infrastructure evaluates the permissions defined in the policy to determine whether the request should be allowed or denied whenever an identity requests any service. In a typical environment, these basically following types of policies. So you have an identity-based policy based on a specific person and the permissions that they're allowed to have. You have a resource-based policy based on what they're trying to access. And then you have a session-based policy. So their identity could be also the role of the person. The resource could be based on the data or the services that they're trying to access. And then a session is temporary policies for specific resources for a particular amount of time. So security policies through AWS, they are by the AWS IAM, and you just go to policies. So you click on IAM, click on open policies, and then it'll just bring you to the wizard for creating a policy if you don't already have one. You click on create policy, and then you have either the visual editor or a JSON version. And if you don't know JSON, then you use the visual editor to do so. And then you just choose a service that you want to attach your policy to. So this is what it looks like, right? So you choose a service, and then from RDS, in this particular case is the service, you want to specify kind of action that they could do. So you're going to do all RDS services, and then the resources that are attached to that, and all resources that are attached to that. And then the conditions, so multi-factor authentication required, or a source IP that should be able to use it. And then you click next, and then you assign a name to your policy. And from there, you can assign even a description to the policy, the summary that goes attached to it, any kind of key or a value that would be attached to it, and then you can just create your policy. And once it's been created, it'll show up on your policy list, like here, you see right here. And then from there, you can just go create another one, for example. So this GIF is basically going to repeat itself, but very, very simple to do. So what we did was used RDS and denied all the permissions, and we can attach the policy with an identity so the user cannot access the RDS service. The primary idea is to have granular level of access control through policies to restrict or enable access to a specific resource. In a cloud environment, can we create a policy to enable database access for a user at a specific time of the day? And that is called yes. And that is a session-based control, as we talked at the top right here. So session-based policies. We have completed the practical exercise. So I'm going to say yes, but I did not do that because I was too lazy to create my AWS account for this session. But yeah, you kind of see what it's like, right? So don't do as I do as I say in this case. All right, moving on to security through network management. Cloud computing is different from the on-premises model of computing, wherein including physical firewalls and protect on-premises deployments, all those things are a little bit different since you're using a cloud service provider, and then the physical protection is done through the actual service provider themselves. So network security of cloud infrastructure is maintained through a layered approach, and we have the 3 layers here. The network security through security groups, which is the most fundamental aspect of network security, and it basically is the allowed rules or allow rules that allow specific traffic to get access to resources. Contrary to traditional firewalls, security groups do not have deny rules. The absence of any allow rule against a particular traffic means that it's denied. So you basically explicitly allow something, and if you don't want it to be allowed, you just don't check the allow button, right? So we can say security groups operate on the principle of deny all unless allowed explicitly. Then you have layer 2, which is network security through network access control lists. And the concept of NACL is related to protecting the virtual private cloud, and they are used to create rules to protect specific instances of the private cloud. And network access control lists are different from security groups in the fact that NACLs contain deny rules as well, and we can make a rule to block a particular IP address from accessing the virtual private cloud. Then you have the layer 3, which is the vendor-specific security solutions. So service providers are also well aware of the inherent weaknesses and cyber attacks that can target their infrastructure, so they have deployed their specific security solutions. And these vary from vendor to vendor, meaning AWS has different rules, and for example, DNS firewall and network firewall, both. So network security in AWS falls under several components, which is the security group, the network access control list, the DNS firewall, and the network firewall. So what we can do in this particular case is when you go to AWS account and you navigate to the VPC in the services menu, which is on the left-hand side, or you can just search for VPC in the search bar at the top. It'll open up the virtual private cloud for you, and then you get your set of options for that. And so under security, you have network access control list. So NACL, network access control list. And when you click on it, you do create a network access control list. And then you go through the wizard, basically, right? So you give it a name, then you can attach any virtual private cloud to be used for that access control list. You have any tags that you want to attach to it. And then you have your inbound rules, your outbound rules, and any associations with the subnets. And if you don't know what subnets are, I do recommend you go look into that. I think we have a video on subnets. I don't know. I don't think it's like a deep dive on subnets, but it's fairly easy to understand. It kind of seems complicated, but I would recommend you just kind of understand it. Network Chuck has a really good video on subnetting, so you should go check that out if you haven't already. Then you select new ACL and click on the inbound rules, and you create a new rule. So under inbound rules, you can edit inbound rules, and then when you edit the inbound rules, you can essentially start editing it. Very, very simple. So rule number 1 on port 22, which is secure shell, which is a TCP port, and you say that the source address from any port essentially, or any IP essentially, is denied, right? That's the specific rule. So it denies all the traffic at port 22. And you can allow list or block list specific IPs for connecting to port 22 when you add more rules, right? So you can just add another rule on the same port, and then you say the source IP address is the specific IP address that you have, and then you just do allow for that. So it denies everything with the exception of that one IP that has an allow permission. The question is it a good practice to operate security groups on the principle of deny all unless allowed explicitly? And I'm going to say yay for that. And that is it for this particular section. So now what we can do is go into security through storage management. Storage security in a cloud environment ensures that the data must remain safe while at rest, meaning it's not being used, and in transit during the various phases of the data lifecycle. You could create geographical boundaries, which is the regions that can access it, and then set policies permitting data access or denying data access. You can set role-based authorization, which is the identities and their roles that can access a particular data set per their specific rights and privileges. And then you have the encryption of the data. So all cloud service providers allow data encryption at rest. You should do that. you should definitely do that. With this approach, server-side encryption is applied to the data, meaning while it's inside the server and it's at rest and it's not being used, it's encrypted. Some important things to understand here is connection strings with the database containing a hostname, username, and password must be used using secure methods, right? So encryption, basically. Access security policies, data encryption standards, and physical security measures by the cloud service provider. All these things are very, very important to understand when you're talking about storing data. And then in AWS specifically, we can look at a lot of different types of repositories to store the data. You have the relational database services, simple storage services, Redis, and a lot of other things. And data security is ensured by applying various policies to database instances per the data sensitivity, right? So how sensitive the data is, if it's confidential, or if it's hybrid, or if it's just meant to be internal, all of those things. So if you go to AWS and navigate to S3, which is basically, it can be searched for inside of the search menu at the top. You just type in S3 or simple storage service. That's what S3 stands for. You will find the S3 service, and then from there, you click on create a bucket and enter the basic information such as the bucket name, the region, which means the physical region that you want it to be stored at. And the bucket name must be globally unique, meaning that no other people can't have access to that bucket name. So you just need to create a bucket name specifically for you. And it could just be the name of your business dash the name of the bucket, meaning what kind of data is being stored in it, dash the location that you want it to be at. And that usually is unique enough. And then you can just create your bucket. And so default encryption, encryption type would be the managed keys, which is the basic default encryption, or it could be a key management service by them. And then the bucket key is enabled. You just want to make sure that you enable your bucket key so that it encrypts your data bucket. And then enable server-side encryption and select encryption key type. For the demo, we've used the S3 magic keys. And then you create the bucket and you have your first S3 bucket. The encryption of data at rest is unnecessary. If we carry out encryption at transit, that is not the case. You need to encrypt your data. And so just so you know, when you do this, an S3 bucket has cost associated with it. And I want to say that network access control lists don't, but I do know for a fact that when you create a database, an S3 bucket, there is a cost associated with it. So if you are actually doing this in real time and you're going to create these things for yourself, make sure if you're not going to use them and if you're just doing it for practice, to delete all of these things at the end of this video so that you don't get charged for them, especially if you're literally just doing it just for the hell of the exercise and just for going through the motions and going through the process. So finally, let us jump into cloud security and just some additional concepts around cloud security. There's a concept in data recovery that is called disaster recovery and backups that are associated with disaster recovery. And cloud disaster recovery is a terminology that became really famous as clouds became really famous and really popular. So it's a combination of approaches, tools, and techniques that ensures to back up the data just in case there's a disaster so that you can recover that data or any of the resources or applications that were used through your virtualized machines and your instances. So to ensure regular continuity of business operations is why we do this. And the essential concepts are as follows. So you have cold DR, cold disaster recovery, which is the most straightforward approach and inexpensive, but it has the largest recovery time objective, meaning to get back to business operations, it takes the longest time if you just use cold data recovery. And it basically stores data and saves images, and these are disk images or snapshots of the machines that you have, so that basically whatever software you had that was installed, you would just virtualize that software, reinitialize that operating system with all of the softwares and everything already installed on it. That's what a disk image is. And all snapshots must be recovered to resume business operation in a disaster situation, right? So if a computer crashes and it has a bunch of things installed on it and a bunch of data in there, you need to be able to retrieve that virtual machine. You need to be able to retrieve that computer with all of the data as well as all the software and everything that was installed on it. Then you have the warm disaster recovery, and it's the near real-time synchronization of the actual data and applications with disaster sites. So a copy of all the data and services is being maintained at the data disaster recovery setup, hosted on a cloud environment, and it's just being kept as a backup to resume business operations in case there's something going on. And when a disaster occurs, the disaster recovery site is configured to resume operations, and in this case, it's the time required for configuring the disaster recovery site to become operational. And then you have hot disaster recovery, which is practically zero recovery time objective, and it's the most expensive. So in this approach, the actual disaster recovery sites works in parallel and shares the workload through load balancers. In case of disaster, all work is shifted to the so a company that has a lot of need for their operations and their services to be up all the time would do something like this. But if you're just running a personal website, it's probably not necessary for you to do this, and you can just do cold disaster recovery. Then you have security through monitoring and logging. So there's real-time logging, which all service providers monitor and log all identities and resources. Then you have monitoring and logging of API calls, which has the instances have provision for recording API calls made to the infrastructure. So a GET request or a POST request, all those things. And the logs include the source IP address of the user or the service and the time and their geolocation, etc., etc. And then credential reports, which is another essential thing that that cloud service providers monitor, and user account logs. Common log factors include the user account, the last used date, and the password last changed, password last used, all that stuff that have to do with the credentials, the actual users themselves. Then you have monitoring and logging into AWS specifically, so IAM, Identity and Access Management, basic logging features related to access management, logs and credential reports of user accounts. Then you have CloudTrail, which logs all the API calls made to the AWS resources, CloudWatch, which monitors the entire cloud infrastructure and informs about application status performance changes, ensuring better resource utilization, and Guard Duty, which ensures continuous monitoring of any malicious activity and unauthorized behavior. So if we wanted to do this practically, we would need to go back to IAM and go into the console, navigate to IAM. In the navigation pane, you then go into Access Reports, and under that you have the credential report, and then you can download your credential report on the next page, and it gives you an Excel sheet. And then from there you get the root user, their specific username and the networks that they're assigned to, the user creation time, the user update time, a lot of that stuff. The report is going to be downloaded in CSV format, and it use password last used, password last changed, user creation time, stuff like that. Updates and patching. There's something called patch management in AWS, and you can have automated and scheduled patch management. Patch management in AWS is managed by Systems Manager, and it has the following concepts. It ensures automatic and scheduled updating of cloud resources and to update operating systems and their applications. Provides scanning option to scan complete infrastructure regarding the missing patches. And if you wanted to access that, you would go to the System Manager in AWS, and from there you would open Patch Manager, which is going to be in your left-hand side menu, and that's going to be under Node Management. So you go to System Manager, on the left side menu you go into Node Management, and when you do the drop down, you get to go to Patch Manager, and then when you open up Patch Manager, it brings you to the Create Patch Policy wizard. And then you can have a patch without a schedule or scheduled patching. So you create the name for it. You can do scan or just scan and install. And recommended defaults, it can scan your nodes daily at this time, or you can create your own scan schedule. And then that's basically it. And then it'll just scan your services for any updates that might be necessary. And then you could either just get an update for what needs to be installed, or you can just do scan and install, and then they'll do the updates for you automatically. So question here is it a good practice to keep disaster recovery backups for a server in the same vicinity or data center? Is it to keep disaster? I would say nay. Yeah, that is the answer. So there it is. We are now officially complete with our room here. So that was it for our cloud security introduction. And as a quick little conclusion, this is what we went through: security through access management, through policies, networking, and storage management, and things like logging, disaster recovery and backup, and updates, and all those things. So this is a really, really big topic. So cloud security in general, cloud computing in general is a really big topic, and companies hire people specifically for cloud management, and then it even falls into different subcategories of that. So they'll have different departments under their cloud management. They'll have different, and that includes cloud security, right? So all of these things are really, really important for you to understand, especially if you want to go into security engineering and cybersecurity, stuff like that. If you got any value from this video, or if you want to be updated on the new content that comes out through this channel, I do recommend that you like, subscribe, and turn on the notification bell so that you get notified the next time that we drop something, and that includes everything that comes through the security engineer pathway, which we are currently on right now. So the next thing that we're going to be doing is the cloud monitoring, or not, excuse me, the auditing and monitoring room, which is going to be the very last piece of the network and system security module. And then we're going to go into software security. That, look at that, it is going to be OWASP top 10 as the very first room that we're going to do there. So I would very much love for you to actually join our community and come through the comment section and check all these things out, and I think you'll get a lot of value from it. So make sure you like, subscribe, and turn on the notification bell. And yeah, that's pretty much it for that one. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next room. Later. What is auditing and what is monitoring? And how can logging help you with doing proper auditing and monitoring? And what is something called a SIM, a Security Information and Event Manager? And how are all these things going to help you become a better security engineer? And these are some of the questions that we're going to be answering in today's video, which is on auditing and monitoring, which is a part of the network and system security module of the security engineer pathway of TryHackMe. My name is Hank Hackerson, and to learn more about cybersecurity, ethical hacking, pen testing, or to get more videos like this one, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And you will honestly get access to a lot of good stuff. I've gotten a lot of great feedback from this channel so far, and we are just going to keep going forward. So I would love to see you in the comments section and in a part of our community. Now, without further ado, let's jump into the actual introduction of the auditing and monitoring room. All right, to get a good idea of the importance of auditing and monitoring, we're going to look at an example to start everything off. So imagine that there's a prestigious hospital in the United Kingdom, and they have to ensure that it aligns with all of the regulations. So the hospital needs to align with all of the regulations for the medical industry, the medical field. You're part of the team that's responsible for ensuring compliance with the Data Protection Act. One of the requirements is to ensure that patients' records are kept confidential and protected against unauthorized processing, access, loss, destruction, etc. So the management provided the staff with substantial relevant training to raise awareness and equip them with all the necessary tools to ensure compliance. Now, does this mean that the hospital is now in compliance with the requirements of the Data Protection Act, especially when handling patient records? Policy violations come in a lot of various forms. So the staff might copy patient-related data using a USB flash drive for easy access. Others might dispose of confidential paper records without using the allocated paper shredders. Some might take photos of the computer screen to share it with via unauthorized channels to make work more efficient. These are just some examples, and there's a lot more, which are considered workarounds, and how those workarounds might lead to violations of the laws that apply to that specific industry, which then can lead to lawsuits against the hospital. And so as a security engineer, you have to ensure that everybody's doing their best to observe all of the laws and the regulations to the best of their abilities. There's still going to be some bad apples in the bunch, but you got to just make sure that you do what you can do to make sure that all the compliance and regulations are met. So what we need is some systematic and objective ways to evaluate the hospital's standing, which means we got to audit them. And we have to regularly audit them, the processes that they go through, the controls that they have, to ensure that the hospital abides by all the regulated or the related regulations and laws. Without auditing, there's no way to know what needs to be fixed. So there's another way to say this, is that when we ask questions like, how can we know whether a company complies with the applicable laws and industry standards? How can we assess the effectiveness of the risk management and internal controls? How can we detect fraudulent activities or misuse of resources? And all of that is answered by auditing. So in simplest terms, auditing is like a checkup for a company or organization, right? So you've probably heard of an audit before, and auditing is just somebody. Typically, there's an auditor, and we'll talk about that in a little bit. But the auditor comes and audits the company to just do a check on to see where they're standing with their regulations, with their processes, their controls, their systems, and everything to make sure that it actually is compliant, right? So you examine the company's processes, their internal controls, financial statements, and everything else to see that they're running smoothly according to policies and laws. Auditors look for problems, which are either errors or inefficiencies or shady activities, and they suggest ways to fix them. And it helps improve the company and its operations, and it builds trust with the people that are involved or affected by the organization's activities. Auditors usually are hated by people, especially the people inside of the organization. That like everybody's terrified by an auditor, and I mean it's for good reason. Especially if you're a slacker and you don't follow compliance. But if you're compliant and if you follow the regulations and the rules, then auditors will love you and they give you your little star for doing good on your audit. And when you pass your audit, everybody loves you and you get more funding and you get recognition and people want to do more business with you. So this is the systematic or the formal definition of it, which I don't think is necessary. If you want to pause it to read it, you're more than welcome to. But as long as you just understand that it's essentially a test that a company goes under to make sure that they're compliant and they're following regulations. Then there's monitoring. So monitoring is a continuous process that helps you prepare for auditing. So before we move on, we're going to find out what that means. In information systems, monitoring is about continually, right? So it's continuous, continually, ongoing. Those are the phrases that are attached to monitoring. So continually checking a computer or network's performance and behavior, watching over various components like applications, storage, networking to make sure that everything's working well together. And it also looks for unusual behavior and checks if everything or anything violates established rules. So what we're going to do in this room is we're going to go over auditing and monitoring so that we can understand how it works, and then visit some related concepts like logs and logging. And we've talked about this previously in previous videos, but we've looked at them as a security analyst perspective. And right now you're looking at this entire concept as a security engineer. So there is some nuanced differences, so we're going to go through that as well. You need to have a good understanding of Microsoft Windows if you're going to go through this room. You need to understand Linux. And of course, IAA, which stands for, oh, it opened up an entire different room. IAA is for Identity and Access Management. And there's the IAA model, which is identification, authentication, authorization, and accountability. And then risk management and all the concepts that are related to that entire process. They're not necessary, but it's good to know these things. So if you haven't gone through the identity and access management video, I would recommend you go through that as well. And I mean, you should have an understanding of Windows and Linux, depending on what type of system you're using. If you have Mac OS, it's Unix, which is kind of a version of Linux. So the command line is similar, and a lot of the stuff that happens are similar, except Linux in its raw form is just a command line interface. So it's just good to understand how that works. So first questions here we got, what do you call the systematic review of an organization's technological infrastructure, policies, and operations? And that is auditing. And then what's the continuous observation of the organization computer technologies is monitoring. So that is our intro for the auditing and monitoring room. So let's jump into audit objectives and types. In financial services, auditing is an official inspection and verification of an organization's financial records, procedures, statements to ensure accuracy, reliability, compliance with applicable laws, regulations, accounting standards. So you need to verify the financial records of individuals and businesses. I used to work in banking, and we would get audited multiple times a year. Mainly because of the fact that it's a very, very sensitive business. You're dealing with people's money, and based on the jurisdiction that you're in, a lot of those things there's a lot of sophisticated details on a lot of regulations to follow. So there's the BSA, Bank Secrecy Act, there's Graham-Leach-Bliley, there's Sarbanes-Oxley. There's a lot of stuff that you gotta follow to be compliant in the banking industry. So when it comes to information systems, there's a broader meaning for auditing, and it goes beyond financial records and procedures because it's a very big world. Information technology and information systems are gigantic. So auditing information systems involves systematic, independent, and objective examinations of the organization's IT infrastructure, processes, and controls. So there's a lot of different objectives that goes through this. So there's the effectiveness, the security, and compliance of the systems. And when you do an information system audit, auditors can assess various aspects of the IT infrastructure, processes, and controls. So this is our auditor right here, this freaking guy right here. This guy decides whether or not you stay in business. That's basically what an auditor is. The objectives of an audit are multiple folds. So you have the assessing of the effectiveness of the internal controls. So how effective are your internal controls? It can mitigate fraud, errors, and any other disruption to the operations. Then you have identifying and assessing risks. So develop and implement appropriate controls to mitigate risks. Then you have assessing the efficiency and effectiveness of the systems. So improve the performance of the information systems and make decisions about future investments in information technology. And ensuring compliance with laws and regulations. So that part it's kind of a given. And if you don't follow laws and regulations, you're going to go out of business. You're going to get fined. You're going to get sent to jail. There's a lot of stuff that can happen if you don't follow laws. So this is kind of just an overview of this, right? So risk assessment, compliance, IT governance, security management, continuity, fraud detection, and disaster recovery. So these are the goals that we are trying to accomplish when we go through an audit or when we're trying to be prepared for an audit. So risk assessment, potential risks and vulnerabilities need to be assessed and identified. Complying with regulation environments. So HIPAA is for the health industry. Bank Secrecy Act is for the banking industry. So there's a lot of different rules for or different compliance regulations for different businesses. PCI DSS is for anybody who collects payment card information. And then there's IT governance, so evaluating the effectiveness of IT governance practices, including decision-making processes, resource allocation, etc. Security management, the effectiveness of the organization's security policy, processes, and controls in protecting information assets. Operational and performance evaluation, to make sure that your performance and the operations, the way that the business runs, are up to par. So the system design, development, implementation, maintenance, all that stuff. Data management and quality, to make sure that the data is stored properly. We talked about encryption and all those things in the cloud security room. So data storage, retention, backup, recovery, and even destruction of data. That's all that falls under data management. Business continuity and disaster recovery. So if shit hits the fan and there's a hurricane or something, there needs to be disaster recovery plans put in place so that the business does not stop running. That's what it means for a business to have continuity. The business continues running. That's basically what that is. And of course, fraud detection and prevention. So fraudulent activities, if somebody's trying to defraud you, if somebody in your organization is trying to defraud the government, or identity theft, any of those things fall under fraud. And you got to be able to detect those things and prevent those things from happening. So the audit, again, all of this is being looked at by the audit. When somebody audits your company, these are the things that they're looking at to make sure that your company is solid. And if we were talking about information systems, we're auditing the information systems to make sure that all of these things are solid, right? So you have different types of audits. We have internal audits that are run by the organization's personnel, which should happen all the time. You have external audits that are done by an independent auditor or basically a third party. from external accounting or auditing firms, and the primary purpose is to provide an impartial and objective review. And then you have something called a third-party audit. Well, I guess so. An external audit is different from a third-party audit. So I guess I kind of miscategorized those things. We started with an internal audit to start, and then we would pay for an external audit to help discover what we may have missed based on our current biases or maybe lack of expertise with our current team. If you don't start with an internal audit, you're more likely going to need multiple external audits, which ends up becoming really expensive. And then you have the third party audit when an organization needs to assess the IT systems within third parties, such as vendors, service providers, so on and so forth. So you're looking at the third parties that you do business with, and you audit those people and those organizations. So it's not that a third party is auditing you. That's what I was kind of connecting external audits to. It's the fact that you're auditing the third party that you are doing business with. So your vendors, for example, or your subcontractors or service providers, stuff like that. So which type of audit is conducted by an independent auditor? And that is an external audit. And what's conducted by the personnel of the company? That would be an internal audit. So very, very simple, easy answers. And I feel like most of this is going to be, oh no, you know what? We actually have a couple of machines that we're going to work with. So there's going to be a lot of read stuff, and then we're going to do a couple of exercises with the machines that we have. So let's go into audit frameworks here. In an attempt to keep this simple, I am not going to read all of this information here, but it is important for you to at least have an understanding of what all of these different frameworks are, which means I would recommend that you pause the screen and pause the video and just read through this. I'm going to make sure to center it for you so you have access to all these things. And so there's COSO, the Committee of Sponsoring Organizations of the Treadway Commission. Then you have COBIT, the Control Objectives for Information and Related Technology. ISA 3402, so International Standard, and then ISO 27001. This is actually really common. A lot of companies want to follow along with this one. It's the International Standard for Information Security Management. Set of best practices. That one, it's so common. You're going to run across this all the time. You're also going to run across this, which is the IT Infrastructure Library, which is a framework of best practices for service management, so IT service management. And you're going to run across that a lot. And then you have PCI DSS, which I mentioned a little bit earlier, which is about the payment card industry standard, that if you have, if you collect payment card information in any way, you have to adhere to the compliance and the regulatory environment for PCI. And then we have SOX, the Sarbanes-Oxley Act, which we also talked about a little bit as well. And it's the auditing and financial reporting requirements for public companies. So SOX, Sarbanes-Oxley, has to do with auditing. So it's the regulation for auditing and reporting requirements. So it's very, very important that you understand just what these basic things are. And this is the kind of like a description of it, the industry that it applies to, and then just some notes that are attached to it. And I want to say this is not a free room. So you would need a membership, a paid membership with TryHackMe to get access to this. But if you just Google any of these names, you'll be able to pull up way more information than what's on the screen, and you'll get really good detailed information about those things. So I do recommend that you actually look into this. I am skimming over it because it's a lot to read, and I want to get to some of the more important stuff. But these are just audit frameworks, and this is not all intensive. HIPAA is not included in here. High-Tech Omnibus is not included in here. Graham-Leach-Bliley is not included. There are so many freaking audit frameworks. So just depending on the industry that you're in, you can do audit frameworks for such and such industry, and then read up on what is required for that industry. So a standard used by organizations that process card payments is PCI DSS. Who developed ITIL? So I actually Googled this, and I will do a search for you as well, just so you can see this. So it's been developed by the British Government Central Computer and Telecommunications Agency, which is CCTA, during the 80s. So that's that. And then who developed COBIT? And again, we just Google that. And just like that, you have this ISACA, uh, Control Objectives and Information and Related Technology by the Information Systems Audit and Control Association. And that is the creator of COBIT. But then you can Google any of the other ones, and then you'll find out who created those. And now moving on to auditing IT infrastructure and operations. All right, here is the audit process. Look at all this fun. So you want to plan for the audit. So the auditor determines the scope of the audit, the objectives, the timelines, and you need to understand the environment of the information technology, including infrastructure, system, application, security measures, yada, yada, yada. So you got to plan for it. And then you gather information for it. So collecting relevant data, background information, documentation, all that stuff. Then you assess risks and control evaluation. So risk assessment and control evaluation, which is the identifying and assessing the risks and vulnerabilities within the organization's infrastructure, processes, systems, based on the information that was gathered here, and evaluating the effectiveness of the internal control, security measures, so on and so forth. Then you test the environment. So detailed tests on selected systems, applications, specific processes, all that. And this could potentially be a penetration test. A penetration test is technically an audit of the security of your system, right? So this testing methods include data analysis, vulnerability scanning, penetration testing, control testing, sampling. All of that falls under the auditing general category, like the general concept of auditing. Penetration testing is actually one of those things. So when you go into penetration testing, you're technically auditing systems. Then we have the analysis and the findings. So whatever you find through your testing process, you want to analyze those things and get some kind of documentation, some kind of debrief or report for any deviations, irregularities, vulnerabilities, all those things. And to just make sure if the system is actually secure and if they're compliant or if there's anything that needs to be mitigated and addressed. And then you create the report based on your analysis and your findings. And it needs to be detailed, and you got to present the report to the C-suite executives most likely, and upper management, and all of the stakeholders and all the people involved in those departments that need to be applying the mitigations and everything that goes into that. And then you do a follow-up. In some cases, the follow-up is done and recommended improvements and corrective actions to make sure that they've actually done those things to mitigate and fix all the issues that were identified. And this is a continuous process. This is not something that happens once. This whole thing is continuous, hence the monitoring phrase that goes in here. So you have an audit process, but you do audits all the time. It's not a one-time thing. So the areas that you want to audit, especially for information systems, are the hardware. Then you have the operating system. Then you have the file system, the database management system, the infrastructure of the network, the operation controls of the network. Then you have IT operations. Then you have light out operations. So lights out operations to ensure that the effectively managing IT infrastructure without the need for human intervention. Problem management operations, monitoring operations, procurement to ensure that IT hardware and software are secure and compliant, business continuity planning, disaster recovery planning. These are the areas of an information system audit, okay? This is specific to information systems. Keep this in mind, because audit areas are going to be very different based on the industry that you're in. Now, depending on the industry that you're in, you're going to deal with the regulations of that specific industry as well as information system auditing. So you're doing both in a lot of cases. And you may not necessarily have to worry about all of the HR related audits or the kind of like the minutia that goes into administration. But it's good for you to understand that those are the things that are going to be looked at by various auditors during the audit process, so that you just are more well informed and you know what the hell is going on. So let's look at a scenario here. And is there a virtual machine that I gotta launch? I don't think so. I don't think there's a machine attached to this. No. All right, so we just have a sample scenario here. So the planning is going to be, this is for COBIT. So if you want to go and do an audit based on the COBIT compliance, it's the acronym for Control Objectives for Information and Related Technologies. So that's what we're looking at here. So in the planning phase, we want to define the scope of the audit. So what we're going to be doing the audit against, so the domains and the IT governance practices, then identify the relevant COVID controls, whatever is in place to mitigate the risk identified in the scope of the audit, develop the audit plan, and get ready to actually execute your plan. COVID-19 framework defines 40 control objectives, which are grouped into 5 domains: plan and organize, acquire, implement, deliver and support, monitor and evaluate, and resilience. This is just the COVID-19 framework for the control object. That's nuts. And then we have execution as our step 2. So you want to gather evidence of the organization's compliance with the relevant controls, and it could include documentation, interviews with staff, observations. Then you assess your evidence and determine whether the organization complies with the relevant COVID controls. And then the assessment identifies gaps in compliance, which could be basically a gap in compliance. Make recommendations for improvement based on the gaps in compliance if you find anything, if there are areas of improvement. Then you start creating your report. So prepare your audit report, summarize the findings and making recommendations, and then communicate it to the stakeholders and management. And then you have follow-up. So monitor the implementation of recommendations to make sure that if there was anything that did come up, they actually did it and they went through with the mitigations and remediations. So this is it. And so what we're going to do in these questions is consider the case where we divide the audit process into the following 5 stages, and then we're just going to answer based on the number associated with these things. So which step do we present our findings about non-conformities, weaknesses, and issues noted? And that would be in the step number 4, which is reporting. At which stage does an organization review the steps based on recommendations for proper and satisfactory implementation? And that would be the assessment. Oh, it's not assessment. So does the organization review the steps on the recommendations for proper and satisfactory implementation? All right, so if it's not the assessment, then it is the follow-up stage where the organization does a review based on the recommendations. And then at which stage do auditors establish the audit scope and define the objectives? And that would be inside of the planning stage. So there we go. We got our answers for our little audit infrastructure operations. So let's look at logs. Super fun. Let's look at logs. This one is really straight to the point. So logs is the process of recording events as they take place, and it's usually done automatically. Auditors create their own logs, however, and then they also probably review logs as well. Pen testers create logs, review logs, so on and so forth. So there's a lot of different layers to logging. There's compliance, auditing, troubleshooting, monitoring. There's security logs. There's authentication logs. There's connection logs. Now, there are so many different freaking levels to logging. So in the purpose of auditing, and the usage of logging is to be able to troubleshoot areas for errors. So if a server fails to start, we will look at the log to try to figure out where it failed and why it failed. The monitoring log, so providing plenty of insights to the utilization of the system resources. If a server is slow, we want to discover the bottleneck affecting the performance. The system might run low on memory, the CPU might reach 100% utilization, and logs can provide the insights that you would need for that. Then you have the auditing of the logs. So logs record users' activities on a given system, and we want to know who logged in, what they did, so on and so forth. And then, of course, compliance. So logs can be a requirement to maintain compliance with relevant regulations. So we're going to go into log management on a Linux system right now, so we can see the practical of how this is actually used. All right, in Linux, logs are an essential part. I mean, they're an essential part of Windows as well. So logs are important. They're not the most exciting thing, but they're very, very important for us to at least be familiar with and learn how to navigate, because they provide a look into the system's operation, and reveal any issues that could potentially be happening, and errors, warnings, security alerts, any other innocuous events. I love that word, innocuous. All of these things can be found and discovered through logs. Most Linux distributions store the logs in the var log directory. So if you run a basic tree command, so sudo, so you want to run admin, and again, this is why you need to understand the basics of Linux. So I'm not going to break down why we use sudo, for example. So if you don't have a basic understanding of Linux, this is going to be one of those things that's an issue for you. So you would do tree, and then you do a tree command for the log directory, and then it basically breaks it down for you, and it goes through the entire thing and shows you. So these are all the different folders that are inside it, and then inside this folder there's this file, inside this folder there are these files, so on and so forth. So you get to see all the logs that are inside of the var log file. And inside of that, you can see the private log, you can see the SSD log, the VMware log. So all these things are very, very important in the context of a Linux computer. Then we have the various distributions that log daemons like the rsyslog, the syslog, and journal to manage, process, and store log events. So these are just based on the various distributions for handling logs. And then we have log types, so the system log, application log, and security logs. These are just, as the names imply, the system log applies to all the general health and operation of the system. Application applies to the specific applications on the system. And security is about security related events such as login and failed authentication attempts. Just in case somebody's trying to log into your system and they fail, that's a security issue that pops up. So when you want to manage logs on Linux, you need to consider a central location for the log, using a tool to filter and parse the logs, and setting up alerts for anything that is innocuous that happens. So configuring your system to log into a central location is very essential. This is where SIMs come into place, Security Information Event Managers, and we'll be looking at those in a little bit as well. So for our practical example, we're going to SSH into this machine as Maxine, and then we're going to run some commands here so we could see what can be done. So by now, the machine should have already been fully loaded, and it is loaded here. So I'm going to go into my attack box, and I'm going to log in as Maxine. So let's do that, and let's have some fun here. All right, we are logged in as Maxine. So let's do an analysis of the AU report, which I believe is the authentication report. And then what we want to do is we want to only look at the failed events of the AU report. So we do AU report, and then I could do summary, and it can show me the summary of the AU, and it says permission denied. So maybe we could run it with sudo AU report and enter the password for Maxine. And there we go. Here's our summary report for Maxine's computer. And it shows things like the changes in configuration, failed logins, 263 failed logins, holy crap. The number of users, terminals, host names, MAC events, failed syscalls. This is a machine that's been attacked to death here. So now what we want to do, instead of a summary, we're going to do sudo AU report, and then we're going to do the failed data to see what failed information shows up. So now we have all of the failed attempts at everything. And so failed authentications, failed logins, host names, executables. And so you notice how these things have significantly dropped in numbers because we're only looking at failed data and not the successful data. So if you go through the AU search message, user login, success, yes, and interpret it, it returns all the successful logins, while message user login success no returns all the failed logins. So message is followed by the message that we're interested in searching for. So user login, delete user, etc. Add group, user, change authority, delete group, change the ID, role assignment, role removal, and then success would be either a yes or a no, depending on what you're trying to search for. And interpret it converts the numeric entities, such as the UID, into text for us. So if we want to display the failed login attempts for root, we can pipe the output via grep. So it would be search, user login, success no, interpret, and then you do a pipe and you grep for the root user. So this is an example that we did for CT root, and then we see that there was 76 instances. So let's see right here, and we're gonna go look at some of these questions that we have. So using AU report, how many failed logins have occurred so far? And so we have that here, and failed logins right here are 263. So let's check that, and that is the right answer. So now we're going to use AU search to see how many failed logins are related to the username Mike. So we're going to use the same exact thing that we have here, and we're just going to count it for the username Mike. So let's check that out. Oh, I forgot to use sudo at the beginning of this, so I'm just going to do the whole thing. And then I'm just going to go at the very, very beginning of this and just type in sudo, just so I can get permission for AU search. All right, there it is. So we got the number right here. So 4. And the answer is going to be 4. Very good. So how many failed logins are related to the username root? So I'm going to press up on my keyboard. It's going to bring up the entire command that we had previously. And so the only thing that I'm going to do in this case is I'm just going to change the user from Mike to root, and then press enter, and that's going to give us 227. Holy cow. And there we go. Just like that, we were able to parse through some logs. Very, very basic. We didn't do much at all here. But I mean, we were able to just go through the AU report and AU search and some pretty interesting commands just to be able to pull up some decent information. So there it is for the log management on Linux. And I'm gonna terminate this machine right here so that I can go ahead and start up the Windows machine as our next machine. And we'll wait for that to load real quick, and then we'll run some log management on Microsoft Windows. In Windows, there's actually something called Windows Event Logs, and it's a graphic user interface that makes it a little bit easier to analyze logs and look for events, and they offer filtering options, and it's more user-friendly because of the fact that there's a graphic user interface. And it's fairly similar to what we just went through with Linux. So there's a system log, application logs, security logs, and forwarded event logs that are received, collected from tertiary computing environments, and they collect collated reports from multiple sources into a centralized file. And these are good for monitoring tasks and analyzing stuff in a networked environment where you would have to assemble data from a bunch of different endpoints or various places. So analyzing Windows logs allows us to do a lot of great things. So the location for Linux is varlog. For Windows logs, the location is the system root system32 log files. The format is syslog, and then there's event log for Windows. The logging levels: debug info, notice, warning, error, debug information, warning, error, critical, tools for viewing logs. These are command line tools, whereas Windows has a GUI, a graphic user interface called the Event Viewer, and it's more flexible and easier to parse on Linux. For Windows, it's user-friendly, more integrated with Windows, but for Linux, if you don't know command line, it's tough to use it, and it's not really centralized, meaning being able to collect and collate multiple endpoints into one. For Windows, it seems to be that it's difficult to troubleshoot, although I haven't really had much difficulty with it. So I guess if you're looking for disadvantages, that would be the disadvantage. So Windows makes it possible to audit various aspects, and you can have an audit policy. So again, these are one of those things that it's a point and click. So account logon events, management, privilege use, directory service, policy change, system events, all of these things are point and click types of options that you can choose inside a Windows machine to set your policy. And there's group policy objects, but then there's also audit policy objects and various other policy objects. So this is what the event viewer looks like for Windows here. And I have a feeling we're about to use it and get some good stuff going on. One key thing that is really important to understand is that when you're going through Windows logs, event IDs are really important. So a lot of times when you get asked a question to search for an event ID, and it's actually not just Windows. I think across all of the machines and all of the distributions, operating systems, event IDs are a big deal. When you use Splunk or any of the SIMs, you'll be searching for events based on their IDs. Because more often than not, the verbiage is different. So failed logon or attempted logon or all those specific terms that are assigned to things are sometimes different than just looking at something based on the event ID and then pulling up that information based on the event ID. So you're going to be using event IDs very more often than using the actual text description of what may have happened. So for this, we're going to now log into our Windows machine, and I already started it, so it doesn't offer me a second window. So what we're going to do is we're going to actually RDP into the machine, and for that I'm actually going to go into full screen mode so that it's a little bit more it's a little bit easier to manage this, and I'm going to shrink this down, and we're going to go here. So my favorite one is xfreeRDP, and the username in this case is going to be, let's do this real quick. So this is the command, xfreeRDP /u dawn /p audit me, and then /v, and then the IP address that you're gonna RDP into, and just like that. Do you trust this? Yes, I do. And there you go. We got our remote desktop session into our Windows machine. So what's the question here? The first question is, what is the event ID for a failed login attempt? So this one's kind of easy. Failed login attempt is already here for us. So 4625 is going to be that. So let's test that out and make sure that's right. That is right. How many failed login attempts do you have under the security events? So let's go and look at our event viewer, which is on our desktop here. And we're going to search for the event ID of 4625. All right, so security logs are going to be under Windows logs, and we'll click on security. And what we're going to do is we're going to wait for it to load, which I'm pretty sure is going to take a bit of a minute because we're in a virtual machine and we're RDPing into another virtual machine. And if you can tell right here, there's 5,300 events that need to populate before I can implement my search filter. So I'm going to wait for this to load, and then I'll run the search filter for the event ID, and then we'll see how many results we get. All right, so we got all of our events here. So let's zoom in a little bit. We're going to click on filter current log right here, and then you see how it says all event IDs. I'm just going to go in here and I'm going to type in the event ID, which is for the failed thing, which was what? What's going on here? Let's zoom out a little bit. 4625 is the one that we're gonna filter for. So 4625, and turn that. And we have 2. So let's see if 2 is the right answer. And it is. Great. So how many failed login attempts took place in 2021? And we just have 1. So I think that's it. That seems pretty simple. Yeah, there you go. 1. And that was it. Very, very simple stuff. So if we wanted to search for other things, we could potentially search for other things. So while we're here, why not? So let's look at 4624, which is a successful logon. So we'll just go back into our filter, and then it's going to be 4624 instead of 4625. And look at that. You have 363 events versus 2 events. And these are all the successful logons that took place on this computer. So out of 5,000 something events, 363 of them had to do with successful logons. So pretty simple, right? Fairly easy, intuitive to use when you are going through Windows Event Viewer because of the fact that it has that filtering system and it has a GUI and all that good stuff. So that was it. And I think I can actually just close this out and close this out. And now we can move on to the monitoring task so that we can kind of, just go through basically understanding what this is. All right, information systems need to be monitored. So this is kind of a simple idea here. So reasons for monitoring. So troubleshooting and maintaining as things happen instead of waiting for a really bad situation to take place and then going and trying to figure it out and fix it. If you're monitoring regularly, you can troubleshoot and maintain in real time, ensuring minimum downtime, so the least amount of downtime possible. Optimizing performance to make sure that performance is always good and it's running smoothly and faster, maybe even if you could do it. Preventing any failures, so denial of service attacks or just failures in the system for whatever reason, crashing, any of those things. This is going to all be done through monitoring. And then you have security risk mitigation. So if there's any kind of security risk, if you're actually if you're monitoring, then you can mitigate potential security risks quickly before any damage is done. And of course, there's compliance and regulation. So just making sure that you're actually compliant and adhering to the regulatory environment that your company is in. Logging is a form of data collection and record keeping activity. Monitoring those logs is the activity of, looking at the logs, monitoring the logs. So both of them involve in-depth analysis. The key difference is that the primary function of logging is a historical account of events, and it's essential for diagnostics, forensics, and compliance. Monitoring is real time. You're looking at it in a real-time environment, whereas logs, you're looking at what happened previously and trying to figure out what went down. So this is kind of just a little T-chart, not a T-chart. What kind of chart is this? Whatever, a table. There you go. This is a table. This is a table that compares the difference between logging and monitoring, the primary functions, error detection, process, typical uses, timeline and notification, inspection, key objectives, so on and so forth. So as long as you understand that this one is historical view and you're looking at what happened in the past, it could be as early or as recent as what happened earlier today. And then monitoring is what's happening right now. So real time, live. So the effective information system offers both. You need to have both. And to ensure technological development, resilience, and integrity, you need to do both of those things. So that is it for our monitoring task. And so I've done several videos on SIM, and there's a compilation video that I think is going to be launched prior to this video coming out. So you're probably going to get the the big ass compilation video. And you know what? While we're here, we might as well just go check it out. So it's going to be inside of our contents of the channel, and it's been scheduled to drop. So let's see, where is it? Everything you need to know about Sims in 3.5 hours. It's a compilation video, and it's going to come out on April 3rd, which is tomorrow at 8:30 a.m. So that is for sure going to come out before this video comes out. So Sim Basics is what you're going to get right now, but I would recommend just going into that big compilation video just so you can get a more in-depth view of what a sim is. And then we actually use a few really popular sims to do some case studies and like live detection and remediation exercises. So let's just look at sim basics real quick. All right, this graphic is pretty good at explaining what a SIM does. So this is a web portal or a website. This is a server, and then this is a firewall. All of these guys generate their own activity logs. And so all of these logs come into one central location, and they get organized and parsed, and then the security analyst can view them all in one place. And what's really cool about it is that a lot of SIMs will actually give you the red flags without you having to put the dots, connect the dots, and try to figure out what just went down. The SIM will say, hey, you know what, this kind of seems fishy. This IP address has been trying to get into the website and the web server, and there was several times that it tried to go through the firewall, and it'll give you a lot of different perspectives and views that you as the security analyst may not necessarily notice, because we're human beings. We're not as good as a computer and artificial intelligence. And Sims are, before AI became a big deal, Sims was kind of an AI software that was doing a lot of the analysis and parsing for us. And then you can even do an automated response and automated remediation system, which is called a SOAR, that takes all of the logs from a SIM and does automated remediations for you. So a SIM is a set of integrated management technologies that provide a holistic view of organizations' information security. Jesus, that's so boring. They collect and aggregate log data generated through the IT infrastructure from network devices, systems, and applications. Then the software identifies and categorizes incidents and analyzes them, and it can be beneficial for identifying issues such as security threats, compromised systems, malicious activities, and it can even help with incident response actions. So collect data from the different endpoints, aggregate the data, discover and detect the threats, and identify breaches and investigate any alerts that pop up. The responsibilities are data aggregation, correlation analysis, alerting and reporting, forensic analysis, threat intelligence feeds, automation and orchestration, and a lot of other things, honestly. Like Splunk is just a robust, sophisticated, badass tool. So if you know how to use Splunk, then you are going to honestly be very, very competitive in the marketplace. In the video that we made, we actually did the video for Wazoo. So there is inside of the video that I just shared with you, that compilation for SIM, Wazoo demonstration is in there, Splunk demonstration is in there, and we use both of those tools to actually do some real-time exercises so you can see how they both work and how to navigate those specific tools. So that was it for our auditing and monitoring room. So not too bad. It was pretty good, and I think we made some pretty good time with this as well. So that is it. So let's see what the conclusion here says real quick. So this is a really good review of basically what we just talked about. So logging is going to be monitored and audited. Recording the system activities, real-time data and report collection, and then auditing everything that just happened between the monitoring and the logging. The main functions are as such, the result identification is as such, process flow, the uses, and the key roles of these specific activities. And as a security engineer and a security analyst, you're going to be doing this all the time. So it's not the most exciting part of it. Maybe it is for you. For me, it's not. I like pen testing. I like ethical hacking. I like the offensive security side of things. But this is very, very important. This pays really good money. Like when you are a security engineers make multiple six figures. And this is not a bad way to earn a living if all you got to do is worry about going through SIMs and so on and so forth. Granted, if something really does happen, you need to be able to respond effectively and do proper incident handling, so on and so forth. So when it does hit the fan, they are going to come to you for the solutions and the responses. But apart from that, I mean, it's a pretty solid gig if you want to go into security engineering, and I do recommend that you definitely check it out. So that was it for our auditing and monitoring room. If you got any value from this room, or if you learned anything from what we talked about, I do encourage you to go to our channel. I mean, you're already on the channel watching this, but subscribe to the channel. So Hank Hackerson at Hank Hacks Hackers. Like, subscribe, turn on the notification bell, all that good stuff, so that you get notified the next time a video comes out, like the videos that we have already scheduled for this upcoming week, and then this video is going to get scheduled out. So I try to, pretty consistently post a bunch of stuff so that our community is well informed and well educated and well equipped. So we would love to see you in the community, and I would love to see you in the comment section just so I can answer your questions and have some chats with you guys and see if there's any way that I can help you. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video. Later.